Hi guys, a very good morning everyone. Very good morning. Yes guys, so all GATE 2024 champions, all electronics and electrical champion. Yes, this is the next revision marathon, mega marathon for you, control system. So Monday we revised up digital electronics. Yesterday you all with Sanjay Rathi sir revised up analog circuits, and today we'll be having the revision for control systems in one shot. The revision for control systems in one shot. Very good morning everyone. Yes, good morning all. Quickly keep joining and share the session to all your friends. All right, so it's a slight delay to the session, but I was at a point neither I can take my vehicle forward nor backward. I was stuck so badly, so unfortunately it got delayed. All right, very morning everyone. Chalo, come on quickly. Okay, let everybody join quickly, and let's begin up the control system revision. But it's not a problem, because ultimately, whether even it's slight late, but not a problem. We'll extend it till late. We'll learn, whatever we are here to learn. So that's not a big worry. Okay, we'll be learning whatever actually we want to learn. So that's not a worry for us. Yes, all good morning. So all set to start control system. Come on. All of you set to start control system. Quickly let me know. All of you set to start control system. Come on, quickly. Yes, if all set. All set. Come on, chalo. Show me the ready, steady and go. So that we all begin up. All right. So if you are really ready, yes, come on, let's get started. But the readiness should also be with your attendance. The readiness should also be with your attendance. So attendance is just nothing but hit the like button so that you put your attendance, and the ratio is very poor as of now. Okay. So come on, hit the like button. Let's get started with your attendance. That is the like button, so that I see how many of you are actually attending, not just watching. Okay, so guys, let's get started. This is a brief introduction. Let's get moving ahead. And this is what is the revision marathon sessions going on the BYJU'S Exam Prep YouTube channel. Okay, to cover up the subjects in different subjects, like each and every subject in one shot. And started from Monday, 8th of January. Monday I covered digital. Yesterday was analog circuits. Okay, yesterday I covered digital. Monday I covered digital. Yesterday analog circuits by Sanjay Rathi sir, and here we are today to cover up control system. This is what here today. Okay, tomorrow then you have another important subject, network theory, coming up. Another important subject, network theory, coming up. Okay, and then etc. Schedule has been posted. Okay, once this is over, we'll post the future schedule also. Don't worry. Okay. Every day with particular subject you have the daily quiz also. Hope you are attempting the daily quiz. So like today evening you will have the daily quiz for control system also. Okay, this daily quiz is on the BYJU'S Exam Prep app. This daily quiz is on the BYJU'S Exam Prep app. Okay, so whatever we discuss in a particular day, you can entirely solve a quiz. And that's what I told you, 3-step procedure if you want to make your revision perfect. And even if you have not done much in the past, still these revision sessions can help you. Number 1 is the daily class, daily marathon class. Number 2 is the daily quiz, and number 3, PYQs of that subject. This much at least if you target, this is good for last month. This much is good for the last month. Okay, of course, along with some mock test and all. Okay, digital electronics PDF has been uploaded in my Telegram group. Okay, so guys, in case you're looking for any sort of counseling with respect to GATE examination, engineering services examination, BARC examination, okay, last moment tips, you want any one-to-one counseling session, okay, for any particular doubts you have, okay, you can book your one-to-one counseling session. So like this is the today's session. Okay, just go to the YouTube today's session and just go to the description. Okay, this is a screenshot, earlier screenshot. Just go to the description. Okay, in the description there is a link. Okay, crack gate in single attempt, and you can book 1-to-1 counseling session on this app, on this link. Okay, you'll be able to find this link here. Okay, you can go to the link, you can book your free 1-to-1 counseling session to get all your doubts rectified here. Okay, to get all your doubts rectified. Okay, so that's what it is in the description of the same video, today's video. Okay, it is there in Telegram. I have uploaded, Manohar, check it out. And guys, the big update also for you, the general aptitude revision marathon, this time exclusively on the BYJU'S exam prep app. Of course, it is free. By app, I don't mean you have to pay anything. It's a free event on the app. Okay, but the complete revision of general aptitude to make you target 15 out of 15 in general aptitude exclusively on the BYJU'S exam prep app. Okay, 13th and 14th January. That's going to be on the 13th and the 14th of January. Right, 13th, and that is coming Saturday and Sunday. Just, in 2-3 days. Saturday and Sunday, this Saturday and Sunday, 13th and 14th January. Okay, the general aptitude revision marathon will be there. Okay, the general aptitude revision marathon will be there. Okay, chalo. Aega, Jitendra. That will be there. Yes, Jashwant, definitely. Okay. Harsh, no problem. We can increase the confidence by these 2 days. Don't worry. Okay. Okay. Any of them, Gotham. Any of the options. Theek hai ji. Chalo guys, what happened? The attendance is not even 100 today. So that's what is the story of GATE aspirants also. Okay. These many fill form. These many go to appear, these many qualify, these many are the toppers. So eventually those who are staying till end, they are the topper zone. Okay, they are the topper zone. They are always at the topper zone. Chalo. So let's get started, and let's get started with the first order control system here. Let us get started first of all with the quick review of the first order control system. Let me see how many attendance put till now. How many of you are actually attentive here? Oh guys, attendance is still very low. So do not forget, let's hit the like button. Let's put the attendance. Okay, chalo. So first order control system, like I have taken a prototype system considering unity feedback. Okay, system having the forward path gain 1/ST, and unity feedback is considered. So when you calculate the transfer function C by R for this, when you're going to calculate the transfer function, that is the C by R for this. Okay, we know that for closed loop system, we solve it as G divided by 1 plus GH, where G is the forward path, H is the feedback path. Okay, so now C by R is going to be equal to G, which is 1/ST divided by 1/1 plus ST. HS is 1 here. Simplifying, you get 1/1 plus ST. Now look into the denominator. Okay, what is the highest power of S in the denominator? Okay, the highest power of S in the denominator is 1, and this is a first order control system. Okay, let's first order control system. We'll have a quick review. Okay, so the first order control system is given by the transfer function, that is 1/1 plus ST. Okay, now since the transfer function here, as I told you, okay, transfer function we have obtained as 1/1 plus ST. Okay, what is T? Uski baat bhi karte jayenge. Okay, so now dear, if transfer function is known to us, what is the impulse response? What is the impulse response? So very simply, you should all be able to recall that impulse response and transfer function makes the Laplace transform pair. Impulse response and transfer function makes the Laplace transform pair, right? So if the transfer function is 1/1 plus ST, I can also rearrange it like, let's take T common. So this becomes S plus 1 by T in the denominator. And now you have 1/S plus A, 1/S plus A. So whose Laplace transform is 1/S plus A? E power minus AT, na? E power minus AT. So what's going to be the impulse response then? The impulse response becomes 1/T. 1/S plus A corresponds to E power minus AT, where what is the value of A? 1/T. What is the value of A is 1/T. So 1/T e raised to the power minus T by T. 1/T e raised to the power minus T by T. That is the impulse response. Okay, yeah, this is going to be a very useful calculation coming up many places. E power minus AT has the Laplace transform 1/S plus A. Okay, so the impulse response is given by 1/T e power minus T by T, and then accordingly, what is the step response? Okay, step response is the response. Okay, it is the response, or we can say it is the output when you apply the input RT equal to UT. That is the step input. Okay, the response of the system when you apply what? When you apply the step input. Okay, when you apply the step input. So what is going to be the response when you apply the step input? Okay, what is going to be the response when you apply the step input? So, guys, calculations and derivations not needed here. Okay, RT equal to UT. UT is 1 for t greater than equal to 0. Then the response output that you obtain, okay, after solving with Laplace transform tool, dot output that you obtained is given by 1 minus e raised to the power minus t by t ut. Okay, the output that you obtain is given by 1 minus e power minus t by t ut, or simply we know that in, anyways in control system we talk about causal systems. Okay, okay, so you can also call it as 1 minus e power minus t by t. Okay, so response of the system will be given by 1 minus e power minus t by t. Okay, now when you sketch it up, okay, when you sketch it up, there are the two parts here basically. Okay, whatever are the important points, us pe thoda time spend karte jayenge. Okay, so you have the response as 1 minus e power minus t by t. Now if you talk about e power minus t by t, okay, if you talk about e power minus t by t, you must be knowing that e power minus t by t, that is like e power at, that is an exponentially decreasing term. Okay, whenever you need to plot any e power minus at, that is an exponentially decreasing term. Okay, that is an exponential decreasing term. Correct, Gautam, just like the attendance of the students. Okay, so see how far rapidly it falls. Okay, but the students, there's those who are going to reach the steady state. Na, abhi steady state ki baat karenge. Okay, the students, those who are going to reach the steady state, they will be the cream, they will be the rankers. Now you decide how long your journey will be, whether you want to reach, okay, your result state or not, steady state or not. Okay, so this is an exponentially decreasing function. There is a time dependent term here, but that is going to die out after some time. Okay, it is present for initial time, but as the time progresses, its effect diminishes, its effect becomes negligible. So this is a type of term which is not permanent. It is there in the system, but is not there is a permanent. Okay, so behavior of the system that is coming due to this term is known as the initial behavior of the system, that is known as the transient behavior of the system. Okay, now what is going to be the final waveform? The final waveform the simple hai na, this is e power minus 80 na, so I take minus e power minus 80. Minus means amplitude folding. Okay, amplitude, all values of amplitude will be in negative side now, and then plus 1, and then plus 1. Isko plus 1. Amplitude uplift, you'll get something like this, isn't it? You'll get something like this. Okay, you'll get something like this, and here it is. It's gonna be something like this. Maybe it's not perfectly visible. I'll just highlight it little better. This is how it is. Okay. Okay, ji. This is how it looks like. Okay. Now, I have sketched along with the input as well. So what is this? This is the input waveform, this yellow one that you're able to see. Okay, if this is the input applied to the system, where input is equal to 1. Okay, unit step, RT equal to 1 for t greater than 0. Of course, everything is for t greater than 0. Okay, then this is the response obtained by the system. That is known as the CT. Okay, which is 1 minus e raised to the power minus t by t, showing overdamped type of waveform. The first order response is always overdamped. For second order, you may have underdamped, overdamped, critically damped, exponentially increasing. Multiple things can be occurring there. Okay, so the response 1 minus e power minus t by t. Okay, and that is the overdamped waveform. Okay, so the output is exponentially rising here. Acha. Output is exponentially rising. Acha, now first of all, there are two things here. As I told you, the response due to this particular term, okay, is the initial response. Okay, so that means initially the waveform, the initially output is increasing, exponentially increasing, but finally it is going to achieve some value. What value? Finally it is going to achieve the value which is equal to 1. Why? Because आप यहाँ पे देख भी सकते हो, when you put limit t tending to infinity CT, when you put limit t tending to infinity, so what is going to be e power minus infinity? E power minus infinity is known as 0. Okay, so what you are left with is only 1. Okay, it is only 1. Okay, so the value of the response for t tending to infinity, that is what is known as the steady state value. That is what is known as the steady state value. Okay, the value of the system, the response of the system in steady state, when time becomes large. When time becomes large. Okay, so we know that initially the response is exponentially increasing and eventually it is going to achieve the steady state value equal to 1. Okay, whenever you want to study the behavior of any system, it will always be broken into two parts. One of them is the transient part, which represents, okay, the initial behavior of the system, and one of the part is the final behavior of the system, which is the steady state part. Okay, the response attained by the system when time becomes very large. Okay, when you leave the system for a larger particular time. Correct? For a larger time. Okay, now what is the significance of both of them? Okay, what is the significance of both of them? As I told you, transient means initial behavior. That is not the permanent effect in the system. Okay, and why does it occur? Why does it occur? So very simple. The output of any control system cannot follow sudden changes in the input. So say for example, we are studying first order right now. Na? We are studying first order system right now. One very simple example of first order system is a series RC circuit. A very simple example of a first order circuit is series RC circuit. You apply the input here RT. Okay, that is the input voltage, and let's say you're calculating the output voltage across the capacitor. Okay, that is V0T. Okay, and let me call this input as VIT. Okay, the transfer function that you obtain for the RC circuit V0 upon Vi in S domain is 1 upon 1 plus SRC. That's a first order system. Okay, now let's say your target is to charge the capacitor to 1 volt. To charge the capacitor to 1 volt, you apply a DC of 1 volt here. Okay, when you apply the DC of 1 volt here, now you know the property of capacitors, right? Okay, you know the property of capacitor. Okay, will it charge immediately? Okay, will it apply? Okay, will it be able to accept that sudden voltage change? No, it will be charging to the 1 volt, but something like this, you have studied this in the fundamental of networks as well. It charges slowly and eventually rises to the 1. Okay, it cannot accept the sudden changes in the voltage across it. Okay, so you know, not only capacitor example, all the systems in the world, they need some time to respond. Okay, nothing can happen in zero time. Nothing can happen in zero time. So output of any system cannot follow sudden changes in the input. Input you applied abruptly, but output needs some time to settle. Okay, so before it settles, there is the initial part, and that is why we call it as transient part. The transients are usually observed. Okay, you can call it as a delay in the system also. Okay, the transient part also gives an idea about the nature of the response. Like I told you here, the response is overdamped. Okay, and also the speed. The transient will also give an idea about the speed of the control system. How it gives an idea about the speed of the control system? Simple reason is, ultimately we want the capacitor to be charged to 1 volt. Okay, that means ultimately we want the final output to be 1. Final output equal to 1 when the transient is over, right? Final output 1 is the steady state value. When will you get the steady state value? When the transient part, when the initial part is over. Okay, so I can say that smaller the transient, okay, higher will be the speed of the system. जितना छोटा transient period होगा, छोटा transient period का मतलब क्या है? The system achieves steady state faster. It is a faster system. The transient also tells what? The nature of the response and the speed of the control system. But how actually that speed is measured? What timing parameter to be applied? उस पे भी आ जाते हैं. Okay, then I told you the next part is the steady state part. We will have a detailed discussion on steady state error as well. Okay. Yes, the session for maths will be coming up next week. Even a strategy to secure full marks in maths and the maths marathon will be also coming up. Okay. So right now, tomorrow there is a session on aptitude. Okay, tomorrow on YouTube there is the aptitude strategy session. Okay, how to secure 15 out of 15 in aptitude. That is tomorrow night. Okay. So as I told you, steady state value, it is the response of the system when the time becomes large. That is for t tending to infinity. And this is going to talk about the accuracy of the system. This is going to talk about the accuracy of the system. Now, what do I mean by accuracy here? Then we will go to steady state errors also. What do we mean by accuracy here, dear? See, itni si baat yaad rakhna. What do we mean by accuracy here? You are telling that, okay, you want the capacitor to charge to 1 volt. Okay. It takes a particular time to charge to 1 volt. So let's say I leave the system ideally for infinite time. I give the system large amount of time. After giving the system large amount of time, I expect that the capacitor should be charged to 1 volt. Now suppose that you have given the system enough time. Suppose that you have given the system enough time. Okay, but eventually it finally stops at the value 0.9 volt. You wanted to charge the capacitor to 1 volt, but finally it stops at 0.9 volt. What does it mean? That even you leave the system for a large amount of time, you wait till steady state, but even in the steady state, it does not achieve. Even in the steady state, it does not achieve the desired value. It does not achieve the desired performance. it does not achieve the desired performance. That means system has some error. That means the system has some error in the steady state, and that is known as steady state error. Okay, that is known as steady state error. If the steady state value does not match with the desired value, then we say that the system has some steady state error. Important parameter, we will learn this separately. The system has some steady state error. Okay, so how do you know whether steady state error is there or not? You have to see what is the steady state value of the output and whether does it match with the desired value. That is why the steady state value is giving the idea about accuracy, how accurate the system is. Okay, whether it is perfectly accurate or does it have some error? Okay, does it have some steady state error? Okay, now as we know that, look into this waveform, as we know that the output is exponentially increasing, 1 minus e power minus t by t, correct? The output is given by 1 minus e power minus t by t. Let me write it here once again. I think this is not clearly printed. Okay, yeah, so but anyways, eventually we know that the output is given by 1 minus e power minus t by t. That means the output of this first order system is exponentially rising. The output is what? The output is exponentially rising. Coming to that also, settling time pe bhi aa raha hai, don't worry. Okay, so output is exponentially rising. Okay, exponential function. What is the time taken by the system, okay, to reach the first exponential part, to reach the first exponential power? Okay, so what is the final value? It is 1. Okay, what is the final value? It is the 1. Okay. Okay, this is the output of the system, 1 minus e power minus t by t. At what time it reaches the 1 minus e inverse mark? Okay, the first exponential power, okay, of the final value. 1 minus e inverse of the final value. Final value is 1. Whatever is the final value I put here. Okay, 1 minus e inverse, the first exponential factor, okay, times the final value. So ye kitna ho gaya, dear? It's just comparing left and right side. You get t by t equal to 1. At what time does it happen? It happens at the time which is given by capital T. So what is the capital T? Initially I did not tell you. Okay, now what is that capital T? It is a parameter. Okay, look into this. It is the parameter T which is seen here. It is this parameter T which is seen here. Okay, such that at this particular parameter the output becomes how much? 1 minus E inverse. Achha, when you calculate 1 minus E inverse, na, this is approximately 0.632. So at this particular time, output reaches the mark 0.632. 0.632. Okay, and that is known as the time constant of the system. That is what is known as the time constant of the system. Okay, the time constant, the time taken to reach, okay, the time taken by the step response to reach 63% of the final value, approximately 63%, or that is 1 minus E inverse of the final value. That is what is known as the time constant of the system. Okay, so the capital T here is simply known as the time constant of the system. Okay, like what is the time constant of RC circuit? That you know from the networks also. Okay, what is the time constant? It is 1 upon 1 plus SRC. Okay, T is equal to RC, and that is known as the time constant. That is known as the time constant. Okay. Now, dear, a small calculations can be done. What I'm trying to tell you that at T equal to T, what is the value of the output? What is the value of the output? 1 minus E inverse, and that is 0.632. Okay, now let me move in multiples of time constant. Okay, I will just now be moving in the multiples of time constant. So in the multiples of time constant, I have 1 minus e ki power minus 2. Okay, 1 minus e ki power minus 2. That will be approximately 0.86. You try with your calculator. Okay, at T equal to 3T, okay, the output becomes 1 minus e ki power minus 3. That is 0.95. So as the time progresses, I am going to slowly approach the desired value. I am slowly approaching the final value. Okay, when I take the T equal to 4T, okay, the output CT is given by 1 minus e raised to the power minus 4. 1 minus e raised to the power minus 4 will be 0.98 approximately. Okay, when you take 5T, okay, the output is going to be 1 minus e power minus 5, that is 0.99. Okay, but if I ask you specifically, what is the time at which the output finally becomes equal to 1? What is the time at which finally output exactly equal to 1? Okay, exactly equal to 1. Okay, exactly equal to 1. And that time is known as T tending to infinity. That will be infinity only. Okay, because 1 minus e power minus infinity, that only will perfectly equal to 0. Okay, so at t tending to infinity, Ct, okay, will be tending to 1. Okay, that will be the perfect value. So now if I ask you, we know that the steady state value, is 1. So if I ask you, what is the time taken by the system to reach perfect steady state, to reach the exact steady state value? And that time is infinity. That time is undefined. We don't know what is infinity value. Na? That is an undefined parameter basically. Okay, so that time is very large. That is infinity. Okay, so we can't define, okay, agar if I go by this way, I can't define the exact time, or I can't put a value of time where the system reaches the steady state. So what do? I do approximation. I will do approximation. Okay, I don't wait till 1. Okay, my final steady state value is 1, but I take some tolerance, I take some error, and I say that suppose even if my output reaches 98%, this is one of the standard way, I'll take other ways also. Let us say, whenever my output reaches up to 98% also, that means 2% of error is there. But even if the output reaches 98%, good enough, na? Okay, I will say that the system has achieved the steady state. I will assume that the system has achieved the steady state rather than waiting for infinite time. So I will assume that the system has achieved the steady state here. Okay, the time at which we achieve this steady state will be the settling time, will be known as what? Settling time. The time required by the step response to reach within a specified percentage of the final value. The time required by the step response to reach within a specified percentage of the final value. Okay, that is known as the settling time. That is what known as the settling time. And commonly used values are 95. I told you the time taken to reach within a specified percentage. What specified percentage? You can specify your own. Okay, if I talk about 95% criteria, okay, 95 or 98 are the most commonly used value. Okay, it is 3t. If I say 98% criteria, okay, then the settling time is 4t. You may also call 99% criteria. Then the settling time will be 5t. That depends. You can specify your own percentage. Acha, if nothing is specified, by default 98%. If nothing is specified, to by default 98%. Now, when you are taking 95% criteria, this also means that you are accepting a 5% error. Okay, a 5% tolerance. Okay, tolerance, yeah, you can also call it as error band. Okay, you are accepting a 5% error. Okay, or say you are ready to accept a 2% error. That means you are waiting for the output to become 99%. That is 98% or 98% criteria. Similarly, 99% means 1% tolerance you are taking. Okay. Chalo. So the commonly used by default value, if nothing is mentioned in the question, you will take it as the 98%. Okay. Now, as I told you, let's take with that 98%. Okay. So let's take this 4t parameter. Let us talk about this 4t parameter, and let me draw another line here. Okay, this is the final value 1. This is the 0.63 time constant, and this is the mark where I reach 0.98. Okay, the time at which I reach the 0.98, that is the 4t. That is the settling time as per the 98% criteria. Okay. Now that's what I told you. Why I am defining the time settling time? Because if I define the settling time, I will now assume that the steady state has arrived, because actual steady state takes infinite time. So we are taking a 2% error. Okay, this is 2% error. ये लिखा भी है 0.02. ये जो दिख रहा है ना आपको, ये deviation. This is what is the 2% error that I am accepting. Okay, but okay, it's a very small error, 2%. I am ready to accept it. But at this point, I will assume my steady state has arrived. So anything beyond this, it is a steady state period. Steady state part बोलते हैं इसको. Okay, basically let me call it as the steady state part. Okay, and anything before it, that is the transient part. Okay, so settling time is also a boundary between transient and steady state. You can say that the settling time is also, okay, the settling time is like also a boundary. It is also like a boundary between transient and steady state. Clear? It is also like a boundary between the transient and the steady state. Okay. So as soon as you reach the settling time value, you assume that the steady state part has arrived. Okay, ji, all clear? Okay. Okay. Acha, now if I ask you a question here, suppose if I ask you a question here, right? There are two transfer functions. There are two systems given to you. Suppose 1 upon s plus 3. Yeah, 1 upon s plus 2 लिख दिया मैंने. And there is another system given to you as 1 upon s plus 4. Which of them is faster? Okay, which of them is a faster system? So what do you logically now mean by a faster system? Okay, logically now what do you mean by the faster system? A system is faster if it reaches the steady state quickly. जो जल्दी steady state पे पहुंचेगा, okay, वो ज़्यादा faster होगा. So if it reaches the steady state quickly, okay, now when do you reach the steady state? Faster का मतलब है the system which reaches steady state quickly. Okay, when do you reach the steady state? At the settling time. Okay, settling time, let's assume 4t value. So settling time should be smaller. Settling time should be smaller. Okay, settling time is 4t, so that means the time constant should be smaller. 4 to constant hai na? You should have the system whose time constant is lower and such a system is faster. Okay, so now what is the time constant here? Acha dekho, normally, okay, you have the habit of, normally, you have the habit of writing 1 upon 1 plus st. Okay, so t is the time constant. Correct. Many a times the transfer function may not be given in the time constant standard form. It is given in 1 upon s plus a form. You can convert, but I will give you the fixed result. A common 1 plus s by a. Okay, now what is the time constant? Now what is the time constant? Ab directly bol dijiye na. Now what is the time constant here? That is 1 plus st and t is 1 by a here. What is the time constant t here? 1 by a. Okay. So directly aap isko yaad rakhna, it is useful for the future discussion also. Okay, so here what's going to be the time constant? Okay, 1 by 2. Okay, that is 0.5 seconds. What is the time constant of this system? 1 by 4. 0.25 seconds. Okay, so of course t2 is less than t1. Okay, which is faster? Okay, the second system is faster. The second system is faster. Okay, chalo. Okay, the second one is faster. T2 is less than T1. The second one is faster. No doubt. Chalo, clear. Now next. The next thing for first order system you need to discuss is the rise time. Okay, and we know that for first order we have got the overdamped waveform. Okay, so for overdamped it is defined as what? For overdamped it is defined as the time taken by the step response. The time taken by the step response to change from 10% to 90%. The time taken by the step response to change from 10% to 90% of the final value. 10% to 90% of the final value. Okay, so have a look into this waveform. Okay, the exponentially increasing overdamped waveform, that is the final response of first order system. Okay, it rises from 0. Now look into this particular moment. Okay, look into this moment. Okay, let us say this is the time t1 when the output becomes 10% of the final value. Final value is 1, so 10% is 0.1. Okay, 10% is 0.1. Correct? Now, let us say this is some time t2. Let us say this is some time t2 where the output becomes 90%. Okay, 90%, 0.9. Okay, now the time taken for the output to change from 10% to 90%. What is the time taken? It is from t1 to t2. Okay, that means it is t2 minus t1. What is the time taken? T2 minus t1, and that is known as the rise time. The time gap between these, it's mentioned here also. That is known as the rise time. Okay, now how to calculate t1, t2? You know the formula. Okay, you know what is the formula? Ct is 1 minus e power minus t by t. Okay, once I will put 0.1, once I will put 0.9, I will calculate t1, t2, I will subtract and let's write down the value. Okay, no derivations required. Rise time is going to turn up to be, network में भी पढ़ा होगा आपने यार, 2.2 RC. Same thing, 2.2 T, approximately 2.2 T. Okay, for first order RC circuit 2.2 RC, here it is 2.2 T. Here this is known as what? The 2.2 T. The rise time is known as the 2.2 T, correct? 2.2 T, done. Okay, so this is the next parameter that you should remember. Okay, that is the next parameter that you are going to remember here. Okay, now let's quickly have some insights about second order system as well. Okay, second order system. Now let me be honest, from first order, numericals are not that important, but just to start up with the momentum, I started with first order. Some conceptual points are important, but numericals first order से बहुत rarely आता है. Even if it is there some time constant and all. No, don't know Ashwin. ये overdamped है Vignesh, that is the overdamped rise time only. चलो देखते. No, Krishna, maybe not, because that's not important for gate. But I'll see at the end. Okay, let me cover up the important topics first. For ESC, sensitivity is important. For gate, it is very least important. But ESC के लिए important होता है वो. ठीक है. चलो second order systems. Okay, second order system. नहीं, it's not 90%. I defined the definition. अंदर ना 10% to 90%. Okay. चलिए. Now second order system. Now, okay, I've again taken a prototype standard second order system. Having the forward path gain omega n square upon s plus 2 zeta omega n. We'll understand what is zeta omega n after some time. Okay. And, connected in unity feedback. So what's going to be the C by R here? Once again, when you calculate C by R, G upon 1 plus GH, so omega n square upon s plus 2 zeta omega n divided by 1 plus omega n square upon s plus 2 zeta omega n. What do you eventually get? You get, on solving, omega n square divided by s square plus 2 zeta omega n s plus omega n square. Okay. Plus zeta s square plus 2 zeta omega n s plus omega n square. Okay. Now, first of all, okay, what are the poles of this system? What are the poles of this system? Tell me quickly, write down in a moment. Write down the location of poles, dear. Okay. Tell me. Chalo. So let's talk about the poles. Let's talk about the response of the system. Let's talk about all the other parameters again. Okay, the poles of the system. Again, just the quadratic equation I'll get from the denominator, s square plus 2 zeta omega n s plus omega n square 0. Solving which I'll be getting s equal to minus zeta omega n plus minus j omega n under root 1 minus zeta square. Here this particular factor, okay, zeta omega n will be named as alpha. Okay, and omega n under root 1 minus zeta square will be named as the damped frequency omega d, and the poles are also written in the form of minus alpha plus minus j omega d. It is also written in the form of minus alpha plus minus j omega d, or minus zeta omega n plus minus j omega n under root 1 minus zeta square. Okay, so if I come to this particular picture, have a look into it. Okay, let us say this is minus alpha, positive imaginary part plus j omega d, and this is minus alpha minus j omega d. Okay, minus j omega d. Acha ji. Okay. Now, what is the distance of any of them with respect to the origin? Okay, what is the distance of any of the pole with respect to origin? So, अगर आप देखोगे, how do you calculate the distance x comma y with origin? Under root x square plus y square. Okay, so under root of alpha square plus omega d square. When you solve the under root of alpha square plus omega d square, you get omega n. Okay, so omega n also represents the distance of the pole with respect to origin. Okay, and now look into this. This is some angle theta. Yeah, let me call it as phi basically. Okay, when I take the cosine of this angle. Okay, now what is this angle? Okay, this is known as the radial line to the pole. What is the meaning of radial line? I join the pole with respect to origin. Okay, Let me join the pole with respect to origin. Okay, the angle, this angle that this radial line subtends with the negative x-axis. The angle that this radial line is subtending with the negative real axis. I'm going to call it as phi. Now, what is cosine of phi? So, cosine, base is alpha. Coordinate is minus alpha, but the distance of the base will be alpha. Na? Okay, the base is alpha divided by hypotenuse. Base upon hypotenuse. Hypotenuse is omega n. सबसे पहले मैंने क्या बोला? This is omega n. How it is obtained? It is under root of minus alpha square plus omega d square. Okay, you can take up the formula, you will get omega n. That's not a big worry. Okay, now this is alpha by omega n, where alpha is zeta omega n upon omega n. Okay, omega n cancel. Okay, and eventually, okay, you get this zeta equal to cos phi. Okay, so zeta is also the cosine of this angle phi. What is this angle phi? The angle of the radial line to the pole with negative real axis. With respect to the negative real axis. Okay. Now, next important parameter, okay, very important parameter, the general step response expression. Okay, when you apply the input RT again equal to 1, the step input, what is the response you get? In general, it is obtained as, okay, in general, then there are special cases, uski baat bhi karenge, but in general, it is obtained by 1 minus e power minus alpha t upon under root 1 minus zeta square into sine of omega dt plus phi, into the sine of omega dt plus phi, right? Where alpha, as I already mentioned, is zeta omega n, omega d is omega n root 1 minus zeta square, and phi is given by the cos inverse of zeta. Phi is given by the cos inverse of zeta. Clear? The phi is given by the cos inverse of zeta. The phi is given by the cos inverse of zeta. As I mentioned, zeta is already equal to the cos phi by this manipulation. So that phi is coming up here. Okay. The alpha, which is zeta into omega n, see dear. Now, let me mention that. What is the zeta? Zeta is known as the damping ratio. Okay. Omega n is known as the natural undamped frequency. Okay, I will explain you slowly each and every time, but abhi note kar lete. Alpha is known as the damping factor. Alpha basically is a damping factor. Omega d is the damped frequency of oscillation. Okay, omega is known as the damped frequency of oscillation. Okay. Now the next important thing is, what is the waveform of this step response? What is the nature of step response? Okay, so that will be depending on the different values of zeta. The very important part, jahan se numericals aate hain, based on the different value of zeta, what is the nature of the step response? Okay. What is that, Manas, we are asking? Step response? Second order ki baat kar rahe hain na? First order to finish ho gaya na? We are talking about second order undoubtedly. Okay. Okay, the step response, here it is 1 minus e power minus alpha t upon root 1 minus zeta square sine of omega dt plus phi. Sine of omega dt plus phi. Okay. Chalo. Sine of omega dt plus phi. Okay. So, let's come up here. The step response, okay, nature for different values of zeta. We'll be classifying into different parts. Okay, maybe zeta is negative, or zeta may be 0, or okay, or zeta is greater than 0 but less than 1, or zeta equal to 1, or zeta greater than 1. These are the different ways in which we're going to classify. Okay, in which we are going to classify. Now, look into this complete tabular information. Okay, I'm telling you, no time and no need for revision, no need for derivation, but complete time for revision we have to dedicate here. So look into it. Okay, let us start with the zeta equal to 0 to 1. One by one I'll explain you. Okay, if zeta is between 0 to 1, the nature of the response is underdamped. Okay, the nature of the response will be underdamped. Okay, the poles, as I already calculated, minus zeta omega n. The omega naught is omega n here. Okay, minus zeta omega n plus minus j omega n under root 1 minus zeta square. Okay, that means the roots are complex conjugate. Okay, the roots are complex conjugate lying in the left half plane. Complex conjugate in the LHP. Kahan pe hai? In the left half plane. Okay, both the roots are complex conjugate in the left half plane. Something like this. Clear? Now, one more thing, I will write down the expression also. देखो, whatever expressions are important, वो अलग से लिख देते हैं. For zeta between 0 to 1, the Ct is given by the general expression only 1 minus e power minus alpha t upon under root 1 minus zeta square sine of omega dt plus phi. The expression that we have just seen. Okay. But in this particular expression, okay, when I take zeta equal to 0, coffee. It's है coffee. Yes, dear. Okay. So Ct is 1 minus e power minus alpha t upon under root 1 minus zeta square sine of omega dt plus phi. Okay. Now, if zeta, next value यहाँ पे आते हैं. If zeta becomes equal to 0. If zeta becomes equal to 0. Okay. If zeta becomes equal to 0. Okay, when zeta becomes equal to 0, roots you can see here directly. Okay, zeta हो गया 0. Okay, zeta हो गया 0. You are only left with plus minus j omega naught, yeah, plus minus j omega n. Okay, so the roots become pure imaginary, plus minus j omega n. The roots become pure imaginary. The roots are on the y-axis, pure imaginary. Okay, the roots are pure imaginary. Now, when zeta actually becomes equal to 0, when you put it in this expression, dear, you get an expression of the form 1 minus cos omega nt. You get an expression of the form 1 minus cos omega nt. I'm going to show you all the different waveforms, but the first one is overdamped. The first one is underdamped, as I mentioned. For zeta between 0 to 1, the nature of the response is underdamped. Okay, and this is what underdamped waveform. This is what underdamped waveform is basically. It has damping. What is damping? Damping is an effect. Damping is a phenomena which is responsible for reducing the amplitude, reducing the oscillations in a system. Okay, reducing the oscillations in a system. That is why the amplitude of oscillations quickly diminish, and when time becomes large in the steady state, output value will be 1. Okay, but if you look into this, Ct is 1 minus cos omega nt, only sinusoidal function. Only sinusoidal function is available here. Okay, so the response here, okay, is only sinusoidal. Okay, is only sinusoidal. अब देखो, you know how to sketch this waveform. Dear, what is cos omega n? पहले cos की बात करते हैं. This is cos theta waveform. I want minus cos theta. So please reverse it up. Amplitude folding. ये हो गया minus cos theta. But not only minus cos theta, add 1 to it. When you add 1 to it, it's going to be uplifted. That is what is the response. And that is pure oscillatory response. Now listen to one important point. The response that you obtain here is pure oscillatory. It is going to oscillate between the value 0 up to 2. Between the value 0 to 2. Okay. Between the value 0 to 2. It is going to oscillate between the value 0 to 2. It's pure oscillatory. Okay. This is known as pure oscillatory. Okay. Or also known as undamped. यहाँ पे कोई damping नहीं है because it is continuously oscillating. Okay. This one is underdamped. Here it is damping, but slight damping. Slight damping से मेरा मतलब है, we will come to the next case where damping becomes so dominant, where damping increases such that the oscillations are totally gone away. Here oscillations are still there, but amplitudes reducing. Next we will come to the case where oscillations totally gone away. Now this system is pure oscillatory, and that is why you get a periodic waveform, and every periodic waveform has a time period and a frequency. Every periodic waveform has a time period and frequency. Okay. What is this? This is known as the time period, the time between repetition. Okay. And how much will be the time period, guys? Cos omega n t. Omega n is the natural frequency. Na? So time period is 2 pi by frequency. So 2 pi by omega n. That is why I told you. What is omega n? Okay. The natural undamped frequency. Okay. It is the frequency of the system when the system is undamped. मैंने लिखा था ना यहाँ पे. What is omega n? Natural undamped frequency. It is known as the frequency of the system when the system is undamped. When the frequency is undamped. ठीक है. अच्छा, अब देखो यहाँ पे, अगर zeta को किया 0, तो alpha which is zeta omega n, that is also 0. Okay, alpha is also 0. Now, dear, if alpha equal to 0, you get e power 0. What is e power 0 is 1. That is why you don't have the exponential term coming up. You are only left with the sinusoidal term coming up. Okay. ये यहीं से तो निकल के आया. Actually, what is going to happen when you take zeta equal to 0? ये हो जाएगा pi by 2. Phi will become pi by 2, omega t will become omega n. So what is sine 90 plus theta? Cos theta. I get the cos theta function. Denominator is also 1, zeta 0 hai. That is how you got 1 minus cos theta. We did not derive, but that is how you got 1 minus cos theta. Now you have got the simple derivation also. But eventual idea is कि when zeta 0, alpha is also 0, and because of the alpha equal to 0, exponential term has gone. Exponential term has been gone away. Okay, if the exponential term is present, what is the e power minus alpha t waveform? Dear, what is the e power minus alpha t waveform? We know that this is how e power minus alpha t behaves. That is why when e power minus alpha t waveform is multiplied by the oscillatory waveform, what it will do? By e power minus alpha t, the reducing, it is always decreasing. It is always decreasing. So when this is multiplied by the oscillatory waveform, what it is going to do? It is going to reduce the amplitude of oscillation also. It is going to reduce the amplitude of oscillation also. Okay. The system rises but not up to 2. Okay, system goes down but not up to 0. Everywhere the amplitude of oscillation will be more and more down. Why? Because as you go to right, the effect is more decreasing. Okay. Okay, so this particular term is actually responsible for bringing the damping. Okay, because if this term is multiplied by the oscillatory waveform, you see the oscillations reduced in nature. The amplitude of oscillation is reducing in nature. Okay, so that particular factor, okay, which reduces the oscillation, which is responsible for reducing the oscillation, will be known as damping factor, and that factor is alpha. Because agar alpha ko 0 kiya, to e power 0, 1, this term will again be gone away. This is present if alpha is non-zero. This is present if alpha is non-zero, and that is why we call the alpha as what? That is why we call the alpha as what? Damping factor. Already I mentioned, I think. Alpha is known as the damping factor. The factor responsible for damping. The factor responsible for damping. Okay? Chalo. Later on in the upcoming discussion, you will find that here. Okay, although it is not periodic, but the time gap between any two peaks, will be fixed. The time gap between any two peaks will be fixed. Okay, and that time gap will actually turn out to be 2 pi by omega d. Ye peak time and overshoot ke baad study karenge. Once I go to the overshoot and peak time. Okay, so the time between any two consecutive peaks will be same 2 pi by omega d. Okay, just like time period term 2 pi by omega d. That is why we call omega as the frequency. Okay, but frequency of damped waveform. This is not undamped. It is the frequency of damped waveform. This is also known as pseudo frequency. Okay, it is also known as pseudo frequency, or simply known as frequency of the damped waveform, damped frequency of oscillation. Okay, that is how omega d gets the name. Clear? Okay. Now, dear, what happens when zeta becomes greater than 1? Okay, when zeta becomes greater than 1, okay, the CT actually turns out to be, I'm not deriving it again, but CT will turn out to be 1 minus, now see, okay, the CT is going to turn out to be 1 minus e power minus omega nt into 1 plus omega nt. It's going to become 1 minus e power minus omega nt into 1 plus omega nt. Okay, now, after putting zeta equal to 1, I'm talking about zeta equal to 1. So when you put zeta equal to 1 in this expression and simplify, okay, you get 1 minus e power minus omega nt into 1 plus omega nt. Now, dear, tell me, all of you, in this, where is the sinusoidal part? Where is the sin theta or cos theta? There is no sin theta cos theta now left here, isn't it? There is no sin theta term, there is no cos theta term. That means there is no term which can talk about oscillation. Okay, there is no term which can talk about oscillation. That is not at all available here. Can I say? It is not at all available. That means whatever waveform you draw for this, I will tell you the waveform also, but whatever waveform will come up here, that will not have any oscillatory element. That will be totally non-oscillatory. That will be totally non-oscillatory. Turns out to be something of this form. Okay, totally non-oscillatory turns out to be something of this form, the waveform which we actually call it as critically damped. Okay, when you increase the damping and make the damping ratio equal to 1, okay, the system shows totally non-oscillatory behavior. The system shows totally non-oscillatory behavior, okay, and it reaches the steady state value, okay, it just reaches the steady state value as quickly as possible. Okay, it is just non-oscillatory and reaches the steady state as quickly as possible. And it reaches the steady state, that is 1, as quickly as possible. As quickly as possible. Okay. That is what? For zeta equal to 1, the response is known as critically damped. Now when you put zeta equal to 1, okay, now when you put zeta equal to 1, the imaginary part will actually become 0. 1 minus 1, 0. You get only minus omega naught or minus omega n. Okay, that means, okay, a single but repeated, because we know there are 2 poles. Both of them are, it's like minus omega n plus minus j0. Okay, so both of them are minus omega n, minus omega n. Minus omega n and minus omega n. Okay, so at the single location but repeated negative root. Okay, repeated negative root. Okay, repeated negative root. Okay, so the root are real and repeated, means real and equal also you can say. Root is real and equal. Yeah, real and repeated. That is what is zeta equal to 1. Okay, now when you talk about zeta greater than 1. Okay, when you talk about zeta greater than 1, dear, you don't have to remember the expression for zeta greater than 1. That is derived using hyperbolic trigonometric function. Whatever to be remember, I am placing in front of you. Whatever you don't have to remember means you don't have to remember. Okay, overdamped. When you increase the damping, okay, system will still be non-oscillatory. Now see the difference between both these waveform. Okay, this is still non-oscillatory. But because you are increasing the damping, system becomes slower. This is non-oscillatory, okay, but slower as compared to the previous case. Okay, that means it is going to still reach the steady state value. It is still going to reach the steady state value. Okay, but taking a longer amount of time as compared to the previous case. More the value of zeta, more the system will be slow. More the value of zeta, more the system will be slow. Actually, you can now observe the different waveforms here. This is like a MATLAB plot properly. Okay, these are different MATLAB plots I have taken, and let me write down the values here. Let me specify all the values here itself. The first, okay, waveform that you are able to see is continuously oscillatory waveform that will exist for zeta equal to 0. As I clearly explained you, zeta equal to 0 represents the undamped case. Okay, the first one is zeta equal to 0. Okay, now when you increase the zeta, but it is less than 1, the system will be oscillatory, but amplitude of oscillation reducing. System will be underdamped. Kya hoga system? Underdamped. So I have taken the next waveform. Okay, for what value of zeta? Some values of zeta were entered in the MATLAB and the plots are obtained. 0.4. Okay, here has 0.4. Okay, then next I increase zeta and I have taken as 0.5. Okay. Okay. Higher the value of zeta, lower will be the amplitudes here. Lower will be the amplitudes here. Okay. Now, when you come to zeta equal to 1, look into this waveform. Okay, look into this. When you come zeta equal to 1, see, the system is not oscillatory a lot. Okay, it quickly reaches the steady state without any turn of oscillation. Without any single turn of oscillation also. It just reaches the steady state mark. This is the steady state mark. Clear? Okay, and then if you increase the zeta beyond 1, like I have taken one more value here, zeta equal to 2. Okay, let me say this is any value zeta greater than 1 for which the system is overdamped. For which the system is known as the overdamped. Clear? These are the different waveforms plotted for you completely. Okay, undamped. These two are underdamped, critically damped and overdamped. Critically damped and overdamped. But what happens? Let me see if I have got that waveform for you. Let me tell you next case. Now what happens? Okay, when zeta is negative. Okay, what happens when zeta is negative? So देखो ये वाला हमने complete कर लिया. We have talked about zeta greater than 1. Response is overdamped. Okay, roots will be real and negative but unequal. Okay, there will be two real and negative roots. We can call it as real and unequal. Okay, negative means LHP. Negative means LHP and the roots can be written as minus zeta omega n plus minus omega n under root zeta square minus 1. Okay, one more j taken outside, one more under root of minus 1 taken outside. Okay. Chalo, now for any negative value of zeta, the response will always rise. Okay, the roots may be complex or real. Chalo, मैं बता देता हूँ, उसको separate करके बता देता हूँ. Nothing to worry here. I'll separate out that case and write it for you. Okay. Okay, these are all the waveforms for zeta equal to 0 or greater than 0. Okay, but if I look into it, okay, if I take zeta negative, okay, इसमें भी मैंने लिया first -1 less than zeta less than 0, and then let's take zeta less than -1. So how the response is going to be? Okay, when the zeta is between -1 to 0, the response obtained will be something of this kind. Okay, that it is going to show exponential growth. It is going to show a exponential growth basically. Okay, and such a system is known as unstable because the output is going to be unbounded. Okay, bounded input producing unbounded output, unstable system. Okay, unstable system. Okay, unstable system. But all of this case, okay, like if you talk about this, bounded output reaching to a final value, the system is stable. If I want to mark the comment on stability. Underdamped ho, overdamped ho, critically damped ho, the system is stable. But if it is undamped, of course the output is bounded. In the undamped, what do we say? The output is bounded, but it does not settle to a final value. Output is oscillatory. Okay, it does not reach the steady state value even after infinite time, because even till t tending to infinity, it is oscillatory only. Okay, but we don't call it as unstable also because output is eventually bounded. This is known as the boundary between stability and instability. We call this case as marginally stable. Whenever the system is oscillatory, pure oscillatory, it is said to be marginally stable. It is said to be marginally stable. Okay, now when zeta is less than the -1, okay, output will still be unbounded, but it just increases without this oscillation turn. It just simply rises continuously and reaches the infinity mark. This is also unstable system. Okay, this is also unstable system. Okay. Okay, for any negative value of zeta, roots will be in the right half plane only. Okay, roots will be in the right half plane. अगर यहाँ पे लिख दूँ मैं, okay, here the poles will be complex conjugate in the right half plane. Complex conjugate in the right half plane. But for zeta less than -1, okay, the poles will be real and unequal, but in the right half plane. Real and unequal in the right half plane. Of course, again, if you take zeta exactly -1, then they will become real equal also, but still in right half plane. Okay, that is why we have the preliminary introduction. We will talk about stability after some more time, detailed version of stability. Okay, but yeah, we have a preliminary version that even if any of the pole is in RHP, maybe one or two, even if a single pole in RHP, that gives rise to exponential growth of the output. Output becomes unbounded eventually and the system is unstable. Okay, if you ensure that all the poles are in LHP, then the system is stable. But if a pair of poles on the y-axis, on the imaginary axis, pure imaginary poles, then the system is marginally stable. But we will add some more points to it later on. This is the preliminary introduction, I can say. This is the preliminary introduction. Okay, now for the underdamped waveform, dear. For the underdamped waveform, let's talk about different transient parameters. For the underdamped waveform, let us also talk about the different transient parameters. For the underdamped waveform, let us talk about the different transient parameters. What are the different transient parameters for the underdamped waveform? Okay, different transient parameters for the underdamped waveform. For the underdamped waveform, what are the different transient parameters? For the underdamped waveform. Okay, so let's talk about one by one. Very important formula. Okay, very, very important formula where questions will also develop for you. Okay, have a look into it. So this is the underdamped waveform. We know that it rises to a particular maximum value and then falls, and every time the amplitude of oscillation is reducing because of the damping factor. Okay, now look into it, this guys. Look into this. This is TR. This is the first time, TR, which is the time taken. This is underdamped. Overdamped ke liye rise time definition I have already discussed. But for underdamped waveform, TR, rise time is defined as the time taken by the step response to reach the desired value for the very first time. to reach the desired value for the very first time. Okay, to reach the value equal to 1 for the very first time. It reaches 1 multiple times, but what is the first time it reaches the desired value? Okay, so it is 0 to 100% rise, not 10 to 90%, 0 to 100% right, and that time will be known as rise time. Okay, all definitions are there for you. Time taken to reach the desired value. Okay, desired value for the very first time. Okay, this is underdamped. Overdamped का definition already हमने पहले ही देख लिया है. ठीक है, this is what is known as the rise time. And what is the formula for rise time? One by one, let me keep writing here. Okay, one by one, let me keep writing here. So rise time. Okay, rise time is given by the formula pi minus phi upon omega d. Okay, क्या करते हैं? Basic hints I will give you. Okay, number one, rise time अगर discuss करना है, तो what do you do basically? Okay, rise time के लिए you have to just equate Ct equal to 1. Okay, when you equate Ct equal to 1, actually you get n pi minus phi by omega d. Okay, you get different values of time. Okay, for n equal to 1, 2, 3, etc. You get different values of time. You get n pi minus phi divided by omega d. You get n pi minus phi divided by omega d. Correct? Eh? Why different values of time? Why different values of time? Because I have just taken Ct equal to 1. So Ct equal to 1 here also, here also, here also, here also, here also, here also. At multiple points it is equal to 1. Okay, but what I need the first particular time when it reaches the 1. Okay, when it reaches the 1. So when you take n equal to 1, you get your rise time, and that will be pi minus phi by omega d. That will be known as the pi minus phi divided by omega d. That is known as the rise time. Pi minus phi divided by omega d. The pi minus phi divided by the omega d. That is known as the rise time. Clear, everybody? The pi minus phi by omega d. Pi minus phi divided by omega d. That is known as the rise time. Clear, everybody? Chalo, let's move ahead. Okay, then let's move ahead then. Okay, so next, okay, delay time. It is the time taken by the step response to reach 50%. Okay, to reach 50% of the desired value. That is known as the delay time. Look at this. Okay, 50% of the desired value, 0.5. Okay, the time taken to reach the 0.5 mark is the delay time. Okay, so what is the delay time? What is the next? Delay time. Okay, delay time के लिए क्या करना है? Okay, Ct equal to 0.5, and then solving approximately, we get the delay time as 1 plus of 0.7 zeta divided by omega n. 1 plus 0.7 zeta divided by omega n. That is the delay time calculation. ठीक है? Next, ठीक है, चलो, this is an important point. Overshoot को बाद में देखते हैं. Settling time, the time taken by the step response to reach. I've taken the standard value 98%. Okay, the time taken by the step response to reach the 98% of the final value. To reach 98% of the final value, that is known as the settling time. Okay, that is known as the settling time. तो अगर settling time की बात करें, okay, let me write down the answer corresponding to it. Okay, so what is the settling time of the system? As I told you, as per 98% criteria, if I define, it turns out to be 4 by alpha. That is 4 upon zeta omega n. Okay. Similarly, if you want to consider by 95% criteria, then it is going to be 3 by alpha. That is 3 by zeta omega n. Okay. Okay. But let me tell you that in many of the control system textbook, you will find that the settling time is 4 by zeta omega n for every type of system. No, this is only for underdamped. This is only for underdamped. Okay, settling time for overdamped is different. वो भी बता देता हूँ, otherwise sometimes you do mistakes in the question. Okay, if it is overdamped waveform, okay, the settling time is given by 6 by zeta omega n. Okay, actually 6 by zeta omega n, but overdamped, sorry, not overdamped, I'm talking about critically damped first of all, I'm sorry. Okay, settling time is 6 by zeta omega n, but zeta will be 1 for critically damped, so it is simply 6 by omega n. It is 6 by omega n. The settling time is known as the 6 by omega n. Okay. Nahi Rajiv, that's what I'm specifying here. Na? For critically damped, it is different. Okay, it is 6 by omega n. It is known as 6 by omega n. Okay. Now let's come to the next and the most important point here. Okay, that is the maximum overshoot and the peak time of the system. Okay, the maximum overshoot and the peak time of the system. Okay, so now we know that the system is underdamped, means the system is oscillatory, but with the amplitude of oscillation reducing. But somehow it is oscillating about the desired value. That means it is fluctuating around the desired value. Sometimes up, sometimes down, but there is some fluctuation in the value. Okay, then eventually it settles to this value. It's like fluctuating and then settles to the value 1. How large is the fluctuation? Is it large enough which may be damaging the system? Okay, we need to measure that fluctuation. Okay, we need to measure this deviation, this fluctuation or this deviation. Okay, so now what I do is, this is known as the desired value. Okay, this is known as the desired value, CT desired. Okay, and this is the max value. Okay, how much is the largest deviation, largest fluctuation? How much is the largest deviation? Okay, we measure this deviation. How much is this deviation? This is known as the maximum deviation. And how much is this deviation? Okay, this deviation is given by the difference between the maximum value minus the desired value, whatever may be the desired value. Okay. Then what is maximum overshoot? Let's come here. Okay, the maximum positive deviation of the output, positive deviation, upar wala, because we know that, okay, this is going to be eventually smaller than the first one. That is why we talk about the first one. Okay. We call it as the peak deviation, also call it as the first overshoot. Ab dekhna. The maximum positive deviation of the output with respect to desired value. Dekho, it is not only deviation. Okay. It is the maximum positive deviation of the output, but with compared to the desired value. That is known as maximum overshoot. Okay. And the time to reach the maximum overshoot is called the peak time. Okay. The time to reach the maximum overshoot. Okay. This is known as the important. This is peak time. This is known as peak time. Now, what is the formula for peak time? And what is the formula for overshoot? Dekho. Peak time after solving. Okay. By solving maxima by calculus, the first derivative equal to 0, we get pi by omega d. Okay. Peak time, actually we get it as pi by omega d. Then what is the overshoot formula? As I just specified, basic definition of overshoot is CT max minus CT desired divided by CT desired. Dekho. First of all, I calculated the deviation, CT max minus CT desired. But that maximum positive deviation when compared with the desired value, that is what is known as the overshoot. Basic definition. Abhi iska final formula pe bhi aayenge. This is the basic definition. You can specify in percentage also. Percentage overshoot means multiply by 100. Multiply by 100. On solving, what do you get? On solving overshoot, you get the formula e raised to the power minus pi cot phi. I will write it in the simplest form. Okay, dekho. Because normally you see the formula written as something like this. E raised to the power minus pi zeta upon under root 1 minus zeta square. But we know zeta is cos phi. Putting down the zeta equal to cos phi, we get the formula e raised to the power minus cos pi, e power minus pi cot phi. Yeah, percentage overshoot, so e power minus pi cot phi whole multiplied by 100. Whole multiplied by 100. Okay, that is the percentage overshoot. E power minus pi cot phi into 100. E power minus pi cot phi into the 100. E power minus pi cot phi into the 100. Clear everybody? Okay. Chalo, done. That is the percentage overshoot. Acha. Yeah, ye bhi yaad rakhna. One relation. This is inversely related to zeta. That means if zeta increases, then overshoot decreases. This also may be useful for you. Whenever zeta increases, the overshoot will decrease. the overshoot will decrease. Acha, देखो TP is pi by omega d. You can also remember the general formula. Okay. Okay, what do? You need to first solve d by dt of Ct equal to 0. Okay. This is the fundamentals to solve maxima and minima problem. Okay, first derivative of Ct equal to 0. Ct expression already you know. Okay. Cot nahi hai, tan to hai. Ashok, tan to still there, na? Cot is not even in the Casio calculator also. But tan will be there always. Okay. देखो अब ये देखो. Okay. So by d by dt of Ct equal to 0, first of all you will be getting the value of t, which is given by n pi by omega d for different values of n equal to 1, 2, 3, etc. You get this formula for different values of n. Okay, you get this formula for different values of n. Okay. And then when you put down these different values of n, okay, you get the overshoot, undershoot, different values. You get it generally in the form of e raised to the power minus n pi cot phi. E power minus n pi cot phi. What I mean to say is sometimes they will not only ask the maximum overshoot. They can talk about any particular overshoot. Maybe first is the maximum, but third or etc etc etc. देखो बस इतना याद रखना है आपको. Whenever you take any odd value of n, it will represent overshoots. And whenever you take any even value of n, that represents undershoots. That represents undershoots. मतलब इसको यहाँ पे देखिए एक बार. Okay, that represents undershoots. So what I'm going to do here is, suppose I take n equal to 1. Any odd value will represent what? Okay, any odd value will represent what? कहाँ गया? Where I have mentioned for you. अच्छा, ठीक है, sorry. Let me mention it here. Okay, any odd value will represent overshoot. So n equal to 1 becomes the first, or known as the peak overshoot. First one is always peak. Okay, and then that formula I have written. The time at the peak overshoot is pi by omega d, that is peak time, and the overshoot value is, okay, overshoot value is e power minus pi cot phi. Okay, but if you take n equal to 3, okay, that is known as second overshoot. Okay, if they ask second overshoot, okay, what are the formulas? Okay, the formula will become n pi by omega d, n equal to 3. N equal to 3. So that will become 3 pi by omega d. Okay, and another formula will be, the overshoot formula will be e power minus 3 pi cot phi. Okay, e power minus 3 pi cot phi. If you put down n equal to 5, you will get the third overshoot value. What is the answer? That you can write down. Okay, na? That you can write down. Similarly, if you take any even values of n, if you take down any even value of n, what do you get? For any even value of it, first even value is 2. So you will get first undershoot. They may ask you what is the time to achieve first undershoot. So time will be 2 pi by omega d, and the value of the undershoot will be e power minus 2 pi cot phi. Okay, if you put n equal to 4, next even value, so next undershoot. What is that next undershoot? That is the second undershoot. That is the second undershoot. That will be obtained at the time 4 pi by omega d, and its value will be e power minus 4 pi cot phi. Clear everybody? Okay. So that is what I am talking about. Here are maximum deviation. That is the first overshoot. This is first undershoot. Like this is told, this is known as the first overshoot. This is known as the first undershoot. Shooting below the desired value. That is first undershoot. This is second overshoot, second undershoot. Third overshoot, third undershoot. They will be alternating in nature. For all odd values of n, overshoots. For all even values of n, it will be undershoot. Okay. ठीक है? चलो. What you are asking? Zeta in terms of, okay, ठीक है, वो भी आता है कभी कभी. So let me write down. As I told you, overshoot is e power minus pi cot phi, or that is e power minus pi zeta upon under root 1 minus zeta square. Okay, now how to obtain zeta? You can solve from here, or I will tell you the formula for zeta also. Okay, if you're looking for the formula, it turns out to be log of overshoot ln mp whole divided by under root of pi square plus ln mp whole square. This is what the zeta will turn out to be. Log of overshoot divided by under root of pi square, okay, under root of pi square plus ln mp whole square, correct? ठीक है, डन है, चलो, okay. So now we can take up a question also here. अच्छा, ये होगा minus log of overshoot, है ना? Minus log of overshoot. That automatically you understood. Zeta will not turn out to be negative here anyways. Okay. Tell me this one. Chalo, for a practice, let's take up one question. Hanji Satvik, whatever topic is I'm focusing is important only. In the beginning half, I first focused important. Towards the evening, we will see how much we can cover. I'll try to cover as much as possible only. Okay. But first priority is कि सब कुछ करना है यहाँ पे, at least all important things. ठीक है जी, tell me. For the system shown in the figure, determine the value of K such that the damping ratio is 0.5. Okay, so first it's a small block diagram activity also. Okay, then determine the rise time, peak time, overshoot, settling time, etc. Okay, चलो तो यहीं पे इसको solve करेंगे. Firstly, let us solve this inner block. What is the gain of this inner block? G upon 1 plus GH. Okay, G upon 1 plus GH. Forward path gain 10 upon S plus 0.8 divided by 1 plus 10 upon S plus 0.8 is multiplied by K. Okay, multiplying by S plus 0.8 throughout, I will be getting 10 upon S plus 0.8 plus 10K. That is the gain of the inner block. Okay, that is the gain of the inner block. Okay, okay. Yeah, you must go through compensator once. Important, not heavily important, but it's important. Okay. Now, this is cascaded with 1 by S to get the overall forward path gain, and then you can get the HS. Okay, then you can get the HS. Achha, not necessary to form the complete transfer function. Na? What you can do, you can just form the direct characteristic equation also. How do we write down the characteristic equation? No need for the complete transfer function. Just get the characteristic equation. What is that characteristic equation? 1 plus GSHS equal to 0. Okay, so 1 plus GS. What is the GS? GS means this particular gain multiplied by 1 by S. So I have 10 upon S plus 0.8 plus 10K multiplied by 1 by S. That is GS. HS is 1. Overall feedback is unity. Unity feedback. So I just need to simplify this. Multiplying by S in the denominator, I will be getting S square. Then 0.8 plus 10K multiplied by S plus 10 equal to 0. Now what is the first question? Determine the value of K so that the damping ratio is 0.5. I want the zeta to be 0.5. I want the zeta to be 0.5. Okay. Whole root where means? Srinath? What is that whole root you want to refer? चले आ जाते हैं, ठीक है. So now what is this equal to? देखो, we comparing with the standard form, S square plus 2 zeta omega n S plus omega n square. What should be this term? This is corresponding to omega n square. Standard second order, na? Standard second order. This is omega n square. That is equal to 10, and hence omega n is root 10. Okay, and then what is this term equal to? S square plus 2 zeta omega n. 2 zeta omega n. Okay, now we can write down here 2 zeta omega n is 0.8 plus 10K. Okay, now zeta is given to be half. We need to solve for zeta half, and omega n abhi nikal liya, root 10. Okay, this is 0.8 plus 10K. Solving here. Okay, what should be the value of K? Let us solve here and let me know what is the value of K you will be getting. Okay, what is the value of K you will be getting? Okay, so let me write down this quick answer. Yeah, 0.236, okay. Okay, K will be turning out to be 0.236. K will be turning out to be 0.236. Okay, 0.236. ये K आ गया. This is the first part. Now obtain the rise time, peak time, overshoot. अच्छा, rise time, peak time के पहले भी let us calculate the alpha and omega d first of all. Okay. I don't know the length of the class. I need to cover as much as possible. That's the only answer I can give right now. Zeta is 0.5. Omega n आ गया है √10. √10 is like approx 3.16. So first of all, let's write down the alpha also. Alpha will be zeta omega n. So when you multiply these two, it's going to become 1.58. Perfect. Okay, then omega d is given by the formula omega n root over 1 minus zeta square. Omega n है √10. This is further 1 minus zeta square, 1 by 2 ka square, 1 by 4. Okay, so this is overall under root 3 by 4 into 10, 30 by 4. Okay, how much is this turning out to be? Can you tell me quickly? $2.74. Okay, 2.74. Yes, guys. Next Tuesday, I am bringing you the signals. You see the schedule. Next Tuesday, signals is there. I'll be taking signals. Don't worry. Okay, so 2.74 is what we are getting here. Correct? 2.74. Okay, so basic parameters are obtained. Now you need to tell me what is the rise time, peak time, okay, overshoot, और क्या क्या बोला है, and settling time. Settling time. Tell me all these values. Okay, I'll just be back in a minute, guys. Okay, just complete this value. I'll be just back in 2 minutes. Okay, I'll be just back in 2 minutes. Yes, hope so you are done, guys. Chalo. Okay, so let's continue quickly. Okay, so one by one सारा कुछ करते जाते हैं. Okay, so what is the value of the rise time? What is the value of the rise time? Okay, it is given by pi minus phi by omega d. चलो one more thing, वो भी यहाँ निकाल देते हैं. Zeta is cos phi, but zeta is 1 by 2. So at what angle you get 1 by 2? 60 degree. Cos 60 is half, but write down in the standard unit radian, it is pi by 3. It is pi by 3. So you have pi minus pi by 3 divided by omega d. Omega d is 2.74. Okay, calculation सब एक साथ लिख देंगे. Then the peak time is pi by omega d. That is pi by 2.74. Okay, settling time लिख देते हैं पहले, and settling time is 4 by alpha. 4 by alpha. Alpha is 1.58. Okay, now let me write down all of these values quickly. .76 is my rise time. Keep looking into the value. 0.76 second. Peak time 1.15. 1.15. Settling time 98% criteria by default considered. 2.53 seconds. Okay, just match on these values. Okay, just match on these values. Now last, e power minus pi cot phi. Okay, that will be e power minus pi cot phi, and phi is pi by 3. Okay, now cot pi by 3. What is tan pi by 3? Tan 60 degrees root 3, na? Tan 60 degrees root 3. So cot 60 degree will be 1 by root 3. Now evaluate the value. 0.16. 0.16 या अगर परसेंटेज में बोला जाए तो 16%. Okay, 16%. Done है? 16% clear. चलो, this is done. Cool. अच्छा, some of the questions may be related with the pole location. So let's look into one more. Directly the pole location is given, and they are asking you what peak time and the settling time. These are actually very simple, but peak time and settling time. Settling time for the 2% range, that is 98% criteria again. Okay, 98% criteria. Tell me, dear. Okay, so we should just remember the location of poles, and in general, okay, when the poles are complex conjugate in the left half plane, this pole should be corresponding to minus alpha plus j omega d. So very simple, on comparing alpha is 2, on comparing omega d equal to 5. Okay, now they are asking peak time. So peak time to pi by omega d, question solved here only. Pi by omega d is known to me as 5. Okay, so how much is this value? 0.63 approximately. 0.63. This is very simple actually. Okay, then next is what is the settling time? Okay, the settling time is given by 4 by alpha. Alpha is directly known to me as 2. So the settling time of the system is 2 seconds. Done hai? Simple hai? Okay ji. So these parts are simple primarily, you can say. Chalo, next. Okay, steady state errors. Okay, now let's have a discussion on the steady state errors also. Very, very important. Very, very important steady state errors. Okay, first of all, let us define the standard definition of error. Okay, the error which is defined as the error between the reference input and the obtained output, that is basically RT minus CT, or you can write it in the S domain also, that is RS minus CS. Okay, the difference between reference input and the obtained output, that is what is the basic definition of the error signal. Okay, now have a look into this block diagram. Okay, if we start by default with the non-unity feedback case, okay, so if it is non-unity feedback case, what is the output of the summing point? See, this is the input RS. This is the output CS, and the output of the summing point in general known as the actuating signal, the corrected input that is applied to the plant. Okay, the corrected input that is applied to the plant. And what is this actuating signal then? Equal to this actuating signal, which is now equal to RS, okay, minus, now this is CS into HS. Okay, this is C, which is the input to the feedback block, and the output of the feedback block will be C into H. Okay, minus CS multiplied by HS. Okay. And it will not be equal to the error signal. It will not be by default the error signal if HS is not equal to 1. Okay, but definitely if you take HS equal to 1, the actuating signal becomes equal to the error signal. Otherwise not equal to error signal. Okay, that is why first of all we start by discussing this steady state error for unity feedback. What to do with non-unity feedback, how to define and calculate the error there, we will come to that also. Okay, but first let us start, okay, with the definition of, let us start with the discussions of unity feedback. Okay, the unity feedback system. Okay, so when you have the unity feedback system, this node is clearly the error signal then. Okay, because it is directly the difference between the reference input and the obtained output. Feedback gain is 1, so it is definitely RS minus CS. Okay, that is RS minus CS. Okay, now there is a simple way of calculating this error. Okay, so we know that output of the summing point is E, and that is R minus C. But what is C eventually? What is C eventually? It is the output of the G block. Input of the G block is E. So input into gain. Input E into gain G. This is EG. So what is error? It is equal to R minus EG. Okay. So E on the left side, 1 plus G equal to R. So what is the value of the error signal? That is given by R upon 1 plus G. That is what I have written here. Correct? The error signal, okay, is RS upon 1 plus GS. Okay. Okay. Yeah, there is a formula for non-unity to unity feedback. Krishna, उस पे भी आ जाएंगे. ठीक है, there is a one-shot formula. Now, steady state error. We are primarily concerned that if I leave the system for steady state, if I leave the system to the steady state, okay, will it be accurate? Will it reach the desired value or not? If it doesn't reaches, it has some error in the steady state. Definition already defined earlier. Steady state error, limit t tending to infinity, error et. Okay, and by the final value theorem, by applying the final value theorem on the Laplace domain, we get limit of s tending to 0, s into es. Limit of s tending to 0, s into es. Okay, and what is the es signal? Okay, this is limit s tending to 0, s into es. And what is the es signal? Rs upon 1 plus gs. And we get this as limit s tending to 0, srs is divided by 1 plus gs. It is given by limit s tending to 0, s into rs is divided by the 1 plus gs. S into rs divided by 1 plus GS. That is how the basic error calculation will start. That means very clearly this basic error calculation, okay, see S is a variable that will eventually be S tending to 0. Okay, that will be S tending to 0. Eventually you will put S tending to 0. So other than that parameter S, the error depends on this, that is the input RS and the forward path gain. Okay, so it depends on number 1 input. Okay, number 2 input. Number 1 input. Okay, number 2, it depends on GS. Okay, and from GS we will now define the type of the system. We will now define the type of the system. What is the meaning of type? Okay. Type means number of poles of forward path gain, that is GS at origin. Okay, considering unity feedback. Considering unity feedback. Number of poles of GS at origin. Okay, number of poles of GS at origin considering unity feedback. So, देखो, what is the value of GS? What is the value of the GS? Okay, suppose example से समझते हैं. Okay, GS could be anything. So suppose I tell you GS is given by twice S plus 1 upon S square S plus 3. Can you tell me what is the type of this system? Okay. Can you tell the type of these systems? Can you tell the type of these systems? Okay, so number of poles of GS at origin. Of course, all of the systems are unity feedback, no doubt. Okay, unity feedback में ही discuss कर रहे हैं. Okay, now it is S square. Because it is S square in the denominator, okay, it will have 2 poles at origin. Okay, when you calculate the poles, it is type 2. Now, this has only one pole, that is at -6. There is no pole at origin. There is no pole at origin. So this one is known as type 0. Okay, this one is known as type 0. Similarly, last one is type 5 system. That is type 5, s power 5. So in general, if the denominator has some s power n, in general, if the denominator has some s power n, okay, in general, if the denominator has some s power n, okay, if the denominator has some s power n, okay, there may be several terms like k, okay, 1 plus st1 and etc. Okay, divided by s raised to the power n into there will be some terms in the denominator, pole terms. Okay, this n is known as the type. Whatever is the separate power of s in the denominator, s power n, that is a type n system. That is a type n system. Okay. Now, before we start the error calculation, we define some error coefficients, the static error coefficients first. Okay. Number one, the static positional error coefficient known as the step error constant. This is associated when unit step input is applied to the system. This is associated, okay, when unit step input is applied to the system. When the unit step input is applied to the system. Okay, when the unit step input is applied to the system, this is known as the step error constant. Okay, so now, okay, for unit step input applied to the system, steady state error of a system will be given by the formula, 1 upon 1 plus kp, okay, where kp is the, okay, this is the kp. That is the step error constant, positional error coefficient, is given by the formula limit of s tending to 0 gs. This will be given by the formula limit of s tending to 0 gs. Okay. Similarly, for unit ramp input applied to the system, we calculate the velocity error coefficient. Okay. For unit ramp input applied to the system, okay, we calculate the velocity error coefficient. Okay, and the steady state error is given by 1 upon kv, where kv is the velocity error coefficient. That is given by the formula limit of s tending to 0, s into gs. No derivations here, guys. Directly writing down the answers. Limit of s tending to 0, s into gs. S into gs. Okay, s into gs. Okay. Then similarly, acceleration error coefficient or parabolic error constant. Okay, so parabolic error, that is for unit parabolic input applied. For unit parabolic input applied to the system, the steady state error is given by 1 upon Ka, okay, reciprocal of Ka, where Ka is the acceleration error coefficient given by the formula limit of s tending to 0, s square gs. Limit of s tending to 0, s square gs. Limit of the s tending to 0, s square gs. Limit of s tending to 0, s square gs. That is unit parabolic input. That is for the unit parabolic input. Limit of s tending to 0, s square gs. And steady state error is given by the 1 upon Ka. Steady state error is given by the 1 upon Ka. Okay. Now, when I say, see, we all know step and ramp. When I say ramp input, when I say unit ramp input, okay, RT is equal to T. Okay, T greater than 0 to pata hai. So Laplace transform is 1 by s square. Accordingly, we get the solution. Similarly, when I talk about unit parabolic input is T square by 2. And its Laplace transform then turns out to be 1 by s cube. Okay. Now, what is the value of these constants for different type of system? Usko bhi generalize kar dete hain. Okay, we'll give it a fixed table. So steady state error for various types of the control system. Type I've already defined. Okay, so there is a type 0 system. Go through it. It's just for your revision. I will give you the direct way of handling the question now. Okay, type 0 system, type 1 system. Type 1 system has a s power 1 in the denominator. Type 2 system having the s square in the denominator. The error for different inputs are solved. आप क्या करेंगे? Okay, just remember a small matrix here. Okay, just remember a small matrix here. We'll remember in the form of a 3x3 grid, yeah, also known as a 3x3 matrix. जो भी नाम दे दीजिए इसको. I will just make a 3x3 grid for you, and we will put down the results there. Okay. We'll put down the result there. Okay. What I will do in this 3x3 grid, okay, on one side I will write down the input And on one side, I will write down the type. Let us talk about the three important types. See, if it is greater than type 2, we will solve normally. वो भी करेंगे हम. Okay. And I will take this three common inputs, step, ramp and parabolic. If it is any other input, if it is higher order input, okay. Okay, we will solve manually. वो वाले question भी कर लेंगे. But first, focus on this 3x3 grid. Okay, step 1 upon s, ramp 1 upon s square, order increasing, parabolic 1 by s cube, order increasing. In the increasing order inputs I have arranged and in the increasing time. Dear, just remember simply that all the diagonal numbers will be finite. All the diagonal numbers will be finite. Okay, whenever you have a type 0 system and you apply step input, the answer will be some finite. How to calculate the finite? How to calculate the error due to step input? भाई बताया ना, how to calculate the error due to step input 1 upon 1 plus kp. So there you have to calculate kp. Okay. Similarly, पहले diagonals को focus करते हैं. If you have a type 1 system, okay, if you have a type 1 system and you apply ramp input, okay, you get finite error and that is given by 1 upon kv. चलो लिख भी देते हैं. ठीक है. 1 upon kv. Let me rewrite here. Similarly, for step it would be 1 upon 1 plus kp. Similarly, if you have a type 2 system and you apply parabolic input, there you get finite error. Okay, and that is given by 1 upon Ka. Okay, now for any particular type, when you increase the order of the input, the error will become undefined. The error will be infinity. That means all the elements below the diagonal will be infinity. Type 0 system, when you apply ramp or parabolic, error will be infinity. Type 1 system, when you apply parabolic, the error will be infinity. But when you apply a lower order input, ramp की जगह step apply करोगे, if you go above, the error will be 0. System is accurate. No error in the steady state. Similarly, type 2 system, okay, parabolic पे finite है, above 0. So all the elements, see, diagonal will be finite. How to remember? Diagonal is finite. Anything below the diagonal is infinity. Anything above the diagonal is 0. Okay, please remember it this way. Then we will solve the other category of question if it is other than parabolic, if it is more than type 2, वो सब भी करेंगे. Okay, have a look into it. Sometimes let me start with a very simple question. Okay. Na Gautam, 0, infinity below diagonal. Sure. For type 0 system, when you apply ramp and parabolic, it is going to give you infinity. You just go through it. Okay, for a type 0 system, when you apply ramp and parabolic, it's going to give infinity. I'm talking about the final error, not the value of the constant, Gautam. This is the final steady state error. This is the steady state error slide. Okay. Chalo. So now, you know, if you remember this technique, the question becomes, a lot of simple, become actually very simple. Okay. So for a unity feedback control system shown in the figure, open loop transfer function is GS equal to 2 upon S, S plus 1. GS is equal to 2 upon S, S plus 1. Okay, what type it is, dear? What type it is? 2 upon S, S plus 1. Okay, it is type 1. S power 1 separately in the denominator. This is known as type 1. This is known as type 1. Clear, everybody? This is type 1. Now, because it is type 1, what is the steady state error due to step, due to ramp, due to parabolic? Dear, it is type 1. So it will give the finite error due to ramp only. Okay, above 0, below infinity. Okay, so two of the answers are known to you. आपको actually एक ही निकालना है. You have to calculate the error due to ramp. Step and parabolic is known to us. Step and parabolic is known to us. So what is the error due to ramp? Okay, what is this finite value? You don't have to say the answer is finite. What is that finite value? It is given by 1 upon kV. It is given by 1 upon kV. Sir, what is the kV? kV is given by the formula limit s tending to 0, s into gs. Limit of s tending to 0, s into gs. Okay, and gs is 2 upon s, s plus 1. S to s cancel. Okay, then s tending to 0, 2 by 2 is 1. So the value of kV is 1 and the error is also 1. Why you are telling 1 by 2? Na baba? Acha, 2 upon s, s plus 1 hai. Okay, sorry. This data is s plus 1. Correct hai, correct hai. This data is s plus 1. Okay, and then the value of the constant is basically equal to the 2. 2 by 1, that is 2. And hence, the value of the error 1 by 2, or that is 0.5. Due to ramp, the error will be 0.5. Due to step, it's going to be 0. Due to parabolic, it is infinity. Clear, everybody? Okay. So in sequence, if I say the answer is 0, 0.5 and infinity. You have to mention what finite value. Don't say it is finite, but what finite value. Okay. So if you remember this grid, na, okay, it will be easier to deal with. Okay. Next one, non-unity feedback पे आ जाते हैं. Non-unity feedback पे आने के पहले, okay, before I come to non-unity feedback, stop, है ना? We'll come to it later. Okay, इस पे आते हैं first. Let's take one or two different questions and then I'll come to non-unity feedback. For the feedback control system shown below, this is again unity feedback. Okay, steady state error is given. So sometimes these are also important questions. Steady state error is given and that is for the step input. Okay, what should be the value of K? Okay, what should be the value of K? So dear, overall, what is the value of GS? वो देख लीजिए ना. What is the overall forward path gain? It is the cascade of two blocks, so hence the gain will be multiplied. Eventually, I will be getting K is divided by 1 plus 4S, 1 plus S. It is type 0, 1 plus S. Acha. The error is due to step input. The error is due to step input. That means steady state error, 20%, 20 by 100 is 0.2. The absolute value is 0.2. So the steady state error is 0.2. The steady state error is 0.2 and that is given by 1 upon 1 plus Kp. Due to step, it is 1 upon 1 plus Kp. Due to the step, it is 1 upon 1 plus Kp. Okay, तो यहाँ से आप निकाल लेंगे 1 plus Kp. 1 plus Kp, 1 upon 0.25. So what is the value of Kp, dear? The value of the Kp equal to 4. The value of the Kp is equal to the 4. The value of the Kp is equal to 4. Okay, but I want K. Dekho, now what is Kp? Kp, we know, dear, is known as limit of S tending to 0 GS. Kp is limit GS. Kv is S into GS. Ka is S square GS. Okay, so limit S tending to 0 GS. Okay, so Kp ka value है 4. Now put S tending to 0 here, so you get K. S equal to 0, so simply 1 and 1. Perfect है, तो K का value ही 4 आ गया. K itself will be 4. But because this is S tending to 0, so just 1 in the denominator. Okay, so K itself equal to 4. Correct answer is 4. Option number D. Correct answer equal to 4. Option number D. Option number D. Next one. Okay, next one. Okay, now a unity feedback system has the forward part transfer function again given to you. 5s plus 1 upon s square s plus 3. Since it is unity feedback, so I can define the type of the system. So what is the type? Denominator s square, s power 2, 2 poles at origin, so it is a type 2 system. It is a type 2 system. If the system is subjected to the input 1 plus 2t plus 5t square, if the system is subjected to the input 1 plus 2t plus 5t square, okay, what is the steady state error of the system? 1 plus 2t plus 5t square. 1 plus 2t plus 5t square. One plus 2t plus 5t square. What is the steady state error of the system? What is the steady state error of the system? Let's check it out. One plus 2t plus 5t square. So guys, it is type 2 na? Okay, type 2. The steady state error due to step and ramp should be. Okay, due to step and ramp should be. देखो सबसे पहले तो आप input को arrange कर लीजिए. Okay, input is here. Input is here. RT equal to 1. Okay, plus twice of t. That is twice of ramp. Plus t. Now t square is parabolic. But what is unit parabolic? What is unit parabolic? Okay, unit parabolic is t square by 2. So if you want to write it in the form of unit parabolic, it should be 10 into t square by 2. 10 into t square by 2. तो देखो अब ये type 2 है, तो steady state error due to step, ramp, parabolic, due to step 0, ramp 0, parabolic finite, that is 1 upon Ka. So because the input is a combination and you apply the linearity, ultimately you're studying linear system. Okay, what should be the steady state error? Due to step 0. Okay, due to ramp, it is 0. Okay, it is twice of ramp, the twice of 0. Just for clarity, I'm writing. This is the error due to unit parabolic. So you have 10 into t square by 2. So what should be the error? Ye learn kar lijiye yahan pe. The error will also be given by 10 times 1 upon Ka. Okay. Linear systems follow scaling also, homogeneity also. If input is multiplied by 10, output is also multiplied by 10, and similarly error, which is RT minus CT. So of course error is also multiplied by 10. So this becomes 10 into 1 by Ka. Okay, so what is the steady state error, dear? It is 10 by Ka. What is the Ka? What is the Ka? Limit of s tending to 0, s square into gs. S square cancel karte hue answer will be 5 by 3. Okay, so the steady state error is basically 10 divided by 5 by 3. So cancel over 2, 2 3s are 6. Answer should be 10 by 5. नहीं 5 by यहाँ तो 3 miss हो गया है. Something is there. It is 10 by it is 6, correct. It is gonna be 6, sure. Okay. It is going to be 6 only. Okay, so let's correct any one of the option. It's going to be 6. Answer is D. Okay, let's say the answer is D, 6. 100%, no doubt. Okay, the answer is turning out to be 6. Okay, next case. The forward part transfer function of a unity feedback system is given to you. The forward part transfer function of a unity feedback system is given to you. Okay, 1000 s square plus 4s plus 20 s square plus 20 s plus 15 upon s cube s plus 2 s plus 10. And the system has RT equal to t cube applied to the input. How do you calculate the error now? Okay, first of all, what is the type of this system? S cube in the denominator separately, it is type 3. And what is the input applied? It is neither step ramp parabolic. It is even a higher order, higher than parabolic. Okay, it is higher than parabolic also. It is higher than parabolic also. So here you have to go with the basic fundamental. Okay, basic fundamental. What's going to be the Laplace transform? What is the Laplace transform for t cube? It is going to be factorial 3 upon s ki power 3 plus 1. The formula is factorial n upon s ki power n plus 1, correct? So this is 6 upon s power 4. Okay. Now, how do we calculate the error? Basic fundamental will come up here. The basic fundamental of error is limit of s tending to 0, s into es. Okay, s into es, and the value of es was rs upon 1 plus gs. So limit s tending to 0, srs upon 1 plus gs. इस तरीके से solve करना है. Okay, unity feedback is anyways mentioned, which I need. Okay, now this is going to be limit s tending to 0, s into rs. Rs is 1 upon s power 4 divided by 1 plus gs. And gs is some expression 1000 into something divided by s ki power 4. नहीं, s की power 3 है. Divided by s power 3, s plus 2, s plus 10, something. I'm not writing that something right now. ठीक है. चलो, so now after cancelling one of the s, it is s cube. Numerator also s cube, ये भी s cube है. तो multiply throughout by s cube. Multiply throughout by s cube. So you get limit s tending to 0, 1. Okay, then multiplied by s cube. So this is s cube plus 1000 into something upon something. S cube cancel ho gaya. I have multiplied by s cube. Okay, now directly put down the s tending to 0. So numerator constant and denominator s cube will become 0 plus the other term 1000. Now what is the value when you put s equal to 0? Write down that something value at s equal to 0 only. So this is gone, 20 into 15. This is gone, 2 into 10. Okay, so you have now this something is 20, then you have 15, and next was how much? 2 and 10. 2 and 10. So 20 cancel hua. Okay. Perfect hai? Yeah. So I am getting the answer as 1 upon, ye bhi 0 hua, 15,000. Answer should be somewhere 1 upon 15,000. 1000 भी था ना, वो कहाँ चला गया? हाँ, करेक्ट है ना. 20 कैंसिल हो गया. हाँ, so 1 upon 15,000, something like that. हाँ 6 upon s की power 4 ना 6 ही तो लिखा था 6 upon s की power 4 oh by chance a typo error I missed it here okay this is 6 this is 6 this is 6 correct a 6 upon s की power 4 ही है that is correct that's what we calculated so 6 upon 15,000 okay now the answers are in the form of देखो 4 आ जाएगा क्योंकि 6 upon 15 is 0.4 10 power minus 3 या multiply by 10 तो 4 and then 10 power minus 4 4 10 power minus 4 so my answer is A ठीक है जी clear my answer is A 4 10 power minus 4 option number A clear everybody okay now let me take you towards non-unity feedback okay so as I told you the error if it is non-unity feedback signal the output of the summing point is the actuating signal which is R minus CH and that is not equal to the error signal and hence there is no node in the block diagram where you can define the error signal okay so what we just do it the shortcut to solve here is rather than solving it again just convert the system into a equivalent unity feedback system okay what I do is I convert this into equivalent unity feedback system okay what is the meaning of equivalence two systems are equivalent if they have the same gain that means they have the same transfer function okay so there is the block diagram having forward path gain J and feedback gain H okay now there is another block diagram having the forward path gain GE and feedback unity that's what I want because I'm changing the feedback path gain there the forward path gain can also change and this forward path gain is this is GE the forward path gain of the equivalent system GE okay now they should have the same transfer function okay what does it mean what is the transfer function of the original system G upon 1 plus GH this should be equal to the transfer function of the second system that is GE upon 1 plus GE either I'll tell you a formula remember or either remember this technique you have to equate this and you can get the GE just have to equate this and you can get the GE okay so after you equate if you want a formula note kar lijiye otherwise you can solve always from here also so what is the GE GE turns out to be G divided by 1 plus GH minus G it is known as the 1 plus GH minus G G is given by the formula G upon 1 plus GH minus G. G upon 1 plus GH minus G. G upon 1 plus GH minus G. ठीक है चलो डन है okay so have a look into this question determine the type of the system and the steady state error for step ramp and parabolic inputs for the system given below step ramp and parabolic inputs for the system given below tell me for the system given below so definitely it's a non-unity feedback system okay there's non-unity feedback okay so what is the type don't say is it type 2 if you say from here it's wrong what is the type I don't know right now maybe 2 maybe 1 maybe anything else but I have to calculate but for type I clearly mentioned okay the type is always defined for unity feedback system it is not defined for non-unity okay and even to calculate the error I told you should convert to unity feedback so first approach is converting to unity feedback the first thing that needs to be done is converting to unity feedback and that is G divided by 1 plus GH minus G G is divided by the 1 plus GH minus G okay so let us apply this formula now get the GE first of all G that is KS plus 1 KS plus 1 upon S square S plus 2 that is the G divided by 1 plus K S plus 1 upon S square S plus 2 into H what is the value of H S plus 4 S plus 3 S plus 4 upon S plus 3 minus G again writing G K S plus 1 upon S square S plus 2 okay multiplying by S square S plus 2 S plus 3 throughout I get the answer K S plus 1 S plus 3 divided by S square S plus 2 S plus 3 plus k s plus 1 s plus 4 minus s plus 1 cancel, s square s plus 2 cancel hoga, but still k s plus 1 and s plus 3 will be there. Okay, so simplifying it, eventually I should be getting GE equal to k s plus 1 and s plus 3 divided by, if you have solved, let me know, ये हो जाएगा s square s power 4 plus 2 and 3 5 s cube plus 2 3 is 6 s square. Okay, plus k s plus 1. Okay, k s plus 1 s plus 4 minus s plus 3 will be 1. Okay, ठीक है, ठीक है, तो k s plus 1, so that is k s plus k. Okay, chalo, that is the value of GE. That is the value of GE. That is the value of GE. Okay, what type now? Do you have any s power term common? Do you have any poles at origin? No. Okay, it's clearly type 0. It's clearly type 0. Okay, and that is why the error due to ramp and parabolic to hoga hi nahi. That will be infinity. We have to calculate due to step. Okay, type 0 hai, to steady state error, dear, for step, okay, for ramp, for parabolic. For ramp and parabolic, higher order input infinity. For step, it's finite, and for step, finite answer is given by 1 upon 1 plus kp. 1 upon 1 plus kp. So dear, what is kp? It is limit s tending to 0 of GES. Limit s tending to 0, forward path gain, GES of the unity feedback system. GES of the unity feedback system. So s tending to 0 jab yahan pe rakha, so you have 1 and 3, so k into 1 into 3 divided by s 0 0 0 0, only k is left. So k is basically cancelled, not required. kp ka value 3 aa gaya, so 1 upon 1 plus 3, and your answer is 1 by 4, that is 0.25. Due to step, it is 0.25. Due to ramp or parabolic, it is infinity. 0.25, infinity, infinity. 0.25, infinity and infinity. Clear, everybody? 0.25, infinity, infinity. Chalte hain next ki taraf. Okay. Now, sometimes what can happen, dear? Isko dekhna. What is the next important point? Look into it, especially a gate question I am taking here. Okay, sometimes we know that the output of the summing point for non-unity feedback is the actuating signal, and the standard definition of error is R minus C. The standard by default definition of error is R minus C. But under some situations and under some systems, they may define that the output of the summing point itself is error signal. Given here, this particular node itself is the error signal. This particular node itself is the error signal. Listen to me. It is a non-unity feedback system. The procedure is for non-unity. We convert to unity feedback. But why we convert it to unity feedback? Because our basic and standard definition of error is R minus C. For non-unity feedback, this is known as R minus CH. That is actually actuating signal, we say. But for some particular cases, like this question, intentionally they have mentioned this is the error signal. So they want the steady state value of this signal. Okay, so should I convert to unity feedback now? If nothing was mentioned, if this was not given, so by default it is actuating signal. This is not error signal, and we will convert to unity feedback. But they have mentioned that this is the error signal. Find a steady state value of this error signal. So should you convert to unity feedback now? Tell me, should you convert to unity feedback now? Does it require to be very specific? There can be twist in the question. Okay, that's what I again repeat. If this was not mentioned, convert to unity feedback. But if it is mentioned, this is what is my error signal, I am defining error as R minus CH. Okay. So I will calculate directly for this particular signal only. No need to convert to unity feedback. Okay. So here, don't convert to unity feedback. Okay. Achha, if I don't convert to unity feedback, then how do I solve? By the basic method. Okay. What is the error signal now? Dekho, dhyan rakhna. Okay, this is error signal. This is the GS. This is the forward path gain. Okay, this is the output C. Okay, so what is the output C? That is error signal multiplied by the gain of the forward path. That is EG. Okay, basic block diagram se pehle error signal ka value nikal lete hain. And that error is now equal to R minus CH. R minus CH. Here they are defining R minus CH. Okay, so that is further equal to R minus C. C का value है EG H. Now take E common on the left side. Okay, so what is the E you are going to finally get? R. यहाँ पे कितना आ जाएगा? GH on the left side, 1 plus GH. तो R upon 1 plus GH. Okay, R upon 1 plus GH. Question is steady state error. Final value theorem से limit steady state error is limit S tending to 0 S into ES. Limit S tending to 0 S into ES. Now what is ES? R is को put करेंगे. Okay, input is step input. Input is step input. So what is the step input Laplace? 1 by S. Okay, so put करेंगे RS is 1 by S divided by 1 plus GH. So GH is given to me ना. GH is given to me. What is G? 4 upon S plus 2. 4 upon S plus 2 multiplied by 2 upon S plus 4. Multiplied by 2 upon S plus 4. ठीक है, तो S ये न्यूमरेटर में S कैंसिल, पुट S टेंडिंग टू 0, यहाँ पे आया 1 प्लस, ओके S इक्वल टू 0, तो 4 by 2 and 2 by 4 they cancelled. This is 1 upon 2 answer, numerical answer type question. 0.5 is my answer. Hope you have got it. Answer is 0.5. This answer is known as what? The 0.5. Clear everybody? This answer is known as what? It is known as the 0.5. Okay, done. Chalo. It not mentioned then convert to unity feedback. I told Ananta na. Not mentioned means by default you have to take error as R minus C. ठीक है. Chalo, done. Next case then. The steady state error, okay, of the system having the GS equal to 10 by S minus 1. The steady state error for the unity feedback system having the GS 10 upon S minus 1. 10 upon S minus 1. Tell me. 10 upon S minus 1. So देखो normally what you say is unity feedback है correct, okay, and S in the denominator there is one pole at origin, so we call it as type 1. Okay, we call it as type 1. Okay, ठीक है, we call it as type 1. अच्छा ठीक है, तो type 1 है, so because it is type 1 and they are asking for step input only, so steady state error for step should be how much? 0. Type 1 है, steady state error for step should be 0 ना, for step should be 0. Okay जी. Now what is the twist here? देखो, it is type 1, उसमें कोई doubt नहीं है. That is correct. We can define the type. It is correct. It is type 1. But what is the error due to step? अरे सर आप ही ने सिखाया था अभी. The error due to step for type 1 is 0. Type 1 will give finite error for ramp, 0 for step, infinity for parabolic. The problem, why it is wrong, इसको समझना. Okay, let's work on the characteristic equation dear. Let's work on the characteristic equation here. And what is the characteristic equation? 1 plus GSHS, so 1 plus 10 by S minus 1 equal to 0, leading to the case that S square minus S plus 10 equal to 0, and this indicates that second order hai na, this indicates zeta is negative. This indicates that the zeta is negative, and for zeta negative we have the growth exponential. The output is unbounded. Already we have revised that. For zeta negative the system is unstable. Okay, the poles are in RHP, the system is unstable. The system is unstable. The poles are in right half plane. Okay. Unstable system का मतलब था unbounded output. Okay. That means for t tending to infinity, the output will be infinity. For t tending to infinity, the output will be infinity. Correct, na? For t tending to infinity, output will be infinity. Limit t tending to infinity, Ct is infinity. Okay, so what should be error then? Error is known as limit t tending to infinity rt minus ct. Okay, now for t tending to infinity, rt is 1 because if I applied step input is always 1. But the value of the output at t tending to infinity is infinity and the error is also minus infinity. Yeah, I can say that the error is also unbounded. For such cases, you will also get an option that the error is unbounded or tending to infinity. Whether plus infinity or minus infinity, eventually it is unbounded. So for such cases, we can say that the error is unbounded. For such cases, we can say that what? We can say that the error is unbounded. We can say that the error is unbounded. Clear, everybody? Okay. Unbounded. You'll get an option like unbounded. Okay. No, then it will not be numerical type question, Jashwant. No, don't worry. Infinity, you cannot put in the numerical answer type question. Okay. ठीक है, आएंगे RH पे आएंगे कृष्णा. ठीक है. So guys, the error methods that you have developed, actually this comes up from final value theorem. What is the method we have done? S tending to 0 S into ES. ये सब कैसे आया था? By limit S tending to 0 S ES. Final value theorem. Final value theorem itself fails when the poles, unstable system means poles are in RHP. When the poles are in RHP, final value theorem itself fails. Final value theorem is not applicable. That is why it is giving you the wrong answer. So whatever analysis of error you have done is applicable to stable systems. ये ध्यान रखना. Whatever error analysis you have done for the stable system. Okay, for the stable system. Matlab, if I want to give a conclusion here, okay, if it is a stable system, okay, steady state error, then you can calculate by the formula limit S tending to 0 S into ES, then it is 0 infinity as per the conclusions we have learned. Okay, but if it is unstable, yeah, marginally stable. See what we learned, if it is unstable, the steady state error is also unbounded. Then you don't have to calculate by any method. It's clear answer unbounded. And if it is by chance marginally stable system, then what is the output marginally stable system? Pure oscillatory. You can't say what is the final value of the output. So you can't say what is the final value of the error. Okay, you can't say what is the final value of the error. It is indeterminate. It is indeterminate. It will be there between some value A and B. It will be oscillatory. The error value will also be fluctuating between A and B, so you can't exactly determine. It will be somewhere in between two numbers. What are the two numbers? That depends on the given data in the question. Okay, वो numbers नहीं पूछेंगे आपसे. But you have to say marginally stable system, error is indeterminate. You cannot exactly determine the error. Okay, error is unbounded for unstable system. Okay, and the error is given by the methods that you were learning till now for stable system. And when we talk about the stability, okay, we will be talking into two parts. Okay, we'll be talking into two parts, absolute stability, relative stability. Let us right now start the first method for absolute stability. Okay, that is known as the RH criteria. Okay, what is this absolute stability? Absolute stability, chalo, here it is. Absolute stability, which is a qualitative measure. But what is a qualitative measure? Which only tells whether the system is stable or not, yes or no. Whether the system is stable or unstable. It does not say anything else about the system. So it is telling you the quality of the system. Okay, it is telling you the quality of the system, whether the system is stable or not. Okay, quality, but not more than that. Not more than that का मेरा मतलब है कि suppose you are given two systems, absolute stability method like RH can only tell you whether both are stable or one of them stable, one unstable. Suppose RH tells you both are stable, but which is more, which is less? That RH will not decide. That RH cannot say. And that is why we have another set of stability criteria known as relative stability criteria. Okay, relative stability criteria, which is used to compare the stability of two systems, and it is a quantitative measure. Okay, it is a quantitative measure. Okay, we will be measuring stability, and we'll be measuring stability in terms of gain margin and phase margin. We will be measuring the stability in terms of the gain margin and phase margin. Clear? We will be measuring the stability of the system in terms of the gain margin and the phase margin. In terms of gain margin and phase margin. They are known as the quantity. The quantity is measured in terms of gain margin, phase margin, and such quantitative measure, okay, is used to compare the stability of systems. Okay, if two systems are stable, which of them is more stable, which of them is less stable? Okay, Now, the basic method for absolute stability criteria is RH. But before we go to RH, a quick highlight of, the condition of stability with respect to location of poles. Okay, if all poles are in LHP, what we know? System is stable. Even if a single pole is in RHP, system is unstable. Okay. If there is a pair of complex conjugate roots on the imaginary axis, that means pure imaginary roots. Pure imaginary root, system is marginally stable. Okay. Now, if there is a repeated pair of poles on the imaginary axis, system is unstable. Okay. If there are two different pairs of complex conjugate roots, two different pairs on imaginary axis, then the system is marginally stable. इसको एक example से समझते हैं. Okay. Let me write down some basic examples in front of you to summarize this condition. Okay. Let me write down. Suppose I give you the transfer functions, final transfer function of the system. You have 1 upon s plus 1, s plus 2, s plus 3. Okay. Next, I give you 2s plus 1 upon s plus 2, s minus 1, s plus 4. Can you comment on the stability of these? And then let me write down one more. ठीक है, पहले बताइए. Okay, no need to write down the poles, but just orally solving it up. All the poles, -1, -2, -3, all the poles are in LHP. So this system is perfectly stable. The perfectly stable means all poles in the LHP. Okay, look into it. LHP, RHP, this will give you a pole at s equal to 1. Even if one RHP pole, does not matter where the others are, even if one RHP pole, system is unstable. तो ये पहले तो basic analysis आपको पता होना चाहिए with respect to poles. Okay, now 1 is in LHP, does not matter, but 1 s square plus 9 equal to 0, s will be plus minus j root 3. This will give s equal to plus minus j root 3. Okay, तो ये क्यों unstable हुआ ये लिख दिया because of s minus 1 factor. Now similarly, because of the s square plus 9 factor, it is going to be marginally stable. Okay, then s square plus 1, roots will be plus minus j. Square means it is repeated, unstable. Repeated on the imaginary axis, then also unstable. Now, two different s square plus 1, तो s equal to plus minus j. यहाँ से solve करेंगे plus minus 2j, plus minus j, plus minus 2j. Two different pairs, then marginally stable. Two different pairs, then marginally stable. If there is a repeated pair, then unstable. ठीक है. अच्छा, if it is by chance like this, one last example. Suppose I give you 2 s plus 2 upon s minus 1 s square plus 9. Tell me this one, dear. There is a imaginary pair also, there is a RHP also. Which one will dominate? Which one should dominate? Will it be marginally stable? देखो, even if a single LHP root, then whether it is on imaginary axis या LHP does not matter, it will be unstable only. No, it's not marginally stable. This one will be unstable only, dear. Okay, RHP will dominate. By simple reason is, what happens when you get the RHP root? Na? For RHP root, you get the value of output which will be unbounded. Due to imaginary, you get the value of output which is indeterminate, oscillatory. Okay, you have one value which is finite, you have one value which is oscillatory, but this is finite, na? It is oscillatory, you can't say the exact value, but it is oscillating. And this is infinity. Infinity plus anything, infinity dominate karega, na? Infinity plus anything, infinity. So unstable. So this is the basic analysis you must know. Okay. Now, the next thing you must know is, ki whenever the question is up to first and second order, dear, you don't have to apply any RH criteria. We are going to start RH, but for first and second order, you don't have to apply anything about RH. By there, to s minus 2 cancelled, na, Vignesh? Okay. So for first and second order, okay, if all coefficients have the same sign, okay, for first and second order, the only condition is all coefficients must have the same sign, and if that is true, the system is stable. Okay, that is true, the system is stable. No, Krishna, that is mentioned. Okay, I will say that all these are closed loop transfer function. That is mentioned in the question. You cannot say and decide. Even by the name, you can't decide. Okay. Because of Bhanu, because of repeated pair on the imaginary axis. Try to take the inverse Laplace transform. When you take the inverse Laplace transform, you will get the function of the form t sin t or t cos t. Something like this you will get. In the inverse Laplace nikalna Bhanu iska, you will get something of the form t sin t, t cos t. So when t tends to infinity, okay, sine and cos are bounded. See, for this one you only get sine and cos. But for s square plus 1 whole square, okay, frequency differentiation property, S differentiation property, you will get t sin t or t cos t. And system will be, for t tending to infinity, unbounded output. System will be unstable. Okay? Okay? Yes, you can get Manasvi if it is unity feedback. Okay? So for first and second order, if all coefficients are of the same sign, okay, then the system is stable. Then the system is stable. Okay, देखो अभी हमने एक कुछ case solve किया था. Look into it. Okay, look into the second order example. There is a sign change occurred. Minus s आया. Okay, zeta negative unstable. Ultimately, all the coefficients are not of the same sign. Okay, the system is unstable. If it is s square plus s plus 10, okay, then zeta will become positive. Then the system will be stable because all coefficients will be of the same sign. Are you getting it? So for first and second order, you don't have to do anything. First and second order के लिए आपको केवल क्या करना है? If all coefficients are of the same sign, system is stable. Don't apply RH there. So ठीक है, चलो, let me take a problem here. Then we go to the higher order. Then आते हैं higher order पे. Tell me this one. Tell me this answer first of all. Some basic questions. Some basic questions. I think today we need to stop early or what? Students are tiring very early. अभी तो half भी नहीं हुआ है. That's what. So should we stop today early? If that is what students feel, okay. Unstable Jashwant. Minus 10 आए तो भी unstable. Chalo, let's come here, dear. Okay, the open loop transfer function, see specified, now what they have given is open loop transfer function. Okay, for a unity, normally open loop transfer function, I mean GSHS. But if it is unity feedback, so it is only GS, okay, no problem. Okay, so open loop transfer function for unity feedback is given to you, k s plus 2 upon s plus 1 s minus 7. Okay, for k greater than 6, for k greater than 6, what is the stability characteristics of an open loop and closed loop? So dear, what are open loop poles here? What are the open loop poles? In short, I will call OLP. OLP से मेरा मतलब है open loop poles. Okay, so what are the open loop poles? Okay, poles of the open loop transfer function. उसके लिए तो कुछ करना ही नहीं है ना. They are talking about stability of both open loop and closed loop. Okay, so for open loop pole, the open loop system, the poles are -1 and +7. You have one RHP. Okay, any one RHP pole unstable. Who is unstable? By who is unstable? Open loop is unstable. I don't know about closed loop right now, but who is unstable? Open loop is unstable. Who is unstable? Open loop is unstable. Clear everybody? Clear everybody? चलिए आगे आते. Okay. Now closed loop की बात करेंगे. For closed loop, okay. For closed loop, either calculate the closed loop transfer function or directly go to the characteristic equation. Okay, directly go to the characteristic equation. Okay, 1 plus GS equal to 0. HS तो 1 है. So 1 plus K S plus 2 upon S plus 1 S minus 7 equal to 0. Now this is going to be solved as S square. Then you have -7 plus 1. So -6S minus 7 plus KS plus 2K equal to 0. So I have S square. Okay, arranging the terms, K minus 6 into S, 2K minus 7 equal to 0. Now tell me, dear, this is second order. What you have got second order. So I told you, if the system is up to first and second order, we don't need any RH here. Only coefficient sign. Only coefficient sign. ठीक है, अब coefficient का sign देखेंगे. You are given a condition. You are given the condition. Don't forget that K greater than 6. Okay, you are given the condition k greater than 6. So if k greater than 6, so k minus 6 is positive, na? Ye given hai k greater than 6. Okay, so k minus 6 is positive. This is also positive, 1 into s square. Acha, if k greater than 6, so 2 se multiply kiya, so 2k greater than 12. Okay, so 2k if it is greater than 12, automatically 2k greater than 7 also. 12 se bada hai, to 7 se to bada hi hai. Okay, so this is also plus. If 2k greater than 7, so 2k minus 7 is positive. All coefficients are of the same sign. Do I need any RH here? No. Because it is second order. See why I have discussed this question separately, because I have seen many students for second order they will start and for second order they will start and you know what to do? They start applying the RH. Nahi karna hai yahan pe RH. You don't have to apply any RH here. The system is gonna be stable. Because it is second order, RH not required. So the correct answer should be the open loop was unstable, closed loop is stable. Answer is D, unstable and stable. Sorry, option is C, unstable and stable. Look into it, it is C. Stability of the final system decided by closed loop only. Correct, Krishna. For closed loop transfer function, we just take the characteristic equation. ठीक है जी? Okay. But always remember, never have a confusion. Let me write down one important point here. Dekho, stability of closed loop system depends on what? Stability of closed loop transfer function depends on what? It depends on the poles. See, for any transfer function, stability depends on poles. So it depends on poles of closed loop transfer function. Poles of closed loop transfer function are nothing but the roots of characteristic equation. Yes or no? Any confusion? Abhi bol do, because this is going to be interchangeably used. Sometimes I will use the word poles of closed loop transfer function. Sometimes I will use the language roots of characteristic equation. If you have any confusion, tell me straight away. Because we are going to go towards root locus and other plots also. We'll talk about these languages, okay? So when I say poles of closed loop transfer function, they are nothing but the roots of characteristic equations. That is what I used in this particular question. Okay? So up to second order, you don't need any RH criteria. Okay, for first and second order system, if all the coefficients have same sign, that is sufficient. System is stable. But for higher order, above condition is necessary but not sufficient. Above condition is necessary but not sufficient. ठीक है? चलो, for example, पहले इसको समझाता हूँ. Sometimes students don't know about this necessary and sufficient condition. Suppose I give you an example. Let me tell cubic only. Okay, s cube plus s square plus 5s plus 10 equal to 0. Okay, I'll tell you next example. S cube minus s square plus 2s plus 5 equal to 0. Can you comment on the answer here? Can you comment on the answer here? Dekho dear, I can comment on the second one. Okay, in the second one, all the coefficients do not have the same sign. The system cannot be stable. That is what I can comment. Okay, I told you the above condition is necessary. Above matlab same sign. Necessary condition itself fails. Necessary condition itself fails. Okay, so here you can say unstable. But in the first example, all coefficients are plus, 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 plus. All coefficients are of same sign. Can you say that the system is stable? Can you say system is stable? Can you say that the system is stable? Dekho, dhyan dena. Can you say the system is stable? Can you say that the system is stable? Dekho, here I can say that necessary condition satisfied. Necessary condition satisfied. System may be stable. I'm not saying it is not stable. Okay. But we cannot conclude. We have to check sufficient condition now. Okay. In the second example, you don't have to check anything because necessary condition fails, system unstable. But here you have to check sufficient condition. And what sufficient condition? The sufficient conditions ke liye we solve the Routh-Hurwitz. For sufficient conditions, we solve the Routh-Hurwitz. Okay. Sabse pehle, let me repeat the necessary condition. Now, it may be an nth order equation also in the form of s power n. It may be nth order equation. Necessary condition so that the above equation does not have root in the RHPR. Okay, the necessary condition is all are of same sign. Matlab all should be positive strictly. Zero bhi nahi hona chahiye. Okay, so I am specifying the two parameters here. Okay, all of the same sign. Okay, and none of the coefficient must be missing. Okay, none of the coefficient must be missing. Okay, so necessary condition ke liye I can say that all these coefficients A0, A1, etc. must be greater than 0. Okay, and all AI, okay, must be non-zero. Okay, 0 ho gaya to ek coefficient missing hoga, so none of them should be missing also. Okay, that means all should be non-zero and strictly positive. Okay, for sufficient we need to solve the Routh-Hurwitz. For sufficient condition we need to solve the Routh-Hurwitz. Now let me start with this one only. What is the Routh-Hurwitz corresponding to this one? S cube plus S square plus 5S plus 10. Okay, I have S cube plus S square plus 5S plus 10 equal to 0. Routh-Hurwitz, I'll explain you the Routh-Hurwitz, guys. For Routh-Hurwitz, what you have to do, okay, then we will we'll go to the higher order also. Okay, Routh-Hurwitz के लिए आपको क्या करना है? Okay, take the first two rows, okay, S cube and S square, highest order term S cube, then S square, and arrange the alternate coefficients. The alternate coefficients 1 and 5, and then next alternate coefficients, that is 1 and 10, and now solve. S ki power 1. Now there will be the next row S ki power 1, which will be solved, okay, by taking the determinant of these four elements. Okay, taking the determinant of these four elements. Determinant ke liye kya karoge? The first column is always the first column of the above two rows, and if you are calculating this element, so this is the second column. Dhyan dena. We will take for higher order for more clarity. This will be the second column. Now you solve the determinant, and that too in the reverse manner. Normally you solve determinant 10 minus 5. You have to solve reverse manner. That is 5 minus 10. Okay, 5 minus 10 minus 5 upon, okay, minus 5 upon 1. This will be minus 5. I will explain you the calculation separately. Isko thoda sa separate le lete hai. How I have obtained this? This is 1 into 5 cross multiply. Okay, minus 1 into 10 divided by what? Divided by the first element of the above row. Just go to the above row. What is the first element? 1. So I divide by 1. This is how we obtain. This is minus 5. Okay. Now dear, look into it. What about this element? Whenever you are calculating any element, I told you na, the first column will be treated as the first column of the above two row. Ye fix rahega. But the second column will be the column next to it. Now what is the column next to it? Nothing. Zeros. It is nothing. Nothing means 0, 0. Okay, so if a column of a determinant is 0, determinant answer will be 0 hoga. Okay, that means last element of every row will always be 0. Last element of every row will always be 0. Now next S power 0. You have to go up to S power 0. So now dear, quickly cross multiply. Minus 5 into 10 divide minus 0. So ye to hata dijiye. Minus 5 into 10 divide by minus 5. Divide by this first element of above row. So minus 5 bhi cancel hoga. You will be left with 10, and then last element is 0. Okay. Now I told you, for sufficient conditions you need to solve the Routh-Hurwitz. Okay sir, I have solved the Routh-Hurwitz. मैंने आपको बोला था necessary condition fulfilled. Okay, still I can't say system is stable. For stability we have to check the Routh-Hurwitz for higher order. Second order के लिए check नहीं करना होता है. Now this system is actually unstable. Why? This system is actually unstable because it has sign changes in the first column of the Routh-Hurwitz. So you have to investigate the first column of the Routh-Hurwitz. You have to investigate the first column of the Routh-Hurwitz. So here it is the sufficient condition for you. The sufficient condition so that the characteristic equation does not have RHP root is there should be no sign change in the first column of the Routh-Hurwitz. There should be no sign change in the first column of the Routh-Hurwitz. Okay. Then if there are sign changes, there will be RHP roots. How many? The number of poles in the RHP is equal to number of sign changes in the first column of the Routh-Hurwitz. Number of sign changes in the first column of the Routh-Hurwitz. Okay, so because of the sign changes, the system is unstable. Okay, the system is unstable. Okay, if they only ask yes or no, to unstable. Okay, but now how many RHP roots? How many RHP roots of the characteristic equation? How many RHP roots of the characteristic equation? How many sign change? See, don't count the negative number. Sometimes students say answer is 1 because there is one negative number. I am not asking you to count negative number. You have to say sign changes. Okay, plus 2 minus is a sign change. Minus 2 plus is another sign change. So 2 sign changes. Okay, so number of RHP roots will be 2. Acha, if RHP roots is 2, now tell me how many LHP roots? Now tell me how many LHP roots? Dear, you are solving a cubic equation, na? You are solving a cubic equation. Okay. So 2 are in RHP. Okay. Remaining 1 is in LHP. Remaining 1 is in LHP. Okay. So 2 RHP, 1 LHP. Sir, will there be any j omega roots? Will there be any roots on the imaginary axis? Okay. Will there be any roots on the imaginary axis? Will there be j omega roots? Okay. मैं एक remark लिख देता हूं. Why I did not think about j omega root here? Don't think about j omega roots. Imaginary roots. Okay. Until rho of 0. जब तक rho of 0 नहीं आता है. There is a very, very special and the most important case of RH. Rho of 0. Okay. Until you get that rho of 0 condition. Until you get the rho of 0 condition, you will not think about the j omega roots. Clear? You will not think about the j omega roots until you get the rho of 0. Until you get the rho of 0. Clear everybody? ठीक है चलो. Until you get the rho of 0. तो तब तक शांत रहेंगे, तब तक j omega है ही नहीं. Either L or R. Either L or R. ठीक है. So this is what is the sufficient condition. Okay. There should be no sign change in the first column of Routh-Hurwitz. Of course, there are some limitations of Routh-Hurwitz which you must be aware. It is applicable only for polynomial equation. There should not be, exponential or sinusoidal term. Polynomial means like s square, s cube, s power 4. Polynomial terms होना चाहिए. Okay. It is applicable when the coefficients are real. Okay, coefficients should be real. Okay, like jo coefficients are na, A0, A1, A2, A3, all that should be real. Okay, it can only tell the quantity of RHP roots. Now here, I have told you that how many RHP roots are there too. But where they are? Where they are? Can you say the location by this method? No. Can you say the location of RHP roots by Routh-Hurwitz? No. Okay, can you tell out of the two RHP roots whether these two are complex conjugate or whether both of them are real? No. So listen to me, they cannot tell you the location and they cannot also distinguish whether these two are real or these two are complex conjugate. They can't distinguish that also. Okay, but for stability we don't need also. We only need the location. Location means region, not the precise location. If it is in RHP, if something is in RHP, system is unstable. Marginally stable निकाल सकते हैं RH से. Will come RH, ROZ. Let's come to the ROZ case, rho of 0 case. Okay. So that's what. It can only tell the quantity of roots, okay, but not exact location, and it can't distinguish between real and complex roots. Okay, these are some things that you must know before applying the RH criteria. Okay? Before what? Applying the RH criteria. Okay? Before applying the RH criteria. Next. This was done. This was done. Now let's also practice a higher order, yaar. Let's practice a higher order also. ये हो गया fifth order. Let's make the Routh-Hurwitz corresponding to fifth order. And okay, for fifth order, okay, there will be the Routh-Hurwitz starting with the first two rows, that is s power 5 and then s power 4. And then I will arrange the alternate terms. So 1 and 2 and 5. सबसे पहले आ जाएगा 1 and 2 and 5. And then remaining alternate terms, okay, that is 1.5 and 4 and 10. 1.5 and 4 and 10. Correct? Correct. Now, even if you have any doubt in calculation, now it should be rectified. So now I start with the s cube. Now I am going to take the s cube. Okay, what is going to be the s cube? 1.5 into 2, that is 3. 3 minus 4. 3 minus 4, minus 1 upon 1.5. Okay, this is minus 1 upon 1.5. ठीक है. Now for simply, चलो पहले इसको complete करते हैं. ठीक है, minus 1 upon 1.5. 1.5 into 5, 7.5. Okay, 7.5 minus 10 minus 2.5. Divided by what? See, I told you, whenever you are solving, this will always be the first column. Second column, if you are calculating the element, second column is the column next to it. जो ऊपर दिख रहा है ना, next to it. अच्छा, always divide by the first element of the above row. Always divide by the first element of the above row. Okay, so first element is 1.5. Okay, and then 0. Achha, now for simplicity, dear. Now for simplicity. Now what? That is your choice. That is your choice. But for simplicity, what you can do is, you can multiply any row by any constant number. By any positive constant number. You can multiply any row by any positive constant number. ठीक है. So let's multiply by 1.5 or rather I am multiplying by 3. थोड़ा और easy हो जाएगा. So I multiply by 3. I get the s cube row now equal to into 3 किया तो ये हो जाएगा -2 into 3 किया तो ये हो जाएगा -5. 2.5 into 2 and this will be 0. For simplicity, for ease of the calculation. Okay. For ease of the calculation. ठीक है. ठीक है, for ease of the. अच्छा, don't multiply by a negative number, otherwise sign change miss हो जाएगा. Okay, multiply by any positive number, but not by negative. Okay, so that is my new s power 3 row. Now I will proceed. S power 2. Now when I am proceeding with s power 2 here, इसको नहीं देखना है अब. This is gone. ठीक है? Now this is gone. Okay, now this is gone. So you have to take such cross multiplication. -2 into 4 -8. Minus हो गया +7.5. तो -0.5 is divided by -2. Divide by the first element of the above row. No, so that is -2. So that is actually 1/4. Okay, minus cancel. Okay, now what about this element? Now देखो यहाँ पे आ जाएगा -2 into 10 -0 divide by -2. तो -2 into 10 divide by -2 only 10. Only 10. Last element always 0. So now s power 1. S power 1 1/4 into -5. 1/4 into -5. Okay, that is -5/4. Achha, again if you want you can multiply it by 4. That is your choice. Again if you want you can multiply this by 4. Okay, so now this if you multiply by 4, let me write 1. If you multiply this also, you have to multiply entire row by 4. So this is 1 and this is 40. This is the 1, this is the 40. तो देखो अब जाएगा 1 into -5. -5 minus plus 80. तो 75 आया. Divided by first element of the above row, that is 1. So only 75. Okay, look. Okay, for the next element, this is the next column. Entire column 0, so element will be 0. Last element anyway 0. Now s power 0 row. So look into it. 75 into 40 minus 0. So 75 into 40 divide by 75. So bacha only 40. This will be 0 because these two elements are 0. Last element of a row is anyway 0. ठीक है जी. So now, do you have any sign changes, dear? This multiplication by 3 or multiplication by 4, that is totally your choice. I have multiplied this by 4, okay? Into 4. But if you multiply, you should multiply the entire row. Okay, now look into the sign changes. Positive. Isko nahi dekhna hai, guys. This is gone now. You have to worry about this one. Okay, you have to worry about this one. Okay, so 1.5 say -2. This is a sign change. -2 say +1. This is also a sign change. 1 to +75, +75 to +40, no sign change here. Okay, no sign change. But there are total 2 sign changes. Okay, there are total 2 sign changes. Okay, so how many roots in the RHP? That is 2. Number of sign change corresponds to number of sign changes. No, it is 2, Rajesh. एक बार check करेंगे. And because there are 2 RHP, even if one RHP system is unstable, we know. But there are 2 RHP here. There are 2 RHP here. ठीक है. Now next, how many in LHP? Fifth order equation, तो 5 minus 2 will be 3. Don't think about j omega. मैंने आपको strictly बोला है ना. Don't think about j omega till you have a row of 0. Don't think about j omega till you have a row of 0. Okay. Till you have a row of 0. ठीक है. Now guys, if you feel that you are extremely hungry and you can't resist, you can have lunch according to yourself. But I will stop after some time. I will give you lunch break, but I will stop after some time. I will not stop in the middle of topic at least. Okay? So I will stop after some time. Okay, let me continue with the flow. Okay? Now next case, dear. Okay. When the first element of a row becomes 0. Entire row की बात नहीं कर रहे, but when the first element of a row becomes 0. Only when the first element of a row becomes 0. Okay, now what to do? Let's understand directly by a problem. Okay, when the first element of a row becomes 0. Okay, हमें तो नहीं पता ना 0 होगा कि नहीं. तो normally I start with the Routh-Hurwitz. Let us start with the Routh-Hurwitz calculation. Alternate terms, so 1 and 2 and 11. 1 and I have 2 and I have 11. Then s power 4. 1 and 2 and 10. This is 1, this is 2, this is 10. Now I have s ki power 3. Now I have the next, that is the s ki power 3. Okay, s ki power 3. Okay, 2 minus 2, cross multiplication, so you get 0. Okay, 11 minus 10. Okay, 1 upon 1, so this is 1. Last element 0. last element 0. Okay? Now S square. Now what happens if you want to design S square row now? What happens if you want to design the S square row? Normally what do? You cross multiply but divide by the first element of above row. Whatever result of cross multiplication, but you divide by 0. Every element, some calculation, divide by the first element of above row. Okay. So all these elements are coming to be divided by 0 case. All these elements are coming to be divided by 0 case. So system may not be stable here. All these elements are coming, stable to chhod dijiye. Okay, but how can you write down the values here? All the values are coming to be undefined. You can't move forward. Your next row is stuck. Your next row is stuck. So what is that we do here, dear? Okay, that is, understand the problem. See, so when first element of a row becomes 0, you have identified what the problem is. Okay, ab next kya karne wale ho? Next what you're going to do is, okay, remove this 0 and call it as epsilon. Let us say it is epsilon, which is some small variable. It is an arbitrary some small variable, maybe positive 0, negative 0, doesn't matter. It is some small variable. Okay, tending to 0. Tending to 0. Now solve the Routh-Hurwitz in terms of epsilon. Okay, so you have 2 epsilon minus 1 upon epsilon. Cross multiply kiya na. Now next, 10 epsilon minus 0 upon epsilon. So bacha only 10. Then 0. Then I have S ki power 1 row. Okay, S ki power 1. So solve again the cross multiplication. 2 epsilon minus 1 by epsilon into 1. Okay, ultimately divide karoge to yahan se 1 aayega. Minus 10 epsilon. Minus 10 epsilon upon this factor, that is 2 epsilon minus 1 by epsilon. So ये epsilon भी ऊपर चला जाएगा. So I'll write down the simplified answer. 10 epsilon square upon 2 epsilon minus 1. This will be 0 because the entire column on the top is 0 now. Last element anyway 0. S power 0 last row. This is some element, suppose x multiplied by 10. ये तो हो गया minus 0. So x multiplied by 10 divide by x. So only 10. This will be 0 because see, this column is 0. Last element is anyway 0. This is my Routh-Hurwitz complete. Okay. This is my Routh-Hurwitz complete. And because my Routh-Hurwitz is complete, okay, now I will only investigate the first column dear separately. What you have to do is investigate the first column separately. Okay. So it is 1, 1, epsilon. Okay, yeah, rather I will write down directly the value of first column as epsilon tending to 0 because 0 was replaced by epsilon. I told you epsilon is a very small variable. Okay, so let's now put epsilon tending to 0. So 1, 1. Okay, now this is epsilon tending to 0. Okay, now 2 epsilon minus 1, that is minus 1 upon epsilon 0, that is minus infinity. So, of course, it's undefined value, but at least you get the sign whether it is plus or minus infinity. Next, aa jayenge 1 minus 10 epsilon square by 2 epsilon minus 1. So, 10 into 0 is 0. So, 1 minus 0. This is 1. And last element is fixed, that is 10. So, now do you have any sign changes? Take it, dear, it is plus 0. Let's count it in plus sign. Anyway, 0 does not have sign, so let's count it as plus. This is minus. This is plus. This is plus. Okay. Leads to sign changes in between. Plus to minus occurred, minus to plus occurred. Okay, there are 2 sign changes, so there will be 2 on the RHP and 5th order again. Okay, so 5 minus 2, 3 on the LHP. 2 RHP, 3 LHP. That is 2 RHP and 3 LHP. Clear everybody? 2 RHP, 3 LHP. So procedure is same, Routh-Hurwitz method is same. Only thing is when the first element is 0, okay, when the first element is 0, in between, please include the epsilon tending to 0. Okay, then solve in the regular manner. Now coming to the most important case of RH. Okay, the ROZ case. ROZ matlab, ROZ se mera matlab hai, you get a row full of zeros. You have a row of zeros. So when one complete row of Routh-Hurwitz becomes 0, the most special case. Priyanka, मैंने बोला था, don't think about J omega till you have ROZ. And now let's start with ROZ. Okay, first let's take a problem and then understand this procedure. Okay, let's take the problem and understand the procedure. Then let's come to the conclusion. Here it is one problem. First we have to see whether ROZ coming. Then only I'll tell you na, ki what to do next. Okay, so let me start with the RH here. Starting with the first row S power 6 and then next is S power 5. S power 6, S power 5. S power 6 तो 1 and 5 and 2 and minus 8. 1 and 5 and 2 and minus 8. S power 5, 1 and 3 and minus 4. Perfect, yeah. 1 and 3 and minus 4, and then if last is not given, that is 0 of course. Chalo. Now let's continue. S power 4. Okay, 5 minus 3, 2, 2 by 1 is 2. Okay, calculations, hope you are comfortable yourself also. 2 minus minus 4, that is 6, 6 by 1. This is 6. Okay, 1 into minus 8, ये तो हो गया 0, divided by 1. So this is minus 8. Last element 0. S की power 3. S raised to the power 3. 2 3s are 6, minus 6. 0. ठीक है. 6 into minus 4, minus 24. Minus minus 24. तो ये भी same हुआ तो 0. This will anyways be 0 because the column is 0. Last element of a row is always 0. And now you have identified your problem. Isn't it? Here is what I was talking about. This is what I was talking about. This is what we have been talking about. You get a row completely 0. This is known as ROZ. This is known as row of 0. Now, wherever you have a row of 0, the first step is you will form the auxiliary equation. The first step is you will form the auxiliary equation. How do you form the auxiliary equation? Okay, by using the, okay, we call the auxiliary equation as suppose AS equal to 0 by using the coefficients of the row above the row of 0. ऊपर वाली row को refer करेंगे. Okay, by using the coefficients of the row above the row of 0. That is S power 4 row. The first coefficient is 2. Okay, so it will start with 2s power 4, and then we know that in any Routh row, the coefficients are coefficients of alternate term. So if this is 2s power 4, next should be 6 with s square. 6 with s square. Then next is minus 8 with s ki power 0. S ki power 0 means only 1. So only write down minus 8. This is your auxiliary equation. Clear everybody? Okay. Now, next step is differentiate the auxiliary equation. Differentiate the auxiliary equation and put it equal to 0. Okay, solve d by ds equal to 0. Okay, so when you differentiate, okay, 2 4s are 8, 8s cube plus 6 2s are 12s, 8 ka differentiation 0, so you have 8s cube plus 12s equal to 0. Or if you cancel 4, so it can be 2s cube plus 3s equal to 0. 4 cancel kar sakte hai na? So 2s cube plus 3s equal to 0. Now, after solving this, this will give you the modified s power 3 row. S power 3 row became 0, na? So I have given you how to modify that row of 0. This is known as the modified s ki power 3 row. This is known as the modified s ki power 3 row. And what is the modified s ki power 3 row? Coefficients are 2 and then 3. That's it. Rest will be 0, 0. Ye raha. So let me come up here. Let me write down this row of 0, the modified row of 0, star s power 3, with the coefficients which is 2 and 3. Only 2 and 3, so others means of course 0. Okay. So dear, whenever you have ROZ, the equation above it, the row above it actually, will be responsible for making the auxiliary equation, and that I have made. For auxiliary equation, then we differentiate and we got the modified s power 3 row. Pehle to procedure hai, then some important bullet points I will tell. Okay. Now after that, continue with the Routh array in the regular manner. Continue with the Routh array in the regular manner. तो ये हो गया s square row पे जाएंगे. 2 6 12 minus 2 3 is 6. तो 12 minus 6 6 6 upon 2 will be 3. Correct bola na? 12 minus 6 is 6 by 3. Next 2 into minus 8, you get minus 0 divided by 2. So this is minus 8. This should be 0 because the elements are 0. Isko count nahi karna hai ab, okay? Okay. And last element of a row is anyway 0. Coming to s power 1 row. Okay. 3 3s are 9 minus. Okay. 3 3s are 9 minus of minus 16. So 9 plus 16, 25. Correct na? Ha, correct. This should be 0 because this is 0. Again, next element 0 because the column itself is 0. Last element always 0. Coming to the s power 0. Okay. Keep checking the calculations. Okay. Be alert. Okay. 25 into minus 8. Yahan to ho gaya 0. So 25 into minus 8 divide by 25. So it should be minus 8 only. -8 only, no doubt. Okay. Now dear, from the basic analysis, okay, do we have any sign changes? 25 by 3. Acha, sorry, I did not divide by 3. No problem, guys. Okay, even if you divide by 3, no problem. You can multiply by 3. That's not a big thing, okay. 25 by 3 into 3 bhi kar sakte later on. But chalo, you say 25 by 3, let me write down 25 by 3. You can just imagine I multiplied throughout by 3. That is also acceptable. Okay, but chalo, it is 25 by 3. Okay, then still 25 by 3 into -8 upon 25 by 3, ye -8 hoga. Okay, now, do you have any sign change in the first column? Do you have any sign change in the first column overall? Yes. At the last, this is plus, 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 -8. There is a sign change at the last. There is a sign change at the last. Clear, everybody? There is definitely a sign change at the last. Okay, let's accept that. Okay, so now I can say that, okay, how many are the RHP roots? 1, because of the 1 sign change. Okay, okay, how many are the sign change? 1 sign change. Okay, okay, that is 1. Okay, now how can I say how many LHP roots? देखो, सबसे पहले आएगा J omega roots. Okay, here there may be the possibility of J omega. Then what is the order of the system? It is a 6th order. We have a 6th order characteristic equation, correct? Yes, 6th order. So then the LHP roots will be 6 minus RHP plus this J omega roots. Now, how do you know how many J omega roots are here? How do you know how many J omega roots are here? Okay, I will now take the help of auxiliary equation. Now I will take the help of auxiliary equation. I will tell you the details also. I will tell you the shortcut also. Details भी बताऊंगा, shortcut भी बताऊंगा. ध्यान रखना. Okay, I'll tell you the details. I'll tell you the shortcut, both of them. Okay. So first of all, what is that auxiliary equation? Okay, auxiliary equation was 2s power 4 plus 6s square minus 8 equal to 0. चलो 2 को cancel कर दो. तो s power 4 plus 3s square minus 4 equal to 0. Okay, यहाँ पे detail समझना important है. It is important. That is why I'm going to details. Otherwise, I'll tell you the shortcut directly. Okay, so now, okay, we can factorize it. Okay, plus 4 and minus 1, correct. So s square plus 4, because plus 4 minus 1 is 3. Plus 4 into minus 1 will be minus 4. So s square plus 4, s square minus 1 equal to 0. S square is minus 4 and plus 1. So S will be equal to plus minus 2j. See, every time you can't solve equations. Ye to by chance solve ho raha hai. I'll tell you that is why the method and shortcut also. Okay, under root of minus 4 plus minus 2j, under root of 1 plus minus 1. Okay, when you are going to draw these roots, how will the roots appear? Okay, when you locate the roots of the auxiliary equation, how the roots are going to look like? Okay, so you have the roots plus and minus 2j. And plus and minus 1. You have the roots plus minus 2j plus minus 1. Okay, plus minus 1. Okay, this is clearly suggesting this is RHP. I told you there will be one RHP. Okay, there will be one RHP. Okay, and this is what are J omega roots. You have a J omega pair. Okay, so dear, how many on the J omega? 2. There is a pair, means total 2 on J omega. So then how many on the LHP? 6 minus 1 plus 2. Your answer is 3. So 1 RHP, 2 on J omega, 3 on the LHP. That is the complete statistics of the question. And even if there is a single RHP root, the system is unstable. The system is unstable. Ye sure ho gaya. The system is unstable. Okay ji. The system is unstable. Correct hai. Done hai. Cool hai. So chalte hain next ki taraf. Okay. So this is the detailed method. Okay. Detailed method. Now, before I give you the shortcut. Okay. Before I give you the shortcut. Okay, before I give you the shortcut, have a look into it. Okay, let us go back to some more important points and then I'll talk about the shortcut. देखो solve कैसे करना है मैंने बता दिया. First we form auxiliary equation, then we differentiate this, and then we replace the rho of 0 by the equation, by the derivative equation. Okay, by the derivative equation. Okay, by the derivative equation, and then we continued with the Routh. Okay. Now, the rho of 0 will always be observed in the odd power. Very, very important key points. When I'm telling you key point, these are actually very important key points. Okay. Rho of 0 will always be observed in the odd power row. देखिए यहाँ पे, in this question, rho of 0 is in which row? S power 3. It will always be observed in the odd power. It will always be observed in the odd power. Clear everybody? ठीक है. Yes, Venkata, about stability you can say from necessary condition. But you know, most likely the questions they are coming these days, they are not only talking about stability. They ask you how many LHP roots, how many J omega roots. So for that we need to do the analysis. ठीक है? ठीक है? Okay. So now rho of 0 is always in the odd power row. Number 1. ROZ is in the odd power row. Any root of auxiliary equation will also satisfy the characteristic equation. Any root of auxiliary equation is also the root of characteristic equation. That means auxiliary equation is nothing but it is a factor of the auxiliary equation is one of the factor of the characteristic equation. What I can tell you is, let's go back here. We have got the root of auxiliary equation. Suppose I have got any 4 roots I have got. Now take any one s equal to 1. Dear, take any one s equal to 1. What will happen? At s equal to 1, when you take the characteristic equation, देखो s equal to 1 लिया तो 1 plus 1 plus 5 plus 3 plus 2 minus 4 minus 8, calculate 100% 0. You add and subtract all these numbers, 110% 0. This means what? S equal to 1 is also a root of characteristic equation. And that will be valid for all 4. You can try, but that will be valid for all 4. Okay, so the next point is every root of auxiliary equation is also the root of characteristic equation. Okay, now very, very important point. Okay, what happens when the rho of 0 is present? The presence of rho of 0 lead to one or more. I'm not telling one of them, it lead to one or more of the following condition. इनमें से कुछ ना कुछ तो होगा, but maybe multiple possibility. First possibility, there is at least one pair of imaginary roots. ये रहा, the first possibility. There is at least one pair of imaginary roots, plus minus j omega format. Okay. Second possibility, there is at least one pair of real roots having equal magnitude but opposite sign. Okay, having equal magnitude but opposite sign, plus minus a. Both of them are real, magnitude a, like we got plus minus 1, na? Okay. Okay. Equal magnitude, opposite sign, plus a, minus a. Third possibility is quadrature. There are two pairs of complex conjugate poles located with respect to, symmetrically with respect to imaginary axis. Now, there may be poles of the form. Suppose this is x plus jy, its conjugate x minus jy. Okay, there may be minus x plus jy and its conjugate minus x minus jy. That is the third possibility. So in any type of problem, okay, at least one of them will exist. Yeah, more than one possibility can also exist. As you see in our current problem, possibility number 1, possibility number 2, both came up. But whenever there is auxiliary equation, the roots will be any of this part. इसके अलावा कुछ नहीं होगा. Either case 1 or 2 or 3 or combination of this, but nothing other than that. I will take a question where you will see this possibility also. Okay, that simply means that, very important point, roots of auxiliary equation, they are always symmetric with respect to origin. I will put down that they are symmetric with respect to origin. Plus omega above, minus omega below. Plus a right, minus a right, left. Okay. Now, this is equal distance. This is also equal distance. Matlab all of them are symmetric with respect to origin. Okay. And because of the symmetry, देखो case number 1 में, how many LHP roots and how many RHP roots? Okay. None. Neither on the left nor on the right. They are on the imaginary axis. So, left and right both are 0. In the case number 2, how many left, how many right? Both are 1 each. Okay. In the case number 3, how many left, how many right? Both are 2 each. This is 2 right, this is 2 left. Okay. So, roots of auxiliary equation are symmetric with respect to origin. And next very important point is, okay, the number of LHP and RHP roots are equal. L equal to R always. Okay. L equal to R always. Okay. And this is going to become my shortcut to solve the problem. L and R are equal. Yeah, I can say that R equal to L. But what is L? What is L? Dear, you have auxiliary equation. ये रहा आपका auxiliary equation. ठीक है? I am asking you how many R roots for auxiliary equation? बताइए. How many RHP roots for any equation? बाबा नाम में क्या रखा है? Whether it is characteristic equation, auxiliary equation, A equation, B equation, you have an equation and you have the Routh-Hurwitz corresponding to it. This much is the Routh-Hurwitz due to the auxiliary equation. Forget the above part. Okay. How many RHP roots due to any equation? That depends on only sign changes. Now what else you need? That only depends on sign changes. So how many sign changes? From this, ऊपर वाला नहीं देखना है. Forget the above. From this, how many sign changes? One sign change only. One sign change. Getting it? One sign change. One sign change. This is going to behave as the shortcut for you. Okay. ये मैंने detailed method बताया. Okay. अब बताऊंगा मैं आपको shortcut. Okay. Okay. First, let me read out the shortcut for you. That for auxiliary equation, number of LHP and RHP roots are equal. Okay. Number of LHP and RHP roots are equal. Okay. And how many RHP roots we all know? How many RHP roots is number of sign changes. But only below the auxiliary equation. If there is a sign change by chance above, you have to discard it. Only auxiliary equation and below what are the sign changes. Okay. So, shortcut ke liye you will always make two tables. One is for auxiliary equation, one is for characteristic equation. One is for the auxiliary equation, one is for the characteristic equation, dear. Okay. For the auxiliary equation and characteristic equation, both of them first write down the order. Okay. For auxiliary equation, my order was 4. Characteristic equation ka order aaya hai 6. Okay. For auxiliary equation, order is 4. For characteristic equation, order is 6. Okay. Now, for auxiliary equation, L and R are always equal. And equal to how much? Number of sign changes below. So, how many sign changes are here? Yahan pe hai 1. So, L and R are both equal to 1. 1 each. They are both equal to 1. So, how many on J omega, dear? Okay. How many remaining on J omega, na? Okay. J omega. So, total order of the auxiliary equation 4. 4 minus 1 plus 1, that is equal to 2. This is the shortcut to be applied without detailed method. But details mein bhi yahi aaya tha. 2 on J omega. 1 L, 1 R. Same thing details told you. But you don't have to solve detailed. You have to just make this table. L and R are equal to the sign changes. Okay, then remaining J omega. Now let's come to the characteristic equation. In the characteristic equation, always start with R. Total number of R roots, total number of RHP roots is total sign changes, and total sign changes bhi dekha tha na humne. Total sign changes is also 1. Even if I see from top to bottom, the total sign change is also 1. Okay, that was already concluded. Okay, so R to 1 hai, but what was not concluded was J omega. So first you write down J omega, and J omega ke liye hi I have solved this. From here you will write down J omega. How much? From here you can say that there are 2 on J omega. Then how many on the L? Remaining 6 minus 1 plus 2, 3 on the L. 3 on the L. केवल ये shortcut follow करना है, and RHP 1 unstable. Acha, one very important point to be noted here is, just a second. One very important point to be noted here is, if you look into all the possibilities once again, okay, this is pure imaginary roots. The system is marginally stable. But here we have a RHP root, here we have RHP root. System is unstable. This clearly means that whenever you get ROZ, the system is either marginally stable or unstable. It can never be purely stable. Okay, it can never be purely stable. Okay. System is either marginally stable or unstable. Okay. But it cannot be stable. It cannot be purely stable. Whenever you get ROZ, ये confirm कर देना. System stable हो ही नहीं सकता. Clear everybody? System can never be stable. Chalo. So now let's move ahead. Okay. Let's move ahead. This is the shortcut for the auxiliary equation. Very, very important shortcut has been discussed. Okay. Look into this method. Okay, very important this is to help you simplify the question, and then, okay, a homework for you. Okay, same procedure. Okay, s power 4 plus s square plus 1. Actually, when you solve the roots, you don't need to solve, but I'm telling you, this is the quadrature case. This is the one which is going to fall in the quadrature case. Okay, the third possibility. But I'll leave it as homework for you. Let's go to other variety. Okay. Now, next case. Next type of question from RH. A lot of time gone here. Okay. Next type of case from RH. Okay. The range of K for the system to be stable. The range of K for the system to be stable. Okay. The range of K for the system to be stable. Now listen to me. I told you whenever ROZ comes, system can't be stable. Okay. तो देखो system को stable होने के लिए दो points आपको याद रखना पड़ेगा. Okay. Number one, there should not be any ROZ. Okay. And number two, no sign change in first column. Because if there is sign change in the first column, that means RHP roots, and RHP roots means unstable. And if there is a row of 0, then also system may be marginally stable or unstable. Okay, system cannot be stable. So for stability, you need no ROZ and no sign change. That's what I just explained you. Okay, you need no ROZ. Okay, there should not be any ROZ, there should not be any sign change. So let us start solving the Routh array and then find the range of K for the system to be stable. Find the range of K for the system to be stable. So S power 4, S power 3. S power 4 हो गया 1, 15 and K alternate. 1, 15, K. Next हो गया, okay, 20 and 2. Next is known as the 20 and 2 and 0. The next is S square row. Okay, what is next? It is the S square row. Next is the S square row. अब S square row कैसे form करेंगे? 20 into 15 minus 2. Okay, 300 minus 2, 298 divide by 20. Okay, so 29.8 further divide by 2, 14.9. 14.9. 20 into K divide by 20. तो ये आ गया K. Last element 0. S power 1. Okay, 14.9 into 2, that becomes 29.8. Cross multiply minus 20K divide by 14.9. The column here is on the right 0, so this element will be 0. Last element anyway 0. S की power 0. X into K upon X. K. X into K upon X, that is K. This is 0. This is 0. Okay. Okay. This is K. This is 0. This is 0. That is what it is. Chalo, done. Now, as I told you, I don't want any ROZ, I don't want any sign change. So, देखो, this is going to be plus, this is plus, this is plus. Okay, and by default, guys, K positive only. Okay, by default, K will be positive. That is clear with the option also. Okay, K will be positive. चलो, वो भी मैं specify कर देता हूँ आपके लिए. Okay, so this is plus, this is plus, this is plus. Okay, so this has to be what? And this also has to be plus. So K should be greater than 0. You want no sign change, na? So because I'm starting with plus, all should be plus, and इसको 0 भी नहीं होना है. अगर ये 0 हो गया, तो then you get ROZ. Then you get ROZ. ठीक है? So this also has to be plus. 29.8 minus 20K should be positive. Denominator तो anyway is positive. So this means K is going to be less than. This means K is going to be less than 1.49. K is going to be less than 1.49. 1.49. Okay. K should be positive and K should be less than 1.49. Answer is 0, less than K, less than 1.49. Greater than 0 but less than 1.49. Option number B. Simple question but important. ये important case है. K is between 0 से 1.49. K is between the 0 to 1.49. ठीक है? अच्छा, now related to it, next question. Find a value of K. Same question है ना? Previous question पे ही है ये. Okay. Find the value of K for the system to be marginally stable. Okay. Now marginally stable कब होता है? So for the system to be marginally stable, okay, you have to have ROZ. Otherwise marginally stable possibility नहीं आएगा. And then determine the frequency of oscillation also. वो भी बताता हूँ. Determine the frequency of sustained oscillation. Okay. ROZ always occurs in the odd power. ROZ always occurs in the odd power. So look into the Routh array and decide which row can be row of 0. only odd power. तो s power 3 तो fixed है, you cannot change it, it is a fixed element, but you can play here. You can play here. These two are anyway 0. If you make this also 0, you get your answer. You get your answer. That means 29.8 minus 20k 0. I am playing with the s power 1 row. ठीक है? So, what is the value of k? 1.49. What is the value of k? 1.49. Now, what is the frequency of oscillation? For that, okay, now you have got ROZ, na? So, with every ROZ, there will be auxiliary equation also. There will be auxiliary equation also. With every ROZ, there will be auxiliary equation also. Now, what is that auxiliary equation? Auxiliary equation, above row of 0, na? Chalo, aate hain. Above row of 0. So, it will start with the S square row. 14.9 S square plus K. 14.9 S square plus K equal to 0. Okay, K का value रख देंगे. So, basically, 14.9 S square plus K. Okay, plus K. K is 1.49. Okay, equal to 0. So, what is S square? Minus of 1 by 10 आ जाएगा basically, and S is plus minus J by root 10 or plus minus J 0.316 root 10 by 10 0.316, and S corresponds to plus minus J omega n. This S is plus minus J omega n. So what is the frequency of oscillation? Because when the system is oscillatory, the roots were given by plus minus J omega n. Na? So first I told you, system is marginally stable means oscillatory. Marginally stable means oscillatory. And because it is oscillatory, I am trying to find the frequency of oscillation. So things ko connect karna hai. When the system is marginally stable, okay, the roots are pure imaginary. Plus minus J omega n, and that omega n is the frequency. How do you calculate the roots? By the auxiliary equation. By the auxiliary equation, plus minus J omega n. So I now compare. I get the frequency of oscillation as 0.316 radian per second. I get it as 0.316 radian per second. 0.316 radian per second. हो गया ये वाला. 0.316 radian per second. That is the frequency of oscillation. ठीक है. So that is why, see, if you do the analysis here, na? If you do the analysis here, what you got that? When K, first question we solved, we got K less than 0.49, system was stable. ये पूरा link है. Okay. Then next question we took K equal to 1.49, the system was marginally stable. Okay. And then when you take K greater than 1.49, of course, system will become unstable because there will be sign changes. If you take K greater than 1.49, the system will go to unstable zone. Sign change will occur. यहाँ पे साइन चेंज आ जाएगा if k is greater than 1.49. ठीक है. अच्छा, now one more important thing. RH से actually है, there are multiple things. Okay. Now if there is a cubic equation, very commonly you get questions on cubic equation also. Okay, so suppose you have a cubic equation ASQ plus BS square plus CS plus D equal to 0. देखो, एकदम quickly बता देता हूं मैं. Okay, what is the RH? Okay, this is AC and this is BD. Alternate terms arranged. Okay, alternate terms arranged. So S power 1 कितना होगा? That is clearly BC minus AD by B. Last element 0. S power 0 will be D and 0. Okay, so now for stability. नहीं, gain margin. Wait, Vikram, we'll come to gain margin. Okay. Now, what is BC minus AD then? Okay, what is the BC minus AD? For stability, देखो, अब हमें चाहिए stability. For stability condition is BC minus AD. That should be strictly positive. Plus, this has to be plus and plus. BC minus AD positive. Now, what is BC? It is the product of inner terms and AD is the product of outer terms. These are known as inner terms. These are known as outer term. Product of inners should be equal to product, should be minus product of outers, should be positive. या ऐसा बोल सकते हैं BC greater than AD. Product of inner, अंदर वाले terms का product outer से ज्यादा होना चाहिए. Outer से ज्यादा होना चाहिए. ठीक है? ज्यादा होना चाहिए. ठीक है? So what is the condition for marginally stable then? Marginally stable, of course, will mean BC equal to AD. That will create row of 0 again. Okay, BC minus AD equal to 0. So BC equal to AD. Okay. Now, if there is a marginally stable system, okay, there will be a row of 0 also. There will be a row of 0. There will be an auxiliary equation. Right, this creates row of 0. Okay. And there will be auxiliary equation. What is the auxiliary equation? देखो auxiliary equation यहाँ से तो देख ही सकते हो, but I want you not to make the Routh-Hurwitz. That is why I'm giving the shortcut, na? Not to make the Routh-Hurwitz. Auxiliary equation is always in even power, na? Even power, so row of 0 is odd power. Auxiliary equation above means even power. So it becomes BS square plus alternate term D equal to 0. BS square plus D equal to 0. Then you can calculate the root, and that is the frequency of oscillation. Okay, you will get the root S equal to plus minus J under root of, you get D by B, and that is plus minus J omega n. So what is the frequency of oscillation? Root over D by B. No need to mug up that. Bas auxiliary equation nikal lena. Auxiliary equation even power se hoga. Okay, here also if you make, it will be BS square plus D, but I don't want you to make the Routh-Hurwitz for third order. For cubic there is the shortcut. Okay, for cubic there is the shortcut. Okay, inner and outer terms ke beech mein. Okay, product of inner should be greater than the product of outer. Okay, for stability. If they are equal, marginally stable. Of course, if BC less than AD, then unstable. वो तो clear ही हो गया. Then unstable. ठीक है? Yeah, very shortly I'll be announcing the break. Yeah, we'll be entering into root locus also. Yes, root locus पढ़ना है आप सभी को. Tell me. But just one case I will tell you. Okay, just one case I will tell you before I go to the root locus. Okay. 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 Just one more case I will tell you, and then we'll go to the root locus. Shifting the origin. Okay. Till now we are finding the number of roots to the left or right of the imaginary axis. Okay. To the left or right of the imaginary axis. But suppose any other line is given. Okay. Suppose there is a line given sigma equal to -1. Sigma equal to -1. And I want you to tell me how many roots will lie to the left or right of this line. I don't want with respect to imaginary axis. Till now I was telling LHP. LHP matlab left of imaginary axis. RHP means right of imaginary axis. But how many roots lie to the left or right of this line? I'll tell you direct method, no derivation here. Okay. To determine the number of roots, lying to the left or right of the line sigma equal to -a, -1, -2 कुछ भी बोल दे. Okay, lying to the left or right of the line sigma equal to -a, what you have to do, replace S by S minus a and then apply the RH in the same manner. Now, with the RH you can decide now how many left, how many right. Okay, but before applying RH, replace S by S minus a. Okay, replace S by S minus a. IISc Bangalore ने डिजाइन किया था इस क्वेश्चन को. Okay, उससे पहले भी पूछा गया है, but just I am telling you, I will give you as homework. The number of roots, क्वेश्चन में क्या पूछा है? Number of roots of polynomial, there is a polynomial equation given which have real part. What is the real part? Sigma. By real part of S. Roots are S. Real part of S, matlab sigma. Okay, less than -1. Okay, that means I want the values. I want those roots for which sigma less than -1. That means roots lying to the left of sigma equal to -1. Lying to the left of sigma equal to -1. Anything to the left of -1 will have sigma less than -1 ना. So उसके लिए क्या करना है आपको? Just replace S by S minus 1. Okay, sigma equal to -1 to replace S by S minus 1. Okay, and then apply RH. Okay, replace sigma by, so replace S by S minus 1 and then you are going to apply the RH. Then you are going to apply what? Then you are going to apply the RH. Okay, so possibly almost all cases of RH I have covered for you. Okay, almost all cases of RH I have covered to you. Okay, so this is the schedule that you know. Okay, so guys, I've told you, okay, we'll be going for a break, but before that, some important parameters. Daily quiz hoga every day. Okay, now today there will be the daily quiz of control system. How will you attempt the daily quiz? This is the link and this is the QR code. Save it with you right now. Okay, save it with you right now. Okay, save kar lijiye ek baar. Okay, and let me, if you want, let me share you the link also. Yeah, just a moment. I'm sharing it with you. Okay, yeah, this is the link of the quiz. Okay, you can just go to it. I think attempt in the evening, but just go to it, see if it is opening for you. Okay, and maybe if you're not signed in, it will first ask for sign in to do all that formalities. Keep doing it right now. Or if you don't want to open using the link, this is the QR code. Just scan the QR code. डायरेक्टली आप लिंक पे पहुंच जाओगे, डायरेक्टली लिंक पे पहुंच जाओगे. ठीक है. Now, guys, as I already told you, the complete revision marathon, Saturday, Sunday, dedicated to general aptitude to make you target 15 out of 15, exclusively on the BYJU'S exam prep app. Okay, so where you are going to the app, na, same app, you'll find the general aptitude session. Saturday, Sunday, Saturday, Sunday, coming Saturday, Sunday. Okay, ठीक है. Okay. More than one auxiliary equation, same procedure. 2 times you have to make the auxiliary equation. 2 ROC, 2 times ROC. And the system will be unstable. Okay, repeated pair of imaginary roots aata hai. Okay. So guys, 14th of January, okay, starting from 9 a.m. up to 9 p.m., you can appear in the BYJU'S National Scholarship Test, which can make you grab up to 90% scholarship on the GATE preparation programs. And very, very important, if you're looking for the complete guidance with respect to GATE exam. Okay, how to ace GATE 25 in the first attempt. A free live interactive workshop again on the app. Okay, so you can go to the app using the app link, using the quiz link I told you, or you can download directly the app from Google Play Store, or there is a link of the app in the YT description. kahin se bhi aap download kar sakte ho. So 10th Jan, that is today only, Wednesday, at 7:30 p.m. All your favorite Abhinav Negi, Sir, MTech IT Delhi, he's going to join and give you a dhamakedar workshop, okay, on how to ace the GATE exam, GATE 25 in the very first attempt, so that you are very crystal clear about the thoughts if you are preparing for GATE 25. Join on the BYJU'S exam prep app, 7:30 p.m. Okay, then this is the ROC case complete. Okay, I've given you 1 or 2 homeworks. Do take it up serious. They do take that seriously. Shortcut for cubic equation also told. And now time for, okay, break, okay, for approx 20 minutes. Okay, we resume the class at how much? Okay, at 2 hours 20 p.m. Let's resume at 2:20. Okay, I've given 21 minutes. Approximately 2:25 हो जाएगा, आप मान लीजिए. Approximately we'll start at 2:25. ठीक है? चलो, so have whatever break you want to have, because another similar energy packed session starting with root locus. ये भी बता देता हूँ. We are going to resume with the root locus. Okay? We are going to resume with what? With the root locus. But if the energy and the attendance goes down, we plan to stop early. Okay, you might be thinking बाद में देख लेंगे. No, if the attendance is not continuous with me, I may plan to stop also, because it is all for you, all these free efforts, but you have to, show your enthusiasm and your dedication as well. ठीक है, चलो, see you after lunch break. Hello, guys. Yeah, all set to restart again. Let me just know the audio once again. Okay, let me know the audio once again. Chalo, all good, hai na? Chalo. So guys, okay, so let's get moving ahead and let's quickly start with the root locus. Okay, let's quickly start with the root locus now. Okay, root locus, the locus of the roots of characteristic equation. The locus of the roots of the characteristic equation. Okay, when the gain parameter k is varied from 0 to infinity. When the gain parameter k is varied from 0 to infinity. Say for example, in just one of the previous problems, yeah, we were looking into one of the previous Routh-Hurwitz criteria and we noticed that as you swap the values of k, okay, as you change the value of k, so up to the value of 1.49, the system was ensured to be stable. At 1.49, it reaches the boundary that is marginally stable, and for value beyond it, it becomes unstable. Okay, for values beyond it, it will become unstable. Okay. So definitely the roots. Okay, now what stability depends on roots of characteristic equation, and the roots of characteristic equation may be in the R, maybe in the L side, maybe in the RHP, LHP based on the value of K. So what we are going to now do is the next method that is going to come in front of you is a graphical method rather than this calculative method. Okay, it's going to be graphical in nature and we are going to plot these roots. Okay, we'll plot the locus of the roots of characteristic equation. When the gain parameter is varied from 0 to infinity, we will have a complete swap of the values of k. Okay, varying it from 0 to infinity. We will have a complete swap of the values of k, where the k varied entirely from 0 to the infinity. Okay, where k varied entirely from 0 to the infinity. Okay, now normally when gain is varied from 0 to infinity, we call it as the root locus. Okay, and then gain k, if by chance if you take the value of k to be negative, swap it from minus infinity to 0. Okay, such a root locus plot will be known as complementary root locus plot. When you combine both of them, that means when you take the entire range of k minus infinity to infinity, then the plot will be mentioned as the root loci. The plot will be mentioned as the root loci. Okay, and then there will be special cases when we are not varying the gain parameter k, we vary some other parameter. Okay, and in that particular case, we talk about the root contour. Okay, root contour referred to also as the multiple parameter variation. But सबसे पहले इसको समझ लेंगे. Once this is understood, everything else will be clear. Okay, once this is understood, everything else will be clear. Okay. Now, what is the root locus? As I told you, it is the locus of the roots of characteristic equation. What characteristic equation? 1 plus GSHS. So in a way, I am plotting the roots of characteristic equation. Okay, what is this? Okay, this is in short, plot of the roots of this characteristic equation with respect to k for different values of k, means as a function of k. Okay, so because it is the plot of the root of characteristic equation, it is the plot of this function. Okay, and every point lying on the plot will satisfy the function. Na? Every point lying on the root locus, must satisfy the characteristic equation. Very important point. Every point lying on the root locus will satisfy the characteristic equation. That means it should satisfy 1 plus GSHS equal to 0. Okay, if 1 plus GSHS equal to 0, okay, it indeed means that GSHS equal to minus 1. Okay, GSHS equal to minus 1, and in that case, okay, what is the magnitude of GSHS? Mod GSHS is 1, and what is the face of GSHS? Angle? Wait, where is minus 1? Minus 1 comes on the negative real axis. Okay, so what is the argument? What is the angle at the negative real axis? Okay, because by the way, we always start the angle measuring with positive x-axis. The angle will be how much? It will be 180 degree. Or if you go clockwise angles are negative. You can also call it as minus 180 degree. Anti-clockwise angles are positive. Clockwise angles are taken as negative. So it may be plus 180 or minus 180. The angle GSHS will be plus minus 180 or any odd multiple of 180 because after every 360, okay, the repetition occurs. But simply plus minus 180 is sufficient. Okay. So any point lying on the root locus will satisfy two criteria: magnitude criteria, angle criteria. Magnitude criteria says mod GSHS equal to 1. Angle criteria says the angle should be plus minus 180 degree, any odd multiple of 180 degree. Okay, now what is the procedure to start drawing the root locus? Okay, I'll tell you the systematic procedure. Let's apply to the problem and how to quickly solve the problems. Uspe bhi aayenge. Okay, number one, talk about the number of branches. Okay, how many branches will the root locus have? Okay, how many branches will the root locus have? The number of branches, not deriving anything, just quick review and then some problems. The number of branches of root locus, okay, is always equal to the order of the characteristic equation, and finally it is given by max of p comma z. Now what is p and z here? Okay, what is p and z here? Let me define these parameters. Okay, what is p and z here? So let me define OLP as a term which will be known as open loop poles. I think this word we used earlier also. OLP will be known as open loop poles. Okay, GSHS is known as the open loop transfer function. Okay, the poles of GSHS, they are the open loop poles. Okay, when I say open loop poles means poles of GSHS. Okay, and let P equal to the number of open loop poles. Okay, then similarly we define the term here OLZ, and that will be known as open loop zeros of GSHS, and Z will be equal to number of open loop zeros. Z will be then equal to number of open loop zeros. Okay, number of open loop zeros. So that is what P and Z, and N will be given by the formula max of P comma Z. N will be given by the formula max of P comma Z. Okay, the starting point, root locus will start from the open loop pole. Okay, starting point means k equal to 0. We are first talking about root locus, k 0 to infinity. The starting means 0 going up to infinity, and when k tends to infinity, the root locus will end, okay, will end either at the open loop zeros or at infinity. Okay, if there are less number of open loop zeros, then some of the branches will go to infinity. How many branches go to the infinity? For the branches going towards infinity, we approximate the root locus by asymptotic line. For the branches which are going to go towards infinity, okay, we approximate the root locus by asymptotic line. So how many asymptotes are needed? Okay, that is the difference between open loop poles and open loop zeros. The difference between open loop poles and the open loop zeros. The number of asymptotes. Okay, the number of asymptotes, N, which is given by the difference between the number of open loop poles and open loop zeros. Okay, that is P minus Z. Okay, where P and Z already I defined for you. Okay, and then all these asymptotes will make an angle with the real axis, and the angle of asymptotes will be given by, okay, angle of asymptotes will be given by 2k plus 1 by n into 180 degree. Yeah, simply remember it like this. Odd multiple of 180 degree by n. Odd multiple of 180 degree by n. Okay, how many angles? For every asymptote you need one angle. Okay, so jitne bhi asymptotes hai, calculate that many angles. First odd number 1, then third, 3 and 5. Put down all the odd multiples. Okay. Okay. Now, all these asymptotes will intersect at a point on the real axis which is defined as centroid. Okay, intersection of asymptotes. The point is defined as centroid, and that is given by the formula summation of open loop poles minus summation of open loop zeros divided by P minus Z. Okay, summation of the location of poles minus summation zeros upon P minus Z. That is what it will be known as. Clear? That is what it is known as. Okay, now it will end at open loop 0 only in that case, Bhanu, but some of the branches will start from infinity. That's the difference. Okay. So that's a rare case, but that is what it will actually go like. Now, before, talking about just the procedure, okay, let me also apply it parallelly to a problem. Hai na? Let me also apply it parallelly to a problem. Okay, we'll mix the step then. Okay. Where plus or minus, Rajesh, please specify. Okay, so sketch the root locus of the system having the open loop transfer function k upon s, s plus 1, s plus 3. K upon s, s plus 1, s plus 3. Okay, so first of all, I'll write down all the open loop poles. Dear, what are the open loop poles here? Okay, 0, minus 1, minus 3. These are the open loop poles. 0, minus 1, minus 3. So how many open loop poles? It is actually 3. Agar count ki baat kare, to these are 3 open loop poles. Okay. Then open loop zeros. Zeros of open loop transfer function. How many? How many? Nil. There are no zeros. The numerator is just a constant factor. Okay, so how many open loop zeros? Z का value रखेंगे 0. Okay, so P is equal to the 3, Z is equal to the 0. P is equal to the 3, Z is equal to the 0. Okay, that is the number of open loop poles and the open loop zeros. Clear? Now, let us start. The root locus branches will start from where? And how many branches will be there? The number of branches, dear, is given by the formula max of P comma Z. So, there will be 3 branches. Okay. Okay. All the 3 branches starts from where? Okay. The branches starts from open loop poles. Open loop poles. That is 0, -1 and -3. The branches will start from 0, -1 and -3. The branches will end where? All the branches terminates or ends either at open loop zeros or at infinity. Do you have any open loop zeros here? Nahi. So all the 3 branches which start from these 3 open loop poles, okay, will be terminating at infinity. Ends at infinity, infinity, infinity. 3 branches and all of them going towards infinity. For the branches going towards infinity, we approximate the root locus by asymptotic lines. So how many branches are going towards infinity? 3 branches are going to the infinity. So how many asymptotes we need? Okay, how many asymptotes we need? That is directly seen from here only. How many asymptotes we need? Okay, we need 3 asymptotes. For every infinity branch, we need an asymptote. Okay, so that is why we had the step number 4. Okay, it is given by P minus Z. The number of asymptotes is given by P minus Z, and that is 3 minus 0. That is 3 already written there. Okay, now these asymptotes, okay, will subtend an angle with the real axis. What is that angle? I told you the formula for angle theta is given by odd multiple of 180 degree divided by n. Odd multiple of 180 degree divided by n. Okay. That will be respectively how much? That will be respectively how much? So it will be equal to odd multiple of 180 degree by n. N ka value 3 hai, so 180 by 3, 60. Now what are the odd multiples of 60? Start with first odd multiple, so 1 into 60. Next, what is the next odd number? 3. 3 into 60. 5 into 60. Okay, 60, 180, 300. That is known as 60 or 180 or 300. 60 or 180 or 300. That is the theta. That is the theta. 60, 180, 300. Okay. Acha, guys, this is also equivalent to basically 60, 180. If you want to write down the principal angle, it is minus 60. Dear, if I say an angle is 300 plus 300, तो plus 300 का मतलब क्या हुआ? Plus means anti-clockwise. Okay, so this is known as 300. Okay, but what is a smaller angle? The argument, the principal argument is always between minus 180 to 180. Okay, the angle magnitude up to 180, that is known as the principal angle, principal argument. So if you see from the other side, other side se first of all you're going clockwise, but how much is left? 60 is left, na? But it is clockwise 60, the minus 60. So this can also be written as minus 60. ठीक है जी? One and the same thing. Okay, 60, 180, 300 या 60, 180, minus 60, जो भी बोल दीजिए आप इसको. Okay. So this is the angle of asymptotes with the real axis. Okay, now what is the centroid? Okay, now what is the centroid? Okay, next step is the centroid. The intersection of the asymptotes on the real axis given by the formula summation of poles minus summation of zeros divided by P minus Z. So what is the summation of poles? It is 0, minus 1, minus 3 minus the summation of zeros. 0 is hai nahi. Okay, divided by P minus Z. So it is turning out to be minus 4 by 3. Minus 4 by 3, or basically the centroid is minus 1.33. The centroid is basically minus 1.33. Okay? Now, up to this, okay, up to this, let me first draw the plot. Up to this point at least. Okay, up to this point. Okay. So at least let me start placing the asymptotes and all. First of all, देखो, when you need to draw this root locus, na dear, first locate the pole zeros, next locate the asymptotes, then start drawing the branches. Okay, branches बाद में बनाएंगे, but first let us talk about the poles. Okay, poles and zeros. Let me put the poles and zeros here. ठीक है जी? Poles and zeros को यहाँ पे मैं place कर देता हूँ. Okay, so my poles. Okay, 0, then -1. Okay, this is -2, -3. These are the poles. After the poles, I'm telling you what, place the asymptotes. After the poles, place the asymptotes. Okay, now asymptotes intersect where? I have the calculation. Okay, -1.33, and they start at the angle 60, 180, minus 60 degree, and there are total 3 asymptotes. Okay, the asymptotes place karte hain. Okay, so asymptote -1.33, that is the centroid approximately. Okay, so with this centroid, okay, I will start the first asymptote. All the asymptotes will be starting at this point. The first one is having the angle that is known as 60 degree, roughly, freehand. Okay, measure nahi karna exactly, but this is 60 degree. Okay, this angle, okay, should correspond to 60 degree. Okay, an approximate 60 degree line has been taken. Next will be at 180 degree. Next will be at 180 degree. So 180 degree we know negative x axis की तरफ चला जाएगा. This will be the next one. ठीक है, 180 degree. Third one, -60 degree. -60 means clockwise 60. Okay, so next you have to take the line at -60 degree. Let's say this is the one approximately. Okay, so these are the centroids. Okay, these are the asymptotes basically. Okay, this particular line, okay, this green dotted line is your asymptotes. That is not the root locus plot. This one is your asymptotes. Okay, this one is known as your asymptotes. Now let me start the branches of the asymptote. Where do the branches start from? The branches start from open loop poles. The branches start from open loop poles. Okay, so one of the branch will start from here, but where does it start? One of the branch will start from here, okay, from the open loop pole, but where does it start? Will it start left? Will it start right? Okay, so now we have the next step that is known as odd number criteria. Where will the branch go on the real axis? Okay, whether this side or this side. Okay, odd number criteria. Now what is odd number criteria? What is odd number criteria? Okay, so let me go one by one. Let us start with this particular pole. Okay, let us start with this pole. Okay, yeah, forget the pole. Let me take the section of the real axis. Okay, I have this part of the real axis. Then I have the part of real axis from -3 to -1. Then I have the part of real axis from -1 to 0. And then I have the part of real axis from 0 to infinity. Okay, different parts. The poles or zeros will be dividing the real axis into different parts. Where will the root locus exist on the real axis? Whether it is here or here or here or here, or whether it is everywhere. Okay, there is the odd number criteria. What you have to do is calculate forward poles and zeros. I will tell you a term, FPZ, forward poles and zeros. Okay, suppose the root locus exists here. I don't know, but suppose the root locus exists here. Okay, so from this part of the real axis, you should count forward poles and zeros. You should count forward poles and zeros, and it must be odd number. Okay, the forward poles and zeros must be an odd number. Okay, so from here, when you count the forward poles and zeros, so how many forward poles and zeros? Okay, how many forward poles and zeros? How many forward poles and zeros? So look into it. 1, 2, 3. Zeros to hai nahi. 1, 2, 3. 1, 2, 3. Okay, this is 1, 2, 3. Okay, so this is an odd number. Yes. So root locus should exist on this section. Clear? Acha. From this part of the real axis, calculate the forward poles and zeros. Now aage aate. From this part of the real axis, calculate the forward poles and zeros. How many it is? 1 and 1, 2. Okay, 2 is an even number. So root locus will not exist here. Root locus will not exist here. Okay, next, come to this part of the real axis. Count the forward poles and zeros. 1. Forward poles and zeros here is 1. 1 is an odd number. Root locus will exist here. Okay. Now come to this part of the real axis. See the forward poles and zeros. Come to this part of the real axis. Connect forward poles and zeros. How many? Nil. Nil. Ye to hai 0. There is no forward pole or 0, and 0 will be counted in even. Odd means only 135 I need. So will the root locus exist here? No. It's not an odd number. The root locus will not exist here. So on the real axis, where is the root locus? Dear, on the real axis, where is the root locus? यहाँ पे. Between -3 से -infinity. Okay. Not here. Between -1 to 0, yes. After 0, no. Okay. So, if I remove this now and highlight only the areas where the root locus is actually existing. Highlight only the area where the root locus is actually existing. Okay. It is between -1 to 0. That was the first, that was one of them. And one of them was -3 to -infinity. Left side pe entire. -3 to -infinity. Clear, everybody? These are the two sections on the real axis where root locus will exist. Where root locus will exist. Where the root locus will exist. Okay? Oh. It is running so fast. Chalo, forget. I'll continue like this only. Okay? So these are the two parts between the real axis. Okay. Just now I explained why can't between -3 and -1 be, because from there forward poles and zeros are equal to 2. Okay, forward poles are equal to 2. Jashwant, why odd number criteria? Because of the angle criteria. Every part of root locus will satisfy the angle criteria, angle at ±180 degree. From there it comes up. Detailed derivation we are not doing. Okay, we don't have that much time, but that is how it comes up. Hint मैंने आपको दे दिया है. चलो. So now I was asking you a question. There are 3 root locus branches, na? Okay, from where the branches will start? The branches will start from open loop poles. 3 branches will start from these 3 open loop poles. So now, dear, the branch which is starting from -3, where it is going? The branch which is starting from -3, will it go left or right? Now you have the clear idea, na? Will it go to left or right? Right mate is not allowed. Only left because of the odd number criteria. Only left because of the odd number criteria. So it will go, the branch that is starting from here will go to the left. Okay, and it will continue till infinity. Okay, now whenever the root locus branch starts, that is k equal to 0, and it goes, okay, till k tending to infinity. See, finally for k tending to infinity, it is also going in the asymptote direction. Eventually it is going in the asymptote direction. 180 degree asymptote, ये जो second asymptote था. ठीक है? Next point. Now, there are 2 more branches starting from 2 other poles. Okay, the branch that is starting from -1, ये कहाँ जाएगा? The branch that is starting from -1, ये कहाँ जाएगा? The branch that is starting from -1 will go to the right. Because of the odd number, no? It cannot come here. It cannot come here. The branch that is starting from 0, it will go left. यहाँ पे allowed नहीं है. यहाँ पे allowed नहीं है. Okay, so one of the branch, now have a look into it. One of the branch going right, another branch going left. What is going to happen? There are 2 branches now traveling in the opposite direction. So what do you expect, Baba? क्या होने वाला है? Okay, so because there are 2 branches, opposite direction means traveling towards each other. Tick, 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 they are going to come and collide. They are going to be a collision between them. They are going to intersect. They are going to intersect. Okay, and the intersect, that intersection point will be known as a breakaway point. That intersection point will be known as a breakaway point. Okay, the branches come closer and at a point they intersect, they collide, boom, boom, bash. Okay, that is the intersection of the branches, and that point where the root locus is traveling on the real axis and intersect. After intersection, it will go to the complex plane. Okay, that intersection point will be known as a breakaway point. That intersection point will be known as breakaway point. I will stop here. What is that breakaway point? Okay, what is that breakaway point? ये देखिए. Okay, so we were into the procedure. Let's come back to the procedure. Okay, let's come back to the procedure. Number of branches, starting point, ending point. Then we had 3 steps for asymptote. Okay, then we have look into the step number 8 first. मैंने पहले ये apply किया. Okay, existence of root locus on the real axis. Okay, and the procedure applied here is known as odd number criteria. And what is the odd number criteria? Okay, total forward poles and zeros must be odd in value. The root locus will exist on the section of real axis. The root locus will exist on section of real axis if the total number of poles and zeros towards the right, right मतलब मैंने forward बोल दिया था. If the total number of poles and zeros towards the right is an odd number. Total number of poles and zeros towards the right is an odd number. Okay, let me complete one root locus problem, and guys, let's take the doubt. Otherwise, my flow will be interrupted. Okay, let me complete one root locus problem. Okay, if the total number of poles and zeros towards the right is an odd number. Okay, total number of poles and zeros towards the right is an odd number. ठीक है, तो चलो, this must be an odd number. That is what odd number criteria. Now, what we just now saw is that there are two branches traveling in the opposite direction. At some point between two open loop poles, ये picture था ना मेरा, open loop pole at origin, open loop pole at -1. Okay, one starting right, one starting left. So there will be some point between these two poles where the root locus breaks away. Okay, where the root locus breaks away. Okay, and to obtain the breakaway point, again I am not telling you the derivation, but yeah, to obtain the breakaway point, you are going to solve dk by ds equal to 0. To obtain the breakaway point, you will solve the equation that is known as dk by ds equal to 0. Okay, you solve the equation dk by ds equal to 0. Okay, dk by ds equal to 0. Okay, then the solution of dk by ds equal to 0, not every solution will be a breakaway point. For it to be a breakaway point, it must lie on the root locus. So let us understand this. Okay, first thing is dk by ds equal to 0. Chalo, how to apply this? So let's go to the problem. Let's come back to the same problem. Let us come back to the same problem. Okay. Yeah. We are trying to figure out this problem. We have the basic steps done. Asymptote, starting point, ending point, centroid. Okay. Now, breakaway points. Step number 7, breakaway points. Okay. अब उसके लिए dk by ds. But what is k? First, I need to get the value of k as a function of s from the characteristic equation. What is the characteristic equation? 1 plus GSHS equal to 0. 1 plus k upon s, s plus 1, s plus 3 equal to 0. That is the GSHS given to you. So when I simplify it, I get s cube, 1 plus 3, 4, s square. Okay, then plus 3s plus k equal to 0. Okay, equal to 0. Okay, so what is k from here? K is minus of s cube plus 4s square plus 3s, minus of s cube plus 4s square plus 3s. Okay, so what is dk by ds? What is dk by ds? Okay, that is given by minus of 3s square plus 4 to the 8s plus 3, and then you need to solve dk by ds equal to 0. आपको क्या करना है? Now you need to solve the dk by ds equal to the 0. dk by ds equal to the 0. Okay, we'll start solving dk by ds equal to the 0. The dk by ds equal to the 0. Okay, so chalo, let's take the dk by ds equal to 0. Okay, so quadratic equation, solving it, you will be getting the value of s. What is the value of s you will be getting? Let me quickly calculate and tell you the answer. Okay, so what is that roughly I am getting is minus 0.45 minus 2.2, approximately लिख लिया, minus 0.45 minus 2.2. Okay, so I've got two candidates by dk by ds equal to 0, but one line I told you, every solution of dk by ds equal to 0 may not be a breakaway point. Every solution of dk by ds equal to 0 may not be a breakaway point. Okay, for it to be a breakaway point, it must lie on the root locus. So I will write down here s equal to minus 0.45, s equal to minus 2.2. देखना यहाँ पे, for it to be a breakaway point, it must lie on the root locus. दोनों real है, both are real. We have already basic idea about the real axis now. Root locus is between -1 to 0, odd number criteria, and between -infinity to -3. Okay, you have minus 0.21, minus 0.45, वो यहाँ कहीं आएगा, minus 0.45, so that is on the root locus. Then you have minus 2.2, say somewhere here, you have minus 2.2. Is this on the root locus? देख लीजिए यहाँ पे. Root locus branch means that orange section. Is the root locus here? No, na? Odd number criteria already applied. So this is not the breakaway point. This is not on the breakaway point. Okay? So that is what I mean. The root locus should be on the breakaway point should lie on the real axis. Okay. So this one is the breakaway point. This one is not the breakaway point because this is not on the, this does not lie on the root locus as per the odd number criteria. Okay, so we have one breakaway point and very logical. What is the breakaway point? We wanted between 0 and -1. By picture se samajh mein aa gaya tha that the breakaway point, collision is going to happen between -1 and 0. So it is automatically -0.45. Okay, it is automatically -0.45. Here it is. Say roughly, this is -0.45. Now at this point, the root locus branches come and travel up to this point. Then they break away. This is the breakaway point. Okay, they come and intersect here and they break away. Okay, they break away. So this is known as the intersection point. Okay, now they break and go to the complex plane. Okay, what happens? They break and they go to the complex plane. Where? Sab kuch ho gaya. They start, they intersect and they terminate. Remember 3 lines. Start, intersect, terminate. So now you have to take them towards termination. Termination is towards infinity. For infinity, I have already drawn the asymptotes for you. I have already drawn the asymptotes for you. So you have to make it go somewhere. Yeah. Let's say this is the breakaway point. You have to make them go such that approximately freehand sketching. Okay. So that one of them goes towards the above asymptote. One of them goes towards the below asymptote. Okay. One of them goes towards the above asymptote. One of them goes towards the below asymptote. Okay. Flow the arrows. Okay. Just follow these arrows. Okay. The root locus branches started for k equal to 0. And they go towards k tending to infinity. They go towards the k tending to the infinity. They go towards the k tending to infinity. Clear, everybody? Okay, ji, done hai, cool hai. Okay, k tending to infinity, k tending to infinity. This is the root locus complete. This is the root locus complete. Now we are able to see that when the root locus branches are approaching infinity, they are approaching infinity, approaching asymptote. Okay, approaching asymptote. In between, they cut the imaginary axis. In between, they cut the imaginary axis. Okay. In between, they cut the imaginary axis. Okay, where do they cut the imaginary axis? Where do they cut the imaginary axis? So that is the next calculation. Although plot is complete, okay, in the options you will have a rough plot and you can match the option, but okay, let me complete the entire procedure. Okay, let me complete the entire procedure. Okay, so we have seen in the procedure, we have seen the breakaway point. In the procedure, we have seen the root locus on the real axis. Okay, now intersection of the root locus with imaginary axis. Okay. Where does the root locus intersects on the imaginary axis? And if you want to intersection with the imaginary axis, nothing, you have to go for the RH criteria. You know how to apply the RH criteria? Okay. The same can be solved by the RH criteria. The same can be solved by the RH criteria. Okay. So that is the step number 9. Okay. That is the step number 9. So yeah. Let's come and now complete the RH criteria also. Okay. So step number 8 is odd number criteria. मैं पूरा लिख देता हूँ एक-एक करके. Step number 8 was odd number criteria. That is already applied. That we need to apply. That we don't need to write. That we need to apply. And step number 9, as I'm telling, is known as the intersection of the root locus with imaginary axis. Okay, RH criteria apply करेंगे इसके लिए. And RH के लिए what we need is the characteristic equation. And the characteristic equation is given by S cube. Already we have calculated na. S cube plus 4S square plus 3S plus K. Dear, RH भी apply करना है क्या? Cubic shortcut. Cubic shortcut. No RH also. Cubic shortcut. Cubic shortcut. Okay. Product of inner equal to product of outer for the system to be marginally stable. By imaginary axis कब आएगा? When the system is marginally stable. Imaginary roots means marginally stable. The product of inner is equal to product of outer. Okay, so यहाँ से you get the value of k. Okay, so root locus intersects on imaginary axis with k equal to 12. K equal to 12. At what values? How do you calculate the value of roots? Auxiliary equation. Auxiliary equation even power. Just before the lunch I explained you the shortcut. Na? Even power 4s square plus k equal to 0. K का value रख देंगे तो 4s square plus 12 equal to 0 and s square is known as the minus 3. S square is known as the minus 3. So what is the value of S? Plus minus j root 3. So where do the root locus intersects on the imaginary axis? Okay. Okay. Plus minus j root 3. Plus minus j root 3. So these points, let me write here. This point, what is this? This is S equal to plus j root 3. Okay, and this has been obtained for k equal to 12. And this is known as what? This is known as S equal to minus j root 3. S equal to plus minus j root 3. S equal to plus minus j root 3. ठीक है? Yes, ठीक है? This is the complete part done. And now, some more parameters we can extract from here, but let me know if you have any confusions now. Okay, quickly let me know if you have any confusions now. That design of curve, Janendra, is just approximate. We have to have the quick sketches, okay? So after the breakaway point towards the asymptote, okay, that is just approximate. Approximate means you cannot, you should not draw something like this. You can never cut an asymptote in between. Na? Asymptote is those lines. What is mathematically asymptote? They are those lines which will intersect. Okay, they are those lines which will intersect the curve near infinity, which will be tangential to the curve near infinity. So isko intersect nahi karna, rest anything else. Yes, it's going to be smooth. Look into it, the function. We are plotting characteristic equation which was polynomial, though it has to be smooth. It has to be smooth. Because the polynomial nature was there. ठीक है? Done hai ji? ये हो गया. Breakaway direction means what, Gautam? Can you elaborate? Are you talking about breakaway direction or branch direction? Please elaborate quickly and let me know. ठीक है? Quickly and let me know. Now, by the time, one more possibility of question from here. Okay, one more possibility in between. Okay. Okay. Branch direction. Dekho, one more question I can ask you here is, dear, look into this point. This is known as breakaway point, correct? What was the value of breakaway point? Minus 0.45. Okay. What is the value of k here? Okay, one more question. One more question. Find the value of k at the breakaway point. And I'll tell you the technique. Okay, I'll tell you the technique. Okay. Angle of departure will be coming up. Branch, dekho, Gautam, branch direction. Are you clear about odd number criteria? What I first explained is odd number criteria, and by odd number criteria, root locus cannot be here, it can only be here. Okay, so if you are clear about odd number criteria, ab dekhiye, this is a pole. Okay, from the pole a branch will start. From the pole a branch will start. Okay, branch kahan start hoga? Left or right? For that is why I first calculated odd number criteria. So odd number criteria says that this is valid root locus, this cannot be the root locus. Okay, so that is why when I am starting the branch from -1, it has to go towards right. It cannot come left because of odd number criteria. Okay, so that is how we decide where the branch will start from a particular pole. Before that, you first rectify where is odd number criteria satisfied. Okay, chalo, done hai ji. Okay, this is done. Okay, now what is the value of k at the breakaway point? What is the value of k at breakaway point? Okay, not only at breakaway point, now remember. Okay, now remember. Breakaway point eventually lies on root locus only, na? It lies on root locus only. Okay, at any point on root locus, okay, find k. Remember, at any point on root locus, how to find k? There are two methods. Method number one, magnitude criteria. Any point lying on the root locus will satisfy the characteristic equation. Because it is a point on root locus, it will satisfy the characteristic equation. Okay. So at that point, you can take mod GSHS equal to 1. At that point, you can take mod GSHS equal to 1. Clear? ठीक है, बताता हूँ, break in point भी बोलता हूँ अभी. ठीक है. Method number two. Okay, at any point mod GSHS equal to 1. Okay, that is when. And next point is to find the value of k at any point. From magnitude criteria only, we have derived a small shortcut, small technique. The k at any point is given by product of distances of all the poles from that point divided by product of distances of all the zeros from that point. ये हो गया. Pi here, pi means product symbol. Okay. Product of poles from that point divided by product of zeros from that point. ठीक है, ये इसी से आया है magnitude criteria से. Okay, so what is the picture actually we had? अगर आप देखोगे, इसको छोड़ते हैं. What is the picture we actually had? Okay, we have the pole at 0, we have the pole at -1, we have another pole at -3, and this is my point of concern, breakaway point, -0.45. -0.45. Okay, now what is the value of k at this point? Okay, what is the value of k at this point? It is the product of distance of this point from all poles. Okay, so let us say this is the distance p1, let us say this is the distance p2, and let us say this much is the distance यहाँ से यहाँ तक का, that is p3. Okay, so it is numerator p1, p2, p3 divided by distances with respect to 0. Okay, do you have any 0 here? There is no 0 here, so denominator you will write it as 1 if there is no 0. Now what is P1, P2, P3? By 0.45 or 0, absolute distance, don't take the minus, I am talking distance, not the displacement. So 0.5 and 0, distance is 0.5. 0.5 and 1, 0.55. 0.45 and 3, so 2.55. That's your answer. Okay, that's your answer. So how much is k equal to here? .63 approximately. Okay, 0.63 approximately. Okay, so at the breakaway point, okay, we have k that is 0.63. Okay, so it's like root locus starts from k equal to 0. At 0.63 the root locus breaks away. At k equal to 12 it intersects the imaginary axis. For k greater than 12 it goes to the right half plane. Okay, that is the answer, 0.63. Okay, and not only see, now I'll tell you, there are direct questions like this. Find the value of k at any point. Yeah, find the value of k at breakaway point. Okay, let me add on one more thing here. Okay, now there may be the story. A quick sketch बनाता हूँ मैं आपके सामने. Let me give you a quick sketch here. Okay, suppose there is a question of the kind. GSHS equal to k s plus 1 is divided by s plus 3 s plus 5. k s plus 1 upon s plus 3 s plus 5. इसको ध्यान देना एक बार. Okay, and I'll present you a quick sketch of this one. Okay, I'll just be presenting a very quick sketch of this one. देखना. So what are the poles and zeros? Okay, the 0 is at -1. Okay, there are two poles at -3 and -5, and there is a 0 at -1. Now pay attention. Where will the root locus start from? Where will the root locus start from? Okay, root locus will start from poles. Okay, there are two branches. Not writing orally, samajhna. How many branches? Max of p comma z. So there are two poles and there is 1 0. There are two poles and 1 0. So there will be two branches starting from -5 and -3. Okay, one of them will terminate on the 0 because you have a 0, but one of them will go to the infinity. One of them will go to the asymptote. One of them will go to the asymptote. Up, dear, I want you to remember one thing. Okay, I want you to remember one thing. We will come back here. Let me go to the procedures. Let me go to the procedure. I will come back here. Okay? I'll come back here. Okay. So we had the procedure. Okay, number of branches, starting point, ending point, number of asymptote, angle of asymptote, intersection of asymptote. Okay, angle of asymptote ki baat kare na. So you are able to see that angle of asymptote depends only on the value of n. It does not depend where the pole and 0 is, but it only depends on how many asymptotes are there. Okay, so dear, whenever n is equal to 1, okay, only one asymptote, only one angle, that is 180 degree. Okay, it's quick for you to remember. Whenever there are two asymptotes, the angle will be 90 and 270 degree. Okay, 90 and 270, or basically 90 and -90. Okay, whenever there are the three asymptotes, we have solved a question of three asymptote right now. Now, what is the answer we got? 60, 180, 300. We got na 60, 180, 300. That is basically 60, 180 and -60 also. ऐसा भी लिख सकते हैं. For n equal to 4, the theta will be, on solving you get 45, 135, 225, 315. It will be odd multiples of 45 basically, or this is also equivalent to 45, 135, then -135, -45. Okay, now for any other number of asymptotes like n equal to 5, n equal to 6, you can calculate. But these are the 3 or 4 common cases going to come up. So we can directly remember the theta for them. With practice, you can remember, okay? With practice, you can remember. Now, dear, sometimes, you know, I will highlight some steps. Like step number 5. This can be individual one-marker question in GATE or even in ESE also. Many times you don't have the root locus plot complete. You have individual steps as the question. Angle of asymptotes with the real axis. Centroid. कई बार सिर्फ centroid पूछते हैं. Intersection of asymptotes on real axis. What is the centroid of the root locus? Sometimes they will only ask the breakaway point. Very important. Find a breakaway point or find a value of k at breakaway point. वो भी मैंने आपको बता दिया. Find the value of k at breakaway point. This can also be individual question. Okay. Existence of root locus on real axis, then intersection of root locus with imaginary axis. Okay, where does the root locus intersect with the imaginary axis? They put the question like this. They use the word, where does the root locus intersect with the imaginary axis, but ultimately that is to be solved by RH. So there you don't start drawing the root locus. केवल RH बना, केवल RH से solve कर लेना. But this can be individual question. This language can be individual question. Then two more individual question, highly important for you. Step number 10 and 11. These steps did not come in the previous question, because in the previous question all the poles were real. But whenever you have a complex pole, we calculate the angle of departure. I will explain you how to calculate. I will take a separate problem. Okay, but this is a very important separate 2-marker question also. Not only with respect to root locus, this is a separate 2-marker category question. Calculating angle of departure and angle of arrival. So angle of departure is given by the formula 180 degree minus phi p minus phi z. Okay, where phi p is sum of angles subtended by remaining poles. समझाऊंगा मैं. Phi z is sum of angles subtended by zeros. Okay, leave. I will explain you. Okay, similarly there will be the step number 11. Okay, angle of arrival at a complex zero. Okay, important. Okay, 180 degree minus phi z minus phi p. So what is, how to calculate phi z phi p बताता हूँ मैं आपको. ठीक है, ठीक है. Okay. Chalo, so I will explain you this angle of departure or arrival, but before that, यहाँ आते. So I was trying to solve one root locus problem quickly, approximately. हम एक root locus problem को solve करने की कोशिश कर रहे हैं. Okay. Okay. So there are two open loop poles, but there is only one open loop 0. So one of the branch will terminate at open loop 0. Another branch will go towards asymptote. Another branch kahan jayega? Towards asymptote. Where is the asymptote? Another branch will go towards asymptote. Where is the asymptote? Only one asymptote, na? The 180 degree. 180 degree means negative real axis. 180 degree means negative real axis. ठीक है, चलो अब start करते हैं. Odd number criteria. Odd number criteria, guys. Forward poles and zeros here. Forward poles and zeros 3 odd number. The root locus will exist here. Okay. Forward poles and zeros from here 1 and 1 2. Root locus will not exist here because 2 even number hai. Forward poles and zeros here. Okay. Forward poles and zeros here. नहीं यार ये थोड़ा सा ना मैंने गड़बड़ ले लिया है. No. Better let's not take this plot. I'll explain. I'll change the data slightly. I want you to understand something. Better. I'll take it like this. Forget. थोड़ा और इसको better करते हैं. And let's take it of this kind. K s plus 1 s plus 7. Okay. K s plus 1 s plus 7 upon s plus 3 s plus 5. Okay. So now you have one more 0. You have one more 0 and there are no asymptotes now. There are no asymptotes. Okay. There is a 0 at minus 1. Okay. There is a 0 at minus 1. Then there is a pole at minus 3. Okay. Then there is a pole at minus 5. Then there is another 0 at minus 7. Okay. This is the pole 0 configuration. Okay. Two poles, two zeros. There will be two branches starting from these two poles and terminating on the zeros. Okay. Terminating on the zeros. So what will happen? What will happen? नहीं यार ये भी नहीं. हाँ ठीक है. That is also a correct possibility. But what I will rather do is what I want you to rather understand is like this. Okay, let me first draw the pole 0 plot. So out of the multiple possibilities, let us learn about this one. This looks like K s plus 4 s plus 7 divided by s plus 1 s plus 2. अब इसको देखिए dear. Okay, there are two poles and two zeros. What does it mean? Okay, if there are two poles and two zeros, that means no asymptotes. That clearly means this is going to be a problem with no asymptotes. Okay, no asymptotes. Okay, now forward poles and zeros once again dear. Forward poles and zeros once again. Okay, from here, how many forward poles and zeros? 1, 2, 3, 4. 4, not allowed. 4, not allowed. Okay, even number. From here, how many forward poles and zeros? 3, odd number, allowed. The root locus will exist here. यहाँ पे देखेंगे 2. 2 is a even number. Forward is 2. Root locus will not exist here. From here, forward pole is only 1. The root locus will exist here. From here, forward poles, nil. The root locus will not exist here. So where is the root locus existing? This part and this part. Between these two open loop poles, between these two open loop zeros, correct? Between these two open loop zeros, between these two open loop poles. यहाँ पे root locus exist करेगा. Okay. Okay. Now dear, listen to this. Okay, the root locus branches will start from poles. They will start from poles. One of the branch will start from minus 2. Where? One of the branch will start from minus 2. Right. Because of the odd number. Where there is the pink, where there is the orange zone, there only you can travel. Another branch will start from the open loop pole minus 1. Where? To the left. To the left. Again, two branches traveling in the opposite direction. So they will collide. That will be a breakaway point. They will collide. That will be a breakaway point. Okay. So they come and intersect at the breakaway point. Whatever is the breakaway point, abhi calculate nahi karte. They come and intersect at the breakaway point. And where do they travel? Okay, they will travel in the complex plane towards conclusion. Where do they terminate? The root locus branches terminates on the open loop zeros. They will terminate on the open loop zeros. Okay. So one of the branch, can I take it like this? Another branch, can I take it like this? Tell me. One of the branch terminated at open loop 0. Another branch terminated at the next open loop 0. Tell me. Is this the correct root locus plot? Definitely, this is not the correct root locus plot. ये correct root locus plot नहीं है, because the root locus has to be symmetric with the real axis. I told you na. Okay, everything on the top and everything on the bottom is identical. They have to follow the symmetry about the real axis. Okay, they have to follow the symmetry about the real axis. That means the root locus branches breaks from here. Okay, and because of symmetry, they will come and intersect on the real axis at the same point. Because of the symmetry, they will come and intersect back on the real axis at the same point. Symmetry hai na? So at the same point, they will come and intersect here at the same point basically. Because of the symmetry, they will come and intersect at the same point. Okay, so they come and intersect here. Okay, and then they are going to go towards the termination. Termination is open loop 0. So one of the branch dear will go towards this open loop 0. One of the branch will go towards this open loop zeros. In branches का भी arrow बना देते. They are traveling in the complex plane. Okay, now dear listen to me. Now dear listen to me. Okay, this was known as, please listen to me. Okay, this particular point we all know was known as breakaway point. Okay, the two branches traveling on real axis, they intersect and then they travel to the complex plane. यहाँ पे reverse story है. There are two branches traveling on the complex plane. There are two branches that are traveling on the complex plane. They come and intersect on the real axis and then move on the real axis. Opposite picture. This is break in. Coming into the real axis. That is break in. Okay. Achha, whether it is breakaway or break in. Okay. Intersection has to happen here. Okay. This is breakaway. Okay. And this is known as break in point. This is known as break in point. Clear everybody? Okay. So we have the breakaway and the break in point for you. We have the breakaway and the break-in point for you. Clear everybody? Clear everybody? 4 zeros nahi hai Chinmoy. Okay, there are 2 poles and 2 zeros. Okay. So this is what is the break. The break-in point means when the branches travel from complex plane, come and intersect on real axis and then move to the real axis. That is break-in point. Okay. So breakaway is also there, break-in is also there. Ultimately, both of them are intersection points. Acha. Okay. Between the breakaway point and break-in point, between the breakaway point and the break-in point, okay, the root locus is forming a what? It forms a circle. ये proof करने की जरूरत नहीं है. We don't have the time to prove, of course. But between the breakaway and break-in point, this root locus, okay, it will form a circle. It will be perfectly a circular shape. Okay, it will form a circle with. It will form a circle with. It will form a circle with circle has two important points, radius and center. Okay, with the radius given by modulus of S1 minus S2 divided by 2. Okay, let us say the breakaway point is S1. Okay, let us say the break-in point is at S2. You know how to calculate breakaway break-in point? dk by ds equal to 0 se nikal loge, you get some breakaway point S1 and S2. Okay, and center is x comma y, and that is given by S1 plus S2 divided by 2 comma 0. It is on the x-axis. The center will be somewhere on the x-axis. Okay, That is the average of these two. The center will be at a midpoint of breakaway and break-in point, and the radius will be given by that formula. Okay, so where will be the center? It will be exactly at the midpoint of breakaway and break-in. Breakaway and break-in. Okay. So we can have breakaway also, break-in also, sometimes only break-in, sometimes only breakaway, sometimes breakaway, break-in both. Okay, sometimes breakaway and the break-in both. Clear everybody? अच्छा जी, ठीक है. तो ये कुछ और चीजें यहाँ पे learn कर ली with respect to the root locus. Okay. Now, before I take the next problem, na. Okay. Suppose if the question is with respect to complementary root locus. Now question will not specify complementary root locus. Okay. Question will tell you root locus, but where do you apply complementary root locus? Okay. What is the value of k at any point? Vadla, same method. Breakaway or break-in or that same method. Product of wholes upon product of zeros method. Okay. Complementary root locus, as I already told you, complementary root locus is the root locus. Okay. Number one for, I'll tell you, it is the root locus. You have to apply complementary root locus at two different pictures. What is happening? You have to apply complementary root locus for negative feedback systems. Okay, and the k is taken to be negative. That is minus infinity less than k less than equal to 0. Okay, because the root locus was the root locus for positive value of k, this is the root locus for negative value of k, or it is the root locus, okay, for positive feedback systems, oscillators. Okay, the root locus for positive feedback system, but taking k to be positive only. That is the regular value of k. Okay, 0 less than k less than infinity. At these two places you apply complementary root locus. Okay, at these two places you apply complementary root locus. Okay, now again not deriving it up. Okay, not deriving it up. No, root locus is there for the entire system for all values of k. Jashwant, for some values of k system will be marginally stable. Okay, हाँ, for some pure marginally stable system आते हैं उसपे, समझ गया? Got your point, Jashwant. I'll come to that also. Wait. थोड़ा खत्म करने दो यार. Maybe some of the things are automatically coming up. So any point lying on the complementary root locus, okay, will satisfy same. There are two criteria: magnitude criteria and angle criteria. Magnitude criteria remains to be same, mod GSHS equal to 1, but angle criteria will change. Angle criteria will now be odd multiple of 180 degree rather than even. Okay, sorry, now it is even. Earlier we had 180 degree 2k plus 1, odd multiple of 180 degree. Now it will be even multiples of plus minus 180 degree. Now even multiple start with k equal to 0. Okay, so it may be 0 degree also. Next even multiple 180 into 2 360 degree, 180 into 4 720 degree, any of them. The angle GSHS at a point on the complementary root locus, okay, will satisfy 0 plus minus 360 plus minus 720 and etc. Okay, that is what it is. That is what complementary root locus. Okay, so every step in the root locus which is related with angle will change. Okay, will change. So what are the steps that are going to change for you? Okay, angle of asymptotes with the real axis. So 2k plus 1 की जगह यहाँ पे भी 2k आएगा, even multiple of 180 by n. Let us put it like this. 2k into 180 by n. What was the formula for angle of asymptote? 2k plus 1 into 180 by n. Odd multiple of 180 by n. This is going to be even multiple of 180 by n. See, I have directly written 5. So 1, 2, 3, 4. No change. I am only writing the changed steps. Step number 5. No change in step number 6. Okay, directly come to the step number 8. Okay, existence of root locus on the real axis will now satisfy even number criteria. Till now we had odd number criteria, now there will be the even number criteria. Okay, even number criteria means the forward poles and zeros must be even number. The forward poles and zeros must be even number. The forward poles and zeros must be even number. Clear? The forward poles and zeros must be even number. Okay, next. Angle of departure. Okay, I'm going to explain you angle of departure and arrival through a problem. But what was the formula for angle of departure normally? Okay, it was 180 degree. What was the formula for the regular root locus? 180 degree minus 5p minus 5z. Now replace the 180 by 0. 0 or 360, anything. Okay, so I simply replace by 0 and now it becomes, agar 0 hai, so it is only minus 5p minus 5z. It is only minus 5p minus 5z. That is angle of departure. How to calculate 5p 5z? I'm going to explain you shortly. Then angle of arrival. Okay, only change steps have written. That is again 0 minus 5z minus 5p. That is simply minus 5z minus 5p. Okay. Chalo. So you must know ki what steps change in the complementary root locus. Now let me come to a problem. अच्छा, how the question will look like ना एक बार ये भी देख लीजिए. How the question will look like. I will not solve it here, but I'll tell you. Okay. Okay, how the question will look like. A negative feedback system has the open loop transfer function k upon s, s plus 1, s plus 3. Okay, sketch the root locus when k is varied from minus infinity to 0. ध्यान देना, there are two different languages in which a question can come in front of you. Okay, there is a negative feedback system. Okay, with GSHS given to you, and find the root locus for k minus infinity to 0. Negative feedback, regular negative feedback system, but we are taking negative values of k. So this makes the question as complementary root locus. I am again telling you, they will not say in the question whether it is root locus or complementary root locus. You have to identify. Okay, or the question may be drafted in another way. There is a positive feedback system. Okay, which has the open loop transfer function k upon s, s plus 1, s plus 3. Find the root locus when gain is varied from 0 to infinity. So here gain is regular gain, 0 to infinity. But the system is positive feedback. So even for positive feedback, we should be taking complementary root locus. Even for the positive feedback, we should be taking the complementary root locus. Clear everybody? We should be taking the complementary root locus. Okay, these are the two things. These are the two things. Chalo, ठीक है, तो I'll give you this as homework. I'll give you this one as the homework. Chalo, let me take one next example. Sketch the root locus, regular root locus, है ना? Yes, aptitude marathon, Saturday, Sunday, 13-14 January. Okay, complete aptitude revision, but on the BYJU'S app. Free event on the BYJU'S app. It's not paid, it's free, but on the app, not on the YouTube. Okay. Find the root locus for GSHS equal to k by s square. Find the root locus for GSHS equal to k by s square. K by s square. Root locus for GSHS equal to k by s square. Arey Baba Jashwant, that is what we were looking. Negative feedback and 0 to infinity means that is what we started where? Root locus. Root locus, that is the fundamental root locus only, na? Dekho, this is very simple. No need to apply any step here. No need to apply any step here. What is the characteristic equation? 1 plus k by s square equal to 0. S square plus k equal to 0. So s square equal to minus k. So what is the s? Under root of negative number plus minus j. So s is under root, s is plus minus j under root k. This simply means, what is root locus? Locus of roots of characteristic equation. Na? So roots of characteristic equation तो आपके सामने लिख दिए. Roots of characteristic equation plus minus j root k. Everything is written in front of you. The roots of characteristic equation plus minus j root k. And what does it mean? Plus minus j root k. That all the roots are, okay, pure imaginary. All the roots are pure imaginary for any value of k. No need to apply any step here. The roots are pure imaginary for any value of k. The roots are pure imaginary for any value of k. So, if I want to draw the root locus plot, that root locus plot will always be on the imaginary axis. Will always be on what? On the imaginary axis. Okay. If you take k0, s equal to 0, that means, as always, root locus as always, root locus will start from origin. Okay, for k equal to 0, it will be 0 only. Okay, then as k increases, plus j root k, one of the branch will go towards positive y-axis, minus j root k, another one will go towards negative y-axis. Ye ho gaya. This is your root locus complete. Only on the imaginary axis. System is always marginally stable. You can also say that system is always marginally stable. Okay, this is the root locus which started from k equal to 0 and eventually will be going towards k tending to infinity. Okay, here no step required because already characteristic equation itself is so simple. But a very important point I will mention here. Now, a very important root locus category I will mention here. Root locus for the system having root locus for the system having what? Root locus for the system having GSHS equal to k upon s plus 1, sorry. Root locus for the system having the GSHS equal to k upon s plus a raised to the power m. Okay. GSHS equal to k upon s plus a power m. That means there is only one pole minus a and that is repeated m times. Okay, only one pole minus a that is repeated m times. So root locus for this system will, you can note down the conclusion directly, will consist of only m asymptotic lines. There will be m branches and all the branches will be directly asymptotic lines. Okay. Okay, will consist of only m asymptotic lines. Will consist of only m asymptotic lines. Okay. Starting from, all of the branches starts from the open loop poles and the open loop pole is minus a. So all of the branches starting from minus a, right? Okay, at what angles? At asymptotic angles. At asymptotic angles. At what? At asymptotic angles. At asymptotic angles. So chalo, banate hain. Suppose you are given GSHS equal to k by s cube. We took s square na, ab k upon s cube lete. K upon s cube. Do it up, dear. K upon s cube. Okay, so k upon s cube, m equal to 3. There will be only 3 asymptotic lines. Nothing will be there in the root locus, but only asymptotic line. Starting from open loop pole. Where is the open loop pole? Origin. Where is the open loop pole? That is directly origin. Okay, so there will be 3 asymptotes. Starting, what is the angle for 3 asymptotes, dear? What is the angle for 3 asymptotes? If there are 3 asymptotes, angle is 60, 180 and minus 60. That is already calculated. 60, 180 and minus 60. One of the asymptote at 60 degree. One of them at minus 60 degree. And one of them at 180 degree. Okay, this is the root locus complete. The root locus for k upon s cube will only consist of 3 asymptotic straight lines at the angle 60, 180, minus 60. Okay, starting from origin because the poles are at origin. S cube hai. Acha. Next example. K upon s plus 2 power 4. Yes, Janendra, correct. It is unstable for all k, the previous example. K upon s plus 2 ki power 4. All calculations in mind only. Oral. Okay, just focus on the plot. Okay, so there is a pole -2 that is repeated 4 times. K upon S plus A power M form hai. There will be 4 straight lines, 4 asymptotic straight lines. There will be only 4 asymptotic straight lines at what angle? Okay, 4 asymptote angle 45. Okay, तो पहला start करेंगे 45 से and odd multiples of 45. Okay, so 45 degree. Next will be 135, मतलब 90 more perpendicular. अच्छा, इसी का let's consider better this way. This is the pole at -2 and these are the 4 asymptotic lines. Okay, one of them at 45 degree angle. Next is at 135 degree angle. Next, ये जो last दिख रहा है that is -45 degree angle. And then this is -135, you can see. This is the root locus for K upon S plus 2 power 4. K upon S plus 2 power 4. Easy to draw. Okay, anything for K upon S plus A power M should be easy for you. Anything for K upon S plus A power M should be really easy for you. ठीक है? चलो, done है. Okay, now next problem. A unity negative feedback system has the open loop transfer function s square plus 2s plus 2 upon s square minus 2s plus 2. Find the angle of departure from complex poles and angle of arrival for complex zeros. Okay, for 0 less than k less than infinity. Okay, yeah, minus infinity less than k less than 0. Matlab root locus and complementary root locus. It's negative feedback. Okay, so k positive means root locus, k negative means complementary root locus. Okay. Okay. Nani Venkata, Sanjay sir yesterday took the analog. Sir will be again taking other subjects also, like EDC and all. Chalo, let's check it out. So first of all, we know the formula 180 degree minus 5p minus 5z, yeah, minus of 5p minus 5z, that is okay. But first let us focus on 5p and 5z. First let us focus on the 5p and 5z. Okay. So first what are the poles and zeros? Isko nikal lete. So what are the open loop poles? S square minus 2s plus 2 equal to 0. So what is s equal to? Okay, minus 2 by 2 minus 1 आ जाएगा, plus minus under root of minus under root of 2j. It is 2 by 2 cancel, plus minus j. ठीक है. Then what are the open loop zeros here? Numerator s square plus 2s plus 2 equal to 0. S will be, नहीं ये plus 1 हो जाएगा, minus minus plus. Here it will be minus 2 by 2 minus 1 plus minus j. Okay. So S is basically 1 plus minus j and zeros are at minus 1 plus minus j. Okay. Achha. Now let me draw these poles and zeros first of all. समझ लेना. Let me draw these poles and zeros. Okay, so poles are in the RHP 1 plus minus j. Okay, let us say this is the pole, 1 plus j, 1 minus j, and zeros are LHP, minus 1 plus minus j. Minus 1 plus j, minus 1 minus j. First, let us talk about angle of departure. इसको समझते हैं. One by one. First, angle of departure. सही तो है, angle of departure. First we have the angle of departure. चलो, so angle of departure के लिए first we need the phi p and phi z. Okay, angle of departure is calculated for complex pole. Okay, let us talk about this particular pole, and this pole is 1 plus j. Let us fix any pole 1 plus j. Listen to me. Let us fix any pole, and this is the pole 1 plus j. Okay, this is known as the pole 1 plus j. Now join this pole with respect to all the other poles and zeros. Join it with respect to all the other poles and zeros, such that the direction of the line is towards that pole. जो direction होगा line का, that is towards this pole. That is towards this pole. Okay, the direction is towards this pole. Clear, everybody? Acha. Now, how much is this angle? Okay, let's calculate the angle of departure. Okay, angle of departure. Okay, for 1 plus j, for the pole 1 plus j. Okay, and for angle of departure we need phi p and phi z. Understand how to calculate phi p and phi z. Okay, now this is the line. Okay, this is the line. Okay, which is okay made with respect to other pole, and what is the angle of this line? Okay, let us say phi p1. Okay, now what I told you, phi p. Phi p means sum of angles subtended by all other poles. Okay, with respect to this pole, sum of angles subtended by all other poles. So there is only one other pole. There is only one other pole. Okay, so the sum of angle means only phi p1, and phi p1 ये तो vertical line है ना, ये तो vertical line है तो 90 degree. Okay, then we need to calculate phi z, and then similarly what is phi z? Sum of angles subtended by other zeros. Sum of angles subtended by the other zeros. So what are the other zeros? Okay, these are the other zeros. Let's call, suppose this as z1, z2. Okay, so what is this angle, dear? Isko dekhna. This angle that I am writing, this is going to be the angle of this line, phi z1, and this is line parallel to x-axis. So ये 0 degree हो गया. So phi z will be written as phi z1 plus phi z2. Okay, phi z1 plus phi z2. So ये तो 0 हो गया. But what about the angle of the second line? Angle with x-axis? ये angle कितना हो जाएगा? बताएंगे मेरे को. This is going to be tan inverse, angle within a triangle, tan inverse height है 1 unit, base is also 1 unit, tan inverse 1 upon 1, tan inverse 1 is known as 45 degree. Okay, so ये हो गया 0 degree plus 45 degree. Okay, so what is the phi z? Is 45 degree. What is the phi z? It is 45 degree. Okay. Now dear, answer. Okay, if the question, see, you will have any one of the question, maybe root locus or maybe complementary root locus. Maybe root locus, maybe complementary root locus. Okay. So for k positive, okay, what is the angle of departure formula? It is given by 180 degree minus phi p minus phi z. That is going to be 180 degree minus phi p. What is phi p? 90. Phi z is 45. Okay, so this is 45, and 180 minus 45, 135 degree is the answer. Okay, but for k less than 0, दोनों answer लिख देंगे हम. For k less than 0, what is the angle of departure? Because question में दोनों पूछा है. Then the formula is only minus phi p minus phi z. Note this difference. Then the formula is only minus phi p minus phi z. ठीक है? Okay, so that will be phi p minus phi z हो जाएगा 45. So answer is minus 45 degree if it is complementary root locus. Okay, so for the root locus, angle of departure 135. For complementary root locus, it is minus 45. For you, there will be one question coming up, any one of them. So, but you should know both the formula. But eventually, for both, you need this parameter phi p minus phi z. If it is root locus, 180 minus phi p minus phi z. If it is complementary root locus, minus phi p minus phi z. इतना ही तो करना है. This is the only thing to be done. Okay, that is the only thing to be done. Chalo. So next. Okay, अच्छा, this is the angle of departure. Okay, with respect to the pole 1 plus j. अच्छा, एक और चीज नोट कर लेना यहाँ पे. I will note down here separately. Angle of departure. Okay, this is for 1 plus j, na? Okay, this is for 1 plus j. Okay, if you want to calculate the angle of departure for the other pole, that is 1 minus j, then what is the answer? Then what is the answer? Then what is the answer? Tell me. यहाँ पे लिख देता हूँ मैं separately. Angle of departure for the conjugate pole है 1 minus j, I'm sorry. It is the negative of the angle of departure for 1 plus j. Okay, so here you got 135. For the other pole, if you calculate angle of departure, don't do this geometry again. Answer will be minus 135. That's it, simple. Angle of departure for 1 minus j is negative of the angle of departure for 1 plus j. ठीक है. अब चलो quickly. By same argument, angle of arrival. Should I leave this as homework for you? Should I leave it as homework for you? Please tell me angle of arrival. कर लेंगे आप लोग यार. Let's go to some other topic now. Okay, ये कर लेंगे आप, I know. ठीक है, ये आप कर लेंगे. Because formula I have told you. See, when you want to calculate angle of arrival due to, let's say any one zero, and this zero was how much? Okay, let us calculate the angle of arrival. Sorry, you are calculating now. Angle of arrival minus 1 plus j will be 180 degree minus phi z minus phi p. ठीक है. और अगर k नेगेटिव लिया आपने, so then the answer will be minus of phi z minus phi p. But what is phi p, phi z? Please don't copy from the previous one. Phi z, phi p fresh निकालना पड़ेगा, because now you want the angle. Suppose you are calculating the angle of arrival at this zero, so you want the angle at this zero. All the lines will now be drawn towards this zero. ये वाला data copy करोगे wrong. Okay, there will be one line like this, there will be one line like this, there will be next line like this. ठीक है जी, ये याद रखना. So don't copy phi z, phi p. Okay, that was for pole. Now you have to calculate for a particular zero. This is homework for you. Okay, so you have to calculate here phi z, phi p. Achha, same thing then. If you want to calculate angle of arrival due to other zero, so negative of the first answer. It will be what? It will be the negative of the first answer. ठीक है, तो ये ध्यान रखना. चलो. So what is the next in the dictionary? चलते हैं आगे. Leave this right now. No time for root contour. आगे जाते हैं. Yeah, let's discuss this one problem. Okay. The characteristic equation of a unity negative feedback system is given to you. 1 plus kgs equal to 0. The open loop transfer function has one pole at 0 and two poles at minus 1. The root locus of the system for varying k is shown in the figure. Okay, the constant damping ratio line zeta equal to 0.5. Zeta related with respect to root locus. Okay, intersects the root locus at some point A. Find the distance. The distance from the origin to the point A is also given to you as 0.5. Find the value of k at the point A. Okay, find the value of k at the point A. Zeta, the main intent of taking this question is zeta. That is damping ratio from the root locus. The zeta, the damping ratio from the root locus. ये gate का PYQ भी है. Tell me, think about this, dear. Okay. So characteristic equation of a unity negative feedback system is 1 plus kgs equal to 0. Open loop transfer function gs has one pole at origin, okay, and two poles at minus 1. Okay, itna hi given hai. So what is the characteristic equation? That means it will be 1 plus kgs and GS has a pole at origin, तो S लिखेंगे, and two poles at -1, तो S plus 1 का whole square. This is the characteristic equation. The root locus is given to you. The constant damping ratio line intersects the root locus at point A. What is the value of K at the point A? Let us understand this. Okay, this is the root locus. Okay, and this is the point A. What is the value of K at the point A? Okay, देखो, this particular line is zeta equal to 0.5, and this intersects the root locus at the point A. Now, dear, we know that zeta, of course, is 0.5, but zeta is given by cosine of phi, so that means cos 60 degree होना चाहिए ना? Cos 60 degree is half. Okay. Now, what is that phi? Okay. It is the angle subtended by the radial line to the pole with respect to negative real axis. That means this particular angle ये होगा 60 degree. This is known as 60 degree. Okay. This is known as 60 degree. ये हमें 60 degree given है. ये 60 degree obtained है. Okay. The distance of the point A. The distance of the point A from origin is 0.5. तो ये distance given है. So what I will do is, I will separate out this triangle for you actually. Let us separate out this triangle for you. Okay, where this point is the point A, this is the origin, and what is this? I don't know. Okay, whatever is this point, I don't know. Let us say this is some point B. Okay, but I know that this distance is 0.5 and I know that this angle is 60 degree. Okay, so I can calculate the coordinates of the point A. Na? I can calculate the coordinates of the point A. So what is the only role of zeta? Okay, zeta is 0.5. That will decide what angle you are cutting the root locus. Okay. Okay. So what is A? A is suppose some point x comma y. Okay. What is supposed x comma y, and this is known as the magnitude of x. ये negative side में तो x negative होगा, and this is known as y. Y तो positive ही होगा. Okay, how can you calculate x and y? By the basic trigonometry. If you apply sine 60 degree, that is known as opposite sine upon hypotenuse. Okay, so y will be equal to 0.5 into sine 60 degree root 3 by 2. So this is basically root 3 by 4. Okay, now when you apply the cos 60 degree to the problem, that is given by base. Base means modulus of x, because x actually negative hoga. Clearly the point A is in the LHP. Okay, divided by the hypotenuse. So what is the mod x? It is 0.5 into cos 60. Cos 60 is further half. So this is half 1 by 4. Okay, so basically like what is the point A? Point A is given by minus of 1 by 4 and root 3 by 4, and the point A lies on the root locus. The point A lies on the root locus. Story is now over, I think. The point A lies on the root locus. Okay, the point A lies on the root locus. Okay, there is a pole at origin. This is some point A, minus 1 by 4, root 3 by 4, and there are two poles at minus 1. Okay, हमें कुछ नहीं करना है. Join these two poles here. Okay, what is the value of K at any point on the root locus? Dear, what is the value of K at any point on the root locus? That product method. Okay, the distance of that point with respect to this pole, suppose P1. Distance of this point with respect to the other pole, it is P2. Remember, this is double pole. There are two poles at minus 1. It is clearly mentioned in the question. There are two poles at minus 1. So it is a double pole case. It is a double pole. So it is going to be P1 multiplied by P2 square divided by distance with zeros. But there are no zeros, so denominator will be 1. So answer is P1 into P2 square. Answer is P1 into P2 square. What is P1? Distance formula, dear. P1 will be under root of, ये origin है ना 0, 0. Okay, तो under root of minus 1 by 4 का square plus root 3 by 4 का square. तो ये कितना आया? This is going to be 1 plus 3, 4, 4 by 16, 1 by 4, under root आ गया 1 by 2. Okay, just check the calculation once. What's going to be P2? अच्छा, P2 का square चाहिए directly, so no need for under root. Minus 1 by 4, minus plus 1 का whole square, and y2 minus y1, that is root 3 by 4 का whole square. So how much is this equal to? This becomes 3 by 4. So 3 square 9. Root 3 square 3 divided by 4 square 16. This is 12 by 16, or that is 3 by 4. Okay, so K is given by 1 by 2 multiplied by 3 by 4. Answer is 3 by 8. Numerical answer type to 0.375. Okay, 0.375. 0.375. Clear, everybody? Yes, dear. Yeah, if any pending PDFs are there for special 26, I will upload that. ठीक है, मैं upload करता हूँ उसे. I'll upload it in a day or two, especially the special 26 one. Special 26 one. Special 26 series classes. So guys, now be ready for the next topic. Be ready for the next topic. Huh? Just a minute. Okay, shortcut for sketching the polar plots. Okay, let me see how many of you know this. Okay, so I'll do one thing. I'll give you one very, very important problem. Sketch the polar plot for this, and I'll be just there in 2 minutes. I'll be just there in 2 minutes. So please do this one. Okay. Polar plots and Nyquist plots को थोड़ा सा revise करते हैं. चलो, tell me. Okay, chalo. So good, you're able to recall the starting point, diving point. That's what, yeah, we need to apply here. Okay, so let's move ahead. Okay. Sketch the polar plot for GSHS equal to S1 plus ST1, 1 plus ST2. And before I explain that, yeah, let us have the shortcut for sketching the polar plots. Okay, the GSHS plots. Okay, shortcut for sketching the GSHS plot. Ab dhyan dena yahan pe. Okay, let us say GSHS is in the form. Let us say GSHS is given to you in the form that is K 1 plus ST1, 1 plus ST2, etc., etc., etc. is divided by S raised to the power n. Okay. 1 plus STA, then there are some poles, 1 plus STA, 1 plus STB, and etc., etc., etc. Okay, let's say this is what is GSHS given to me. Okay, now here, what is the value of n, dear? N clearly means number of poles at origin. Okay, number of poles of GSHS at origin. Okay, this is known as the number of poles at origin. Okay? Number of poles at origin. Now let us say P is the total number of poles. Okay, not only origin, P is the total number of poles of GSHS, that is open loop poles. Same parameter, open loop poles. Z is the total number of open loop zeros. That means total number of zeros of GSHS. Clear? Achha. Now you will start calculating. Okay, number one, starting angle. Okay, starting angle is for omega tending to 0, and that starting angle I will represent by theta d. Sorry, I will represent by theta st. Okay, I will be writing down the theta st as minus 90 degree into n. There will be special cases, I will elaborate that also. But generally you can write down minus 90 degree into n. What is the theta st is minus 90 degree into n. The attendance is even below 50 now. Stop. Tell me the signal to stop. What is that? Not even 50 left. I know it's almost continuous. How much? It's almost continuous 6 hours since morning. We just had a 20 minutes break in between. But it's like almost, continuous 6 hours. It has been continuous 6 hours. Okay, so theta st is minus 90 degree into n here. Minus 90 degree into n here. Okay, that is known as the theta st. Okay, now what is the diving angle? I'll tell you the special cases, but first let me write down the formulas. What is the diving angle? Diving angle means for omega tending to infinity, and we are going to call it as theta d. Now when I say diving angle, what does the word diving here means? Okay, diving se mera matlab hai, okay, for large values of k, the polar plot will be, for large values of omega, the polar plot will be diving into the origin. Diving into the origin, and then the theta d is given by, the theta d is given by how much? The theta d is given by the formula minus 90 degree into P minus Z. Into P minus Z. Now there will be special considerations here. Okay, there will be special considerations here. What are those special considerations? सबसे पहले याद रखना. Okay, सबसे पहले याद रखना कि suppose if n equal to 0, some special points. Okay, if n equal to 0, okay, then what is the value of theta st? If n 0, तो theta st is 0. Okay, theta st is 0. Okay, n equal to 0, theta st is 0. Theta st कितना हुआ? 0. For n equal to 0, theta st is 0. Now, where is the 0 angle? 0 angle means positive real axis. 0 angle is seen at the positive real axis. That means ये theta st है, starting की बात है, तो I can say that polar plot starts from positive real axis. Polar plot starts from positive real axis, and that too with finite magnitude. That too with the finite magnitude. देखो ध्यान देना, what happens? Finite magnitude क्यों बोला मैंने? Because if n is 0, तो s power 0 is 1. Okay, s power 0, this term is removed. Okay, basically this term is removed, s power 0 is removed. Now when you put s tending to 0, omega 0 means s tending to 0. So s tending to 0, this is gone. You're only left with finite numbers, k. Okay, k into 1 divided by 1. So the answer will be finite. So polar plot starts with finite magnitude. Polar plot starts with finite magnitude if n is 0, and that starts from positive real axis. Okay, but similarly if n not equal to 0, चलो इसको यहीं लिख देते हैं. Okay, so for n not equal to 0, okay, polar plot starts from some infinity. If the n is not equal to 0, polar plot starts from some infinity. The polar plot starts from some infinity. Polar plot starts from infinity. Okay, because if n not equal to 0, अगर n को 1 या 2 कुछ भी रखा तो at s equal to 0, 1 upon 0, 1 upon 0 means infinity. 1 upon 0 means infinity. Then it will start from infinity. Okay, with what angle? With what direction? That is given by theta st, na? Minus 90 degree into n. Whatever non-zero value of n you have, we will see and write down the answer. Next important point to be considered is if there are poles and zeros in RHP. If there are poles or zeros in RHP. Okay. If there are poles and zeros in RHP, na dear, theta d, the diving angle, will not affected. Theta d formula same रहेगा आपके लिए. Theta st will change. Theta st will be given by the formula minus 90 degree into n plus 180 degree. There will be an add-on 180 degree if there is a 0 in RHP. Okay. If there is 1 0 in RHP. Okay, so by chance अगर 2 zeros है तो by chance if there are 2 zeros तो 360 degree will be added. ठीक है, or it will be minus 90 degree into n minus 180 degree if there occurs a pole in RHP. For a single pole in RHP, you subtract 180 degree. If there are multiple poles, you keep subtracting 180 degree for every pole that is in the RHP. Okay. But for any pole or zero in the RHP, diving angle is not affected. Diving angle is not affected. Okay. Next point to be noted is, just a moment. The next point to be noted, let me take a slide here. The next point to be noted is that by chance, if the number of poles are less than equal to number of zeros, okay, that means degree of numerator, zeros are more, degree of numerator is more, then at omega tending to infinity, plot will also be at infinity. It will not dive into origin. Okay, I will simply mention, इसको बाद में अलग से देखेंगे if required, but here I will mention don't apply the tricks, okay, because diving fails. Okay, the plot does not dive into origin. The plot does not dive into origin. Clear? Now have a look into it before we go to the question that I had given you. Polar plot for 1 upon S1 plus ST. Now quickly, by the shortcuts, we are not giving the detailed method, we are directly taking the shortcut. So polar plot for 1 upon S1 plus ST kya hoga? First of all, dear, okay, first of all, how many poles at origin? There is one pole at origin, S power 1 ka case hai. Okay, so what should be the theta ST? Minus 90 degree into n, that is minus 90 degree. Okay, minus 90 degree. Theta ST minus 90 degree. Clear? Okay, then Then what about the total number of poles? 1 and 2. 1 at LHP and 1 at origin. Total poles is 2. How many zeros? Nil. There is no zeros. So what is going to be the diving angle? Minus 90 degree into P minus Z. So diving angle is minus 180 degree. Diving angle is minus 180 degree. Okay. So chalo, now how to quickly sketch the polar plot by this much of the knowledge? वो देखते हैं. Okay, how to quickly sketch the polar plot. So, okay, what is the diving angle? Diving means dive into origin. I specified to start with the diving first of all. You will dive into the origin, okay, along minus 180 degree. Achha, I have to dive into the origin. Okay, but origin को मैं ऐसे भी आ सकता हूँ, ऐसे भी आ सकता हूँ. I can come like this, I can come like this. There are multiple ways I can come anything. That is why I have mentioned the angle. At what angle you are going to arrive at origin, you are going to dive at origin, and that is minus 180 degree. And minus 180 degree means negative real axis. Minus 180 का मतलब क्या होता है? Negative x-axis. So, when you are going to dive into the origin, you are going to dive such that you are coming. It should look like, it should look like you are coming along negative x-axis. It should look like you are coming along negative x-axis. ठीक है? Then what about this? ये ऊपर से भी तो हो सकता है. In both ways you are coming along negative x-axis. So it should be looking like you are coming along negative x-axis and you slide and dive into origin. ठीक है. But whether it is first or second, ऊपर वाला या नीचे वाला, for that I have this leftness. I have to see starting. Where it is starting from? It is starting from minus 90. Minus 90 is negative y-axis, na? Minus 90 means negative y-axis. So it is starting somewhere from negative y-axis. Downwards. Okay, that is why this is to be taken, this is not to be taken. So now let me remove and join it. Let me remove and join it. Let me remove and join it. So this becomes how much? Okay, this becomes the polar plot. This was the starting case. Starting wo le to omega equal to 0 plus. Okay, omega equal to 0 plus, because polar plot is the plot for positive frequency and this is the diving, omega equal to infinity plus. Let me complete the arrow. Here. This is the answer. Acha, sir, why not like this? You can keep asking questions so that your concepts are clear. Sir, why not like this? ऐसा भी तो हो सकता था. It starts from here, it cuts the x-axis in between, and then again towards negative x-axis. ये minus 180 के through यहाँ आ जाए. Why not like this? Okay. Why not like this? I'll explain you that. Okay. To go like this, it is cutting the axis in between. It is cutting any axis in between. It is changing the quadrant. Whenever polar plot changes the quadrant, we will call that frequency as critical frequency. We give it some name, okay? Whenever polar plot cuts the negative, whenever polar plot cuts any axis, it is critical frequency. It is critical frequency. Now, when will the critical frequency arise? When it will not arise? थोड़ा सा ध्यान देना. Okay, when you are going to write down the angle, when you write down the angle expression for this, देखो, this is ultimately when you put s equal to j omega, na? Okay, this is known as 1 by j omega, 1 plus j omega t when you convert it to the frequency domain. 1 upon j omega, 1 plus j omega t. And when you calculate the angle of this expression, na? What is angle gj omega at j omega? The angle part, numerator 0 because it's a positive real number. Denominator pure imaginary, so 90 degree. For every denominator term I write down minus. Okay, and then x plus jy. What is the face? X plus jy, tan inverse y by x. Okay, I will give you a small hint. Okay, थोड़ा shortcut बताते जाता हूँ. How many tan inverse term you have? How many tan inverse term you have? Only one tan inverse term. Critical frequency is possible if you have two or more than two tan inverse term. Note कर लीजिए कहीं पे. Critical frequency is possible if you have two or more than two tan inverse term. For a single tan inverse term, it will not come. And critical frequency doesn't come means you will never change the quadrant. If you never change the quadrant means you are always in the single quadrant. You are always in the single quadrant. Okay? You are always in the single quadrant. So now, eventually we will come to cases where you cut quadrant. Us pe bhi aa jayenge na. Eventually we will come to those cases also where you are cutting the quadrant. where you are cutting the quadrant. We will come to that as well. Okay, so have a look into it. This is the polar plot complete. Now I have next problem in front of you. 1 upon s square 1 plus st. Okay, quickly, what is the value of n is 2? Okay, so what is the theta st? Minus 90 degree into 2. There are the two poles at origin. Okay, so starting is minus 180 degree. Okay, what is the diving? Okay, so I have number of poles, 2 at origin, 1 somewhere else. So total number of poles is 3 and zeros are still not there. Zeros are still not there. So z equal to 0. Okay, z equal to 0. So what is the diving angle? Minus 90 degree into p minus z. Okay, that becomes minus 270 degree. So diving is minus 270 degree. Now let me draw the plot. Okay, let me draw the plot. Let me draw the plot. Okay, and dekho, so diving, let's start with diving. Dive into origin minus 270. Where is minus 270? Even if you don't, nothing to remember, na, minus 270. I told you multiple times, minus bole to clockwise chalna. Clockwise 270, 90, 180, 270. When I travel clockwise 270, I come along the positive y-axis. Okay, so my diving should be along positive y-axis. Okay, but maybe first quadrant or second quadrant, wo kaise decide kare? When I dive into the origin, I should be like just traveling along y-axis and then I touch the origin. ऐसा होना चाहिए ना? Then I touch the origin. Okay. But second या first quadrant, उसके लिए starting देख लेते हैं. Starting is minus 180 degree. Minus 180 is where? Negative x-axis. Minus 180 is where? 180 degree means negative x-axis. So you are starting somewhere from here. You are starting from here. That is why second quadrant plot first नहीं होगा. ठीक है, second quadrant plot first नहीं होगा. So you are starting somewhere from here and you come and dive into the origin here. Okay, this is the diving point, that is for omega equal to infinity plus, and this is the starting point. I call it as 0 plus, and let me draw the arrows. Later on for encirclement and all, these arrows will be important. Na? So draw the arrows 0 plus to infinity plus. From the 0 plus to the infinity plus. This is the polar plot complete. Okay, this is the polar plot complete. ठीक है? अच्छा जी, ये polar plot हो गया. Okay, once again you can see, when you find out the angle expression, don't find out, but there is only 1 plus j omega t single term. Now, how many tan inverse will come? Wait, this is s square. S square means j omega square. Every j omega 90 degree. Okay, so this is fixed angle, 90, 90, but this will give tan inverse omega t. How many tan inverse term? Single. Critical frequency is possible if and only if you have 2 or more tan inverse term. If and only if you have 2 or more tan inverse term. Clear हो गया? ठीक है, तो यहाँ possibility नहीं है. यहाँ पे possibility नहीं है. If you have 2 or more tan inverse term. Clear everybody? Okay, so let's move ahead to the next then. Let us move ahead to the next. Let us move ahead to the next. Fine. Okay, now what is the difference in the two polar plots, dear? Our first one, dekho, this is 1 upon, this is known as 1 upon s square 1 plus st. Okay, we have already drawn for 1 upon s 1 plus st. This was the plot. 1 upon s 1 plus st. What is the difference in the functions? Okay, इसको यहीं पे अगर replicate करें, this is 1 upon s 1 plus st. So rather than s, you have s square, matlab extra pole at origin. You have extra pole at origin. You have one added pole at origin, and due to which what happened, the Nyquist plot is like rotated 90 degree clockwise. The Nyquist plot is rotated 90 degree clockwise. The Nyquist plot is rotated 90 degree clockwise. 90 degree clockwise. Clear? 90 degree clockwise. ये ध्यान रखना. 90 degree clockwise. Okay. So there are some important conclusions to follow. Okay, which is available here. कहाँ चला गया? Okay, but rather than noting it like this, ना मैं इसको थोड़ा सा simple कर देता हूँ. Okay, मैं इसको थोड़ा सा simple कर देता हूँ. Okay, addition of open loop pole at s equal to 0. देखो, I will write here both the points. I'll make it simple in the form of table. addition of open loop pole, addition of open loop 0. Okay, please remember this. Okay, now number 1, when you add the open loop pole at origin at s equal to 0, entire polar plot, that is theta st and theta d, both change, okay, by 90 degree clockwise. Entire polar plot means both starting and diving also changed, we can say. So both starting and diving will change by 90 degree clockwise, and similarly if it is addition of open loop 0, reverse effect will be seen, that at s equal to 0, okay, when you add the pole, the diving and starting, the theta st and the theta d, okay, again will both change, but by reverse effect. Reverse effect means 90 degree anti-clockwise. 90 degree anti-clockwise. Next effect is when you add the open loop pole. Okay, on the negative real axis at -1/t. At the negative real axis. तो क्या होगा वो भी observe करेंगे अभी. Let us observe that also. When you add the pole at the negative real axis. When you are going to add the pole at the negative real axis. Clear? Chalo. We'll observe that. Okay. So yeah, before we observe that, let's come to this plot once again. Okay. So we have 1 upon s, 1 upon s square, 1 plus st. We can do one more activity here now. Gradually, let me complete one more activity here. Okay. We started with this one, 1 upon s, 1 plus st. Okay. Then we had this one, which is 1 upon s square, 1 plus st. Now dear, if you take 1 upon s cube, one more pole at origin, add one more pole at origin, so again 90 degree clockwise rotation, complete 90 degree clockwise rotation, you will be getting something like this. This should be 1 upon s cube, 1 plus st, right? If you add one more pole at origin, so isko again 90 degree clockwise rotate kar denge. So this is the one, 1 upon s power 4, 1 plus st. 1 upon s power 4 into 1 plus st. Okay. So that is what it is. Now have a look into this example which I had given you to solve. Polar plot for 1 upon s, 1 plus st1, 1 plus st2. Polar plot for the 1 upon s, 1 plus st1, 1 plus st2. Isko dekhenge yahan pe. So dear, what is the value of n? N is equal to 1. Okay. Okay, n equal to 1. So what is the starting angle? Minus 90 degree into 1. That is minus 90 degree. Minus 90 degree into 1, that is minus 90 degree. Okay. Now how many poles are there? Okay. How many total number of poles are there? And how many total number of zeros? Zeros abhi bhi nahi hai. Okay, but there are total 3 poles. Okay, so what is going to be the diving angle? Minus 90 degree into P minus Z. So diving is minus 270 degree. Diving is minus 270 degree. Clear? The diving is minus 270 degree. Okay. Chalo, so let's draw. Only on the basis of this knowledge, pehle draw karte hain, then let's learn something important here. Okay. So, if you have a look into it, okay, the starting angle is minus 90 degree. Okay, the diving angle is minus 270. Let me start with diving. Diving means dive into origin. Okay, diving will mean dive into origin. At what angle dive into the origin? Minus 270. Minus 270 means positive y-axis. So dive along positive y-axis, but starting from where? Dear, starting from minus 90, and minus 90 means negative y-axis. Minus matlab clockwise 90 chale, so you are along negative y-axis. So you have to start along the direction of negative y-axis. Okay, so it is very clear picture now that you are starting. It is very clear picture that you are starting downwards, but you are going to dive along positive y-axis. So automatically you are able to realize, you should be able to realize that you are cutting the negative real axis. You are cutting some axis actually. Okay, you are cutting some axis. Okay, I am going to call this point as critical frequency. Later on we'll call it as phase crossover, but let me right now call it as the critical frequency. Okay, now this is the diving known as infinity plus, this is the starting point known as the 0 plus, and let me draw the arrow that as I move from 0 to infinity, I am going to cut an axis in between. That is known as critical frequency. That is critical frequency. What is the critical frequency here? How do we calculate critical frequency here? Why the critical frequency is coming up here? Dear, when you calculate the angle expression for this, na dhyan dena. What is the Gj omega Hj omega? What is the Gj omega Hj omega? K upon J omega 1 plus J omega T1 1 plus J omega T2. Okay, when you are going to calculate the angle expression, na, that is, when you are going to calculate the angle expression, numerator the positive real number. Okay, K upon, isko 1 ki jagah K hi le lete hain. Let me put it in the better form. Okay, let us generalize it. Okay, so what it is, minus, numerator is positive real number 0, denominator J omega 90, then tan inverse y by x, so tan inverse omega T1 minus tan inverse omega T2. So you have 2 or more tan inverse term. Okay, it is not, it is having 2 or more tan inverse term. Okay, no Krishna. So that is why critical frequency is possible. Acha, now what is the simplification of this expression? Right, minus ko common le le, to tan inverse A plus tan inverse B. And what is tan inverse A plus tan inverse B? It is known as tan inverse A plus B upon 1 minus AB. Okay, upon 1 minus AB. Dekho, for critical frequency, first of all, simplify the angle expression in terms of single tan inverse. If there are 2 or 3 tan inverse, use a tan inverse A plus tan inverse B, yeah, tan inverse A minus tan inverse B. Okay, now take the numerator equal to 0. Take the numerator equal to 0. Okay, numerator equal to 0 will give you omega 0. Will give you omega 0, but it cannot be the critical frequency, because the critical frequency, very clear, na? Critical frequency is between starting and diving. It should be between 0 to infinity. It cannot be 0 or infinity. Okay, so critical frequency it is between 0 to infinity. Okay, so now numerator se kaam nahi aaya. So I will now take denominator equal to 0. So 1 minus omega square T1 T2 equal to 0. Okay, so from here, what is the value of omega C? Here you will get the valid critical frequency, and that is given by 1 upon root T1 T2. 1 upon root T1 T2. Okay. You tell me, Krishna, why it should be touching negative imaginary axis, then I will tell you. Then I will tell you why it is not cutting. Koi chance hi nahi hai na. At least some things have to be visual. We can derive from the angle also why it is not cutting negative y-axis. Okay, but some things have to be visual. So you tell me why it is cutting negative imaginary axis, negative y-axis. Okay, how it goes like this, it counts like this and like this. No, na? You tell me why it is cutting, then I will tell you why it is not. Chaliye, theek hai ji. So this is what it is. So definitely you have the critical frequency coming up as 1 upon root T1 T2. Acha, ab ye dekho. Okay. ये देखो, omega c is 1 upon root T1 T2. At the omega c, denominator 0 हुआ. Okay, denominator 0 हुआ. So at omega c, what is the angle? Denominator 0. ये देख लीजिए यहाँ पे, चलिए. Denominator 0, 1 upon 0 infinity, tan inverse infinity. Tell me, tan inverse infinity 90. Already there is one more 90. So minus 90, minus 90. Minus 180. So where you are cutting? ये भी clear हो गया. Where you are cutting? You are cutting at minus 180 degree. Minus 180 means negative real axis. Minus 180 means negative real axis. So omega c is known as 1 upon root T1 T2, and at the omega c you are cutting the negative real axis. And what is the magnitude at this frequency? What is the magnitude of this point? Distance from origin. Please note down, I am not deriving it. It will be given by k T1 T2 upon T1 plus T2. This one will be given by k T1 T2 upon T1 plus T2. Okay? It is given by the k T1 T2 upon T1 plus T2. K T1 T2 upon T1 plus T2. That is known as the magnitude at that point. K T1 T2 upon T1 plus T2. ठीक है, ये नोट कर लीजिए यहाँ पे. अच्छा, now we had one more polar plot. Okay, 1 upon S1 plus ST. 1 upon S1 plus ST, and this was of this kind. What is the difference in these two? This is for 1 upon S, 1 plus ST1, 1 plus ST2. देखो, 1 upon S, 1 plus ST, one more 1 plus ST, मतलब one more negative real pole. One more pole at minus 1 by T2. So I have added a pole on negative real axis. I have added a pole on negative real axis, due to which what is the effect in the polar plot? Due to which what is the effect in the polar plot? बताइए. Due to which what is the effect in the polar plot? ये बता दीजिए. The effect in the polar plot is there is no change in the starting. They are both starting from identical location. They are both starting from identical location, but there is a changing in the diving. There is a change in the diving. There is what? There is a change in the diving. Diving कहाँ तक गया? There is a change in the diving. So diving कहाँ तक गया? Tell me. There is a change in the diving. Diving. Okay. It was along negative real axis. Now it dives here. So diving 90 degree clockwise. Diving has been shifted 90 degree clockwise. Clear? Diving. Only diving changed, starting not changed. Diving is 90 degree clockwise changed. Okay. So when I was writing those conclusions, no? Okay, let me add on there only. Yeah, I was making the table. So when you add the pole at the minus 1 by T, negative real axis. When you add open loop pole at negative real axis, so theta st, no change. Okay. Diving will change by 90 degree clockwise. Matlab minus 90 basically. Similarly, when you add the 0, the effect will be reverse. Theta st, of course theta st, no change means no change. No change is 0 degree. But theta d, which changed by 90 degree clockwise, it is now going to change by 90 degree anti-clockwise. 90 degree anti-clockwise. 90 degree anti-clockwise. It will now change by the 90 degree anti-clockwise. Okay? Tell me. 1 upon S, 1 plus ST1, 1 plus ST2, 1 plus ST3. 1 plus ST3. Tell me. So यहाँ पे क्या होगा? Let's complete this quickly. One more pole, dear. It is just one more pole on the negative real axis. Correct? one more pole on negative real axis, तो diving ही तो change होगा. Yeah, only this diving will further change 90 degree clockwise. So it should be starting same, it should dive like this. Okay. Rather than positive y axis 90 degree clockwise किया, तो you come to positive x axis. This is going to be the answer. ठीक है? This is going to be the answer. This is going to be the answer. अच्छा, अगर ये clear है ना, I will give you one homework. If this much is clear, now you can tell me what should be the answer for 1 upon s square 1 plus st1 1 plus st2 1 plus st3. Okay. 1 upon s square 1 plus st1 1 plus st2 1 plus st3. What is the angle for, what is the polar plot for this, dear? Previous one से compare करें तो one more pole at origin. Now pole at origin means entire polar plot 90 degree. Both. ये भी change होगा, ये भी change होगा. मतलब if I roughly tell you, it will be something like this. It will be something like this. ठीक है? That is the homework for you. Already hints I have given as the answer. Okay. Hint में मैंने आंसर बता दिया है, so you can try it out. For the similar type of case, okay, for the similar type of case, okay, similar type of function k upon s 1 plus st1 1 plus st2, let me also complete the Nyquist plot now, and we will come to some more polar plot. Okay, we'll come to some more polar plot. Sketch the Nyquist plot for k upon s 1 plus s by 2 1 plus s by 3 and determine the range of k for stability. And determine the range of k for stability. Now, before I explain you this, one thing I need to tell you. Okay, the range of k for stability. I'm going to use this. I'm going to explain you this one. Range of k for stability. Now, dear, if you want to understand this, if you want to understand this, okay, I will give you one complete thing. See, if you want to have the complete understanding of Nyquist stability criteria, okay, whether it is n equal to p minus z or n is equal to z minus p, there are the two concepts, okay, p minus z or z minus p, which to apply, which not to apply. I will give you the briefing here. Okay, we are revising, but if somebody is interested and want to learn very beautifully how the Nyquist stability criteria is derived, why we take the encirclement of -1, 0 and all those things, if you want to understand this, I have covered this in the special 26 lesson, in the special 26 class. Okay, if you did not attend, I will share you the link. Okay, you can attend it. The entire class, the entire almost 2 hours class was on the Nyquist stability criteria only. Yeah, in YouTube. Have a look into it. I have shared you the link. I've shared you the link. That has been covered in the special 26 and recently, maybe around, कब किया था? Let me see, 10-15 days back only. 12 days ago, just 12 days ago. Just 12 days ago. Telegram link चाहिए चलो. Meanwhile, I'll share you the Telegram link also. Okay, then we'll continue with this question. This is the Telegram link. ठीक है, छोड़ दे. Done. Tired. You let me know if you're tired. I can stop anytime. I'm continuing only for students. You let me know when you're tired. I will stop. मेरे को कोई issue नहीं है. Chalo, okay. So I have shared you the link. Okay, you can watch it up later on. Okay, how much is the duration of that video? See, it's almost 2-hour video. Okay, it is again almost 2-hour video explaining, okay, complete Nyquist criteria step by step. Okay, step by step. Chalo, so let's, okay, move ahead. Okay, which will explain you ki why this criteria exists. Okay. Now, I'll explain you. I'll give you the briefing, but the derivation can be seen there. Okay, the sketch the Nyquist plot for GSHS equal to K upon S, 1 plus S by 2, 1 plus S by 3, determine the range of K for stability. Okay, so we know that this is what form? Okay, I have taken the regular form first of all. This is of the form K by S, 1 plus ST1, 1 plus ST2. K by S, 1 plus ST1, 1 plus ST2. Okay, this is the form K by S, 1 plus ST1, 1 plus ST2. Okay, now let me first of all draw the polar plot corresponding to it. I'll explain you step-by-step procedure for the Nyquist plot. It is very simple. Once you have obtained the polar plot, it is very simple. Okay. The first step, fundamental one. Okay. The first step, fundamental one is draw the polar plot. Number one, what you will do? You will draw the polar plot. Just now we have seen the polar plot for K upon S, 1 plus ST1, 1 plus ST2. Okay, I have drawn the polar plot. Then what is this frequency and all? वो बाद में लिख देंगे. Number one step is draw the polar plot. Number two, take the mirror image of the polar plot. Okay. Number one, polar plot. Number two, mirror image of polar plot. I'll just write down like this. Okay. Number one, draw the polar plot. Number two, take the mirror image of the polar plot. Okay. About what? About the horizontal. That is the real axis. Take the mirror image about real axis. And number three, okay, we will talk about closing from omega equal to 0 minus to omega equal to 0 plus. Closing from 0 minus to 0 plus. Okay. 0 minus to 0 plus. So second step is take the mirror image about the horizontal, about the real axis. Okay, तो just flip it up about the real axis. इसका mirror image लेना है. Mirror image about the real axis. This is what is the mirror image about the real axis. ठीक है? Mirror image about the real axis. Done है? Now next. Okay. Closing from 0 minus to the 0 plus. Okay. Closing from 0 minus to 0 plus. Now, whenever you have the closing from 0 minus to 0 plus, you will close it through a arc of infinite radius. Okay. Through a circular arc of infinite radius. Okay. And okay. Angle that is n pi in the clockwise sense. With the angle that is n pi in the clockwise sense, where n is the number of poles, as I mentioned earlier also, n is the number of poles at origin. N is the number of poles at origin. तब यहाँ देखना, n is the number of poles at origin. So what are the poles of this one? Okay, you have poles 0, okay, then -2 and -3 when you solve denominator equal to 0. Okay, this leads to the value of n equal to 1. How many poles at origin? Okay, it is equal to 1. So what is the closing angle then? Closing angle will be 1 into pi and closing angle will be clockwise. Okay, so closing angle equal to pi clockwise. Okay, that is equal to pi clockwise. Okay, so now let me write down the important point. Dekho, this was the mirror image. Okay, what was the original polar plot here? That started from 0 plus and infinity plus the diving. Then it is the mirror image. So mirror image 0 plus will become 0 minus, infinity plus is infinity minus, and now join from 0 minus to 0 plus through an angle of 1 pi. Here it is 1 pi in the clockwise sense. Okay, of course it is why it is pi. Pi means 180 degree because you are at positive y-axis, you have to come towards negative y-axis. So automatically 180 will come, na? Automatically 180 will come. So from here, you have to take it through a circular arc of infinite radius. And come and join this point, that is 0 plus. Come and join this point, that is known as the 0 plus. Come and join this point, that is known as the 0 plus. Come and join this point, that is known as the 0 plus. That is known as the 0 plus. ठीक है? तो अब देखो, let me draw the arrows now for increasing omega. This is infinity minus to 0 minus. Zero minus to 0 plus. 0 plus to the infinity plus. 0 plus to the infinity plus. 0 plus to the infinity plus. Okay, 0 plus to infinity plus. This is complete. Okay, now what is this frequency known as? This was the critical frequency and that is 1 upon root T1 T2. कितना हो जाएगा? Root T1 T2. Okay, so what is going to be the critical frequency? 1 upon root T1 T2. 1 upon root T1. T1 is 1 by 2, T2 is 1 by 3. So 1 upon 1 by 2, 1 by 3, 2, 3 is 6 super gas. So it is root 6. Critical frequency is root 6. What is the magnitude at critical frequency? The magnitude was given by the formula K T1 T2 divided by T1 plus T2. So K into 1 by 2 into 1 by 3 is divided by 1 by 2 plus 1 by 3. 6 से multiply करेंगे तो I get K divided by 3 plus 2, that is 5. This is K by 5. Okay, so that means this critical frequency is, after solving मैं value लिख रहा हूँ यहाँ पे, and that is turning out to be root 6. And what is the magnitude at this frequency? This magnitude is K by 5. This is the Nyquist plot complete. This is the Nyquist plot complete. Okay? Nyquist plot complete. Ashok, by the formula K T1 T2 upon T1 plus T2, just put down the values T1 T2 upon T1 plus T2. The formula already I mentioned in the polar plot. K T1 T2 upon T1 plus T2. Okay. Acha. Now, the question was, sketch the Nyquist plot. This is one part. Okay. Then, determine the range of K for stability. Determine the range of K for stability. What is the range of K for stability? What is the range of K for stability? Here comes one of your most awaited things now. You are looking for password. Ye le lijiye. Okay, the password. Okay, polar. All small. Okay, the PDF, which is going to be password protected. Okay, and that will be polar. POLAR, everything in small. I'll share you the PDF probably tonight only. Like digital ka bhi same day night pe share kiya tha. Okay, this also I'll try to share you tonight only, and the password will be polar. Okay. Okay, chalo, let's move ahead. Okay, so yeah, the Nyquist stability criteria, as you know, I told you derivation, you can look into one of my complete videos. That takes complete time, around 2 hours. But yeah, the stability is assessed by the formula n equal to p plus minus z plus. Okay, of course, okay, using Nyquist contour, which is clockwise. Okay, assuming Nyquist path, which is clockwise, n equal to p plus minus z plus. By chance, if you have anti-clockwise Nyquist path given to you, okay, then you will be using the formula reverse, that is z minus p. Okay, now what is p and z? Listen to me carefully. What is p and z here? What is p and z? P plus is the number of poles of GSHS in the RHP. Okay, so poles in the RHP, that is in the right side plane, that is in the positive side. That is why I represent plus here. That is why I represent plus here. Okay. Okay. Plus means positive side, to make you remember easily. Plus bole to positive side wala hai. The number of poles of GSHS lying in the RHP. Z plus is the number of zeros of 1 plus GSHS. Z plus is the number of zeros of 1 plus GSHS equal to 0 lying in the RHP. Number of zeros of 1 plus GSHS. That means 1 plus GSHS equal to 0 is characteristic equation basically. So Z plus is nothing but the zeros of characteristic equation, yeah, roots of characteristic equation. Z plus is nothing but roots of characteristic equation lying in the RHP. And if you want the system to be stable, you should know that there should not be any root in the RHP. So what you want? Z plus 0. For the system to be stable, what you want to ensure that Z plus should be 0. For the system to be stable, you need to ensure that Z plus is 0. You need to ensure that Z plus is equal to 0. Okay? Acha, one more thing I will add here. Chalo, pehle us question ko complete karte, then one more thing I will add here. Okay, one more thing I'll add there. Chalo, yeah. So this is the Nyquist plot complete. Now whether minus 1 comma 0 is encircled or not, because I explained you p plus and z plus. Now eventually what is the value of n? What is the value of n? Number of encirclements of the origin. Which origin? Minus 1 comma 0, modified origin. Okay, by the GSHS plot. Okay, and n also has a sign convention. Dear, n also has a sign convention. N is taken to be positive for anti-clockwise encirclement, negative for clockwise encirclement. Positive for anti-clockwise encirclement, negative for clockwise encirclement. Okay, now let's go there. We need to check the encirclements of minus 1 comma 0. Important point, minus 1 comma 0. Okay, where is minus 1 comma 0? Can you tell me? Can you tell me? Yes, Chinmoy. Where is the minus 1 comma 0? Can you tell me? Bataiye. Where is the minus 1 comma 0? Of course, it is on the negative real axis, na? Of course, it is on the negative real axis, but where? It depends on the value of k. Suppose if I tell you k ka value 10 hai. Suppose k is unknown, na? If k is 10, this becomes 10 by 5, 2. And if this is 2, the 1 will be inside. 1 will be inside. But if I tell you k is not 10, k is only 1, so 1 upon 5. 1 upon 5, this is 0.2. If this is 0.2, 1 will be outside. 1 will be outside. Okay, so it may be inside, outside. That depends on K. That depends on K. So there are two possibilities. यहाँ पे देखेंगे हम लोग that there are the two possibilities here. -1, 0 may be inside. Okay, -1, 0 may be outside. Okay, I'll write down the possibilities here. Number 1, okay, अगर k/5 less than 1 है, okay, if the k/5 is less than 1, if this is k/5, it is less than 1. What is the distance of -1, 0? That is 1. So if the k/5 is less than 1, okay, -1, 0, that goes outside. Clear? That goes outside. This is my case number 1. Okay, -1, 0 outside hai, so there is no encirclement. There is no encirclement. ठीक है? There is no encirclement. Next. Okay, next. इसको थोड़ा सा यहाँ से move कर देते हैं. Okay. Okay, there is no encirclement. But next, okay, if you take the k/5 greater than 1, if this k/5 is greater than 1, means 1 is inside. Okay, 1 is inside. So this means -1, 0 comes inside. Acha, if it is inside, it will be encircled. What is the number of encirclement? Come on, everybody. What is the number of encirclement? यहाँ पे ध्यान देंगे मेरे साथ. Okay, -1, 0 is inside, so it is encircled. See how it is encircled? ये देखना एक बार. This is one encirclement. This is one encirclement. बाबा देखो किस direction में? Direction is also important. So this is one encirclement, clockwise direction. One encirclement, clockwise direction. This is one more. This is one more. Again, what direction? Tadan, clock. I'm moving with clock. This is one more in the clock direction only. Both of the encirclements are coming in the clock direction only. Okay, so I can say that, yes, n is equal to 2 clockwise. Okay, but n has a sign convention, as I told you. 2 clockwise means what is the value of n? The value of n is taken as -2. Okay, the value of n is taken as -2. Okay. Acha. Now, n, as I told you, is given by the p plus minus z plus, assuming clockwise contours, and something is mentioned, n is given to be p plus minus z plus. What is p plus? Number of poles of GSHS. Number of poles of GSHS in the RHP. Plus means right side. How many poles are there in the RHP? 1 at origin, 2 in LHP. There is nothing in the RHP. So from this information, I can also say that P plus is 0. How many poles are in the RHP? How many poles are in the RHP? 0. P plus 0 hai. Okay. So now I'm going to apply the formula. My formula is n equal to P plus minus Z plus. N is P plus is 0, so minus Z plus, and hence Z plus is equal to minus n. What is the value of n? That depends case to case. The first case was k/5. कौन सा था पहला case? k/5 less than 1. I got n equal to 0, and if n equal to 0, Z plus is also 0. Z plus equal to 0, indicating stability. Okay. For the second case, k/5 greater than 1, we have solved for encirclement. Here, how many encirclement? For the second case, the encirclement is -2, n is equal to -2, and the value of Z plus is given by minus n. Okay, that will become +2, and the system is unstable. Z plus is the roots of characteristic equation in RHP, and even if 1 in RHP, system is unstable. Okay, unstable. The system is stable for? System is stable for? I want the range of K for stability, na? For the first case, that is k/5 less than 1, or that is k is less than 5. Of course, by default, k will be positive only. If unless and until mentioned, we take k positive. So k less than 5, so it is between 0 to 5, I can say. It is between 0 to 5. Clear, everybody? The k is between 0 to 5. So देखो, these are two questions individually, both are important. Sketch the Nyquist plot, and दूसरा है given the Nyquist plot, something like this. Okay, determine the range of k for the system to be stable. Determine the range of k for the system to be stable. Determine the range of k for the system to be stable. ठीक है, देखो, if this is clear, I will give you one homework here. एक होमवर्क देता हूं मैं आपको. होमवर्क्स करने के लिए हैं, just not noting down. Nyquist plot has been given to you. The Nyquist plot for open loop transfer function GS of unity feedback system is given. What is the GS? That is not mentioned. But one Nyquist plot is given to me. If GS has no pole in the right half of the S-plane, then the number of roots of system characteristic equation in the right half of the S-plane. You decide what to do. Homework for you. This one is homework for you. Nyquist plot is given so you can see how many encirclements of -1, 0 if required. Okay, do it. ये कर लेंगे आप, because we have other important things to discuss, but this is easy. We have discussed about the formula. N equal to p plus minus z plus, or n equal to z plus minus p plus. As I told you, depends on anti-clockwise Nyquist path or clockwise Nyquist path. Okay. Now, what is p plus basically? What is p plus? P plus is, as I told you, let me write down again, number of open loop poles, that is poles of GSHS in RHP. ये fix है. P plus is known as the number of poles of GSHS in the RHP. P plus is known as the number of poles of GSHS in the RHP. ठीक है. Now, what is N and what is Z plus? What is N and what is Z plus? So if you see the encirclements of the actual origin, what is the actual origin of coordinate system? 0, 0. If N is the encirclements of 0, 0, okay, then Z plus is known as the number of zeros of GSHS in RHP. Plus means RHP. Then it is the zeros of GSHS in RHP. Then it is known as the zeros of GSHS in the RHP. Then it is known as the zeros of GSHS in the RHP. ठीक है. Z plus is the number of zeros of GSHS in the RHP. ठीक है. That is the Z plus, okay? That is what is known as the Z plus. Number of zeros of GSHS in the RHP. Okay, but this is nothing to do with stability. But this is one mathematical point. Why? Again, I'm telling you, any detailed about Nyquist stability criteria, derivation, if you want, you can go through this video, but end moment may not be required. You just focus on what we are revising today. Okay. But then eventually, if N, you look into the encirclements of -1, 0, like we have done, then you want your desired parameter, then Z plus is known as number of zeros of what? Of 1 plus GSHS in the RHP. Now, zeros of 1 plus GSHS in RHP, that is 1 plus GSHS equal to 0, means Z plus will be roots of characteristic equation. For stability, what is important is roots of characteristic equation. That is why whenever it is a stability problem, we represent us and we always check the encirclement of -1, 0. But mathematically, suppose if they ask zeros of GSHS in RHP, then encirclement of 0, 0. Then encirclement of 0, 0. Okay. Okay. Correct, Varun, in a sense. Okay. Correct in a sense. Yes, Jashwant. See, what is P plus? I'm telling you. P plus means the number of poles of GSHS in the RHP. Now, how do we draw the Nyquist contour? Nyquist contour is also drawn so that it covers the entire RHP. So that matches up. Correct, Varun? Okay. That matches up. Correct. That is actually the background. That is correct. Chalo. I'll take one question on this statement also. पहले इसको बता दीजिए. चलो. One more polar plot example. One more polar plot example. 1 upon s plus 1 s plus 2. Polar plot बताइए इसका. 1 upon s plus 1 s plus 2. Tell the polar plot for this one. Tell the polar plot for this one. So let's do it quickly. But the very important point you will note here is n is equal to 0. There is no poles at origin. So dear, what happens at n equal to 0? What happens at n equal to 0? So whenever n equal to 0, I already gave you some conclusion. During I was explaining the procedure for polar plot, I told you that whenever n equal to 0, polar plot starts, okay, from positive real axis. Correct. It starts from positive real axis, and that too with finite magnitude. What finite magnitude? वो भी बता देंगे अभी. Okay, not required, but that also I will tell you. Okay, with finite magnitude. अच्छा. Then what about the theta diving? That is minus 90 degree into total number of poles minus 0. Total poles are 2. There is no 0. So this is minus 180 degree. So diving will be minus 180 degree. Okay, starting will be from positive real axis with finite magnitude. Positive real axis with finite magnitude. Positive real axis with finite magnitude. Okay, have a look into it. Okay, so diving, dive into origin. Diving bole to dive into origin. Okay, along minus 180 degree. Minus 180 is negative real axis, but starts from positive real axis with finite magnitude. Positive real, अच्छा finite magnitude starting मतलब s equal to 0. Okay, this is 0, this is 0, so magnitude will be 1 by 2. Finite magnitude 1 by 2. Okay, 0.5. Okay, so if you want, you can specify this magnitude is 0.5. So this is the point 0.5 comma 0. Okay, and you just have to connect these 2 points here. This is what it is. Okay. If I ask you to complete the Nyquist plot, then if I ask you to complete the Nyquist plot, then तो Nyquist plot के लिए क्या करना है? Mirror image. One more additional point. So dear, this is the starting 0 plus. Okay, this is the diving infinity plus. Take the mirror image. Okay, this becomes 0 minus and this is infinity minus. Arrows बनेंगे infinity minus to 0 minus. 0 plus say infinity plus. Okay. This one is the polar plot, and then next step is mirror image. And I have drawn not only the Nyquist, I have drawn the complete, not only the polar, I have given the complete Nyquist also. Achha, I told you 3 steps for Nyquist. Polar plot, mirror image of polar plot, and closing from 0 minus to 0 plus. Where is the step number 3 here? Dear, when n equal to 0, what is the closing angle? Bataiye. If n is 0, closing angle is also 0. If closing angle is 0, means they will be automatically joined. Now you don't need to move even an inch. You don't need to move even an inch. Closing angle is 0. And you see here, when you take the mirror image, Baba, when you take the mirror image, 0 minus 0 plus is joined. 0 minus and 0 plus is joined. Clear? Okay. Acha, this is known as what? This is known as a critical frequency. Okay, why critical frequency coming up? Why critical frequency coming up? When you take the angle, na, tan inverse omega by 1, tan inverse omega by 2. When you expand, okay, 2 tan inverse term, 2 tan inverse term, 2 tan inverse term. So that is why critical frequency is possible. It is possible for 2 or more tan inverse term. Okay. Then you can apply a stability check nahi kar rahe, but you can apply n equal to p minus z, etc. Okay, this is one case. Heart shaped. Okay, we got something as heart shaped. Okay. Next. sketch the polar plot. पहले polar पे करते, then let's see if we want we can go for Nyquist as well. S minus 2 upon S square, S plus 1, S plus 3. बताइए. S minus 2 upon S square, S plus 1, S plus 3. Please take care of the fact that there is a 0 in RHP. Please take care of the fact that there is a 0 in the RHP. Clear? Okay, so we are at 192 likes. It's evening. Show your freshness. Let's hit the double century quickly, yaar. Before we complete the problem, at least this Nyquist polar plot problem. Okay, let's target double century, guys. It's evening. It's morning to evening, non-stop. Almost 7 hours done. Okay, let's time to hit the double century. Time to hit the double century at least, yaar. It's going on like a test match. So slow run rate. Slow run rate. Okay. Okay, the polar plot. Now, first of all, okay, what is the value of n? It is equal to 2. Okay, of course not equal to 0. The polar plot will not start from real axis. From positive real axis, it will start from infinity. Polar plot, we should know that it should start here from infinity. Start from infinity. With what angle, with what direction? Minus 90 degree into n, that is minus 180 degree. Negative real axis. Negative real axis. Okay. Now, is it correct? No, theta st में change होगा, sorry. Okay. With how much angle? With how much angle? Theta st minus 90 degree into 2. Okay, but there is a 0 in RHP, and I told you if there is a pole and 0 in RHP, diving will not change, but starting will change. 0 in RHP plus 180 degree. Okay, so this becomes the 0 degree. Theta st is known as the 0 degree. Okay. Theta st is known as what? Is known as the 0 degree. Is known as the 0 degree. Okay, ये हो गया. Okay, now what about theta d? Theta d, same formula, unaffected, minus 90 degree into total poles 1, 2, 3, 4. Okay, so there are total of 4 poles. Minus 1, 0 is there. So the diving is minus 270 degree. Diving is minus 270 degree. चलो बना लेते हैं diving को. Starting 0 degree, positive real axis, diving minus 270. Minus 270 means positive y axis, 90, 90, 90 ऊपर आ गए clockwise करते हुए. Okay, तो diving has to be here. Okay, diving has to be here. Starting यहाँ show करना है. How the plot will look like? How the plot will look like? It is going to look like something like this approximately. There will be 2 critical frequency. How to calculate critical frequency? I have told you the method. Tan inverse के form में simplify, numerator, denominator equal to 0, but not required right now. Okay. This is what it is going to be. This is what it is going to be. This is the approximate shape that is going to be. Chalo. Shall we attempt the Nyquist also? इसका Nyquist भी complete कर लें क्या? Shall we attempt Nyquist also? Chalo, let's do it. Why wait? Why wait? Let's attempt the Nyquist also. Mirror image. Procedure is mirror image. Okay, so take the mirror image of this first of all. About the real axis, carefully. Take the mirror image about the real axis. Okay. Okay, now this was our starting of the polar plot 0 plus. Okay, so this is the mirror image 0 minus. ये इसका diving था infinity plus. This is the reflected infinity minus. And now 0 minus to 0 plus through. 0 minus to 0 plus through an angle of. Through an angle of. Hey, what is going to be the closing angle, dear? What is going to be the closing angle? Because n का value 2 है ना, यहीं पे लिख देते हैं. What is going to be the closing angle? It's going to be 2 pi and closing angle is clockwise. So 2 pi clockwise. 2 pi clockwise. अच्छा, clockwise. 0 minus से 0 plus कैसे join करेंगे? Will I go like this? If I go like this, I am going anti-clock. Stop, 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 stop. If I go like this, I am going anti-clockwise. I have to go clockwise. I have to go clockwise. Okay, so clockwise means I start from 0 minus something like this. Okay, yeah. I start from 0 minus. Clock के direction में चलना बहुत ओहो. Through a circular arc of infinity radius, I come and join 0 plus. Okay. नहीं 0 minus है ना, 0 plus से क्यों करेंगे? We have to join from 0 minus to 0 plus. Okay. Now I will complete the arrow. Okay. Infinity minus से चले 0 minus. 0 minus से चले clockwise direction. Zero plus to infinity plus This is finished. Starting point is at infinity direction, na Ananta? It is not at finite direction. Infinite direction only. This is the complete Nyquist plot for this one. Okay, ji. This is the complete Nyquist plot. What about stability? For stability, you have to check where is minus 1 comma 0, whether it is coming here or here. Okay, that you have to check first of all. 0 degree means positive x-axis. That can be towards infinity also, na? 0 degree is positive x-axis, but what is the positive x-axis? It can go till infinity also. Finite magnitude tab aayega when n is 0. Very clearly I told n not equal to 0, it definitely starts with infinity. Finite magnitude for n equal to 0. Yes, so stability minus 1 comma 0. For that we'll have to do some more calculations like where is minus 1 comma 0 and etc. Chalo, theek hai, so that we can do. Nyquist contour nahi, Nyquist plot should be given. Only Nyquist contour say you can't conclude, na? Transfer function may not be given, that is okay. But at least Nyquist plot is given. Never on something like this. ये जो मैंने आपको homework दिया, something like this. Aptitude is on app. I'll share you the link in Telegram, don't worry. How to join the aptitude marathon, I'll share you the link in the Telegram. Okay, so here Nyquist plot is given, GS is not given, still you can work out on stability. Okay. Chalo, one more. A unity feedback control system is characterized by the open loop transfer function. Okay, is characterized by the open loop transfer function, which is wrong here. Just wait a second, hai na? It is wrong. बार बार typo error आ जाता है. It's a gate 17 2 mark important conceptual question. Just let me check it out once, है ना? Here Nyquist plot and Nyquist contour both are given, है ना? Just let me check the correct data, guys. just check and update you. I'm downloading the original file. Yeah, it is basically, I've got the original file. Okay, open loop transfer function is given to you GS equal to 10k s plus 2. Okay, upon SQ plus 3s square. SQ plus 3s square plus 10. SQ plus 3s square plus 10. ठीक है? All right. Chalo. Thank you guys. Thank you all for your love. Sure, it definitely appear in the gate. We'll definitely plan to do your best. We'll plan to meet then. Okay, chalo, let's come up here. 10k s plus 2 upon SQ plus 3s square plus 10. Okay, unity feedback system is characterized by this open loop transfer function. Nyquist path and the corresponding Nyquist plot of GS are shown in the figure below. For 0 less than k less than 1, you mentioned it. Okay, 0 less than k less than 1, the number of poles of the closed loop transfer function. Okay, they are talking about number of poles of the closed loop transfer function. Okay, that lie in the right half of the S-plane. What is the meaning of this? Poles of closed loop transfer function means roots of characteristic equation. Means roots of characteristic equation. Roots of characteristic equation in RHP means Z plus. Okay. Okay, Z plus for which encirclement? Dear, I told you two cases. We have to talk about minus 1, 0 encirclement. We should talk about minus 1, 0 encirclement. Minus 1, 0 encirclement. You have to find the Z plus. Okay. For minus 1, 0 encirclement, have a look into it. Okay. Now, the Nyquist path. This is the Nyquist path which is given to be completely clockwise, as you are able to see here. Clockwise Nyquist path is given to you. Okay. So, we know the formula to be applied is P minus Z, because of the Nyquist path which is clockwise. Okay. Now, what is the number of encirclement? K less than 1. Dekho. K is less than 1. And this point is given to be minus K. Hope this is visible to you. This is given to you as minus K. Okay. And K is less than 1 basically. K is less than 1. So, this simply means that because K less than 1, okay, so minus 1, 0, okay, will it be inside or outside? That is outside by minus 1, 0. Bahar aa gaya, K less than 1 hai. Okay, so number of encirclements is not here. Number of encirclements is not here. Number of encirclements is 0. Number of encirclement is 0. Yeah, I know red colors have come up wrong today, but theek hai, you can manage it, okay na? The number of encirclements is 0. Okay, this point is minus K. Isko thoda aur better likh deta hu main. This is given to you as minus K. Okay. So, number of encirclements is 0. Acha. Now, what I am telling you is number of encirclement is 0. That means P plus minus Z plus is 0. Again, let me repeat that because it is the clockwise Nyquist contour. So, N formula that to be used is P minus Z. Okay. Okay, P plus minus Z plus. So, what is Z plus is P plus. But dear, what is P plus actually equal to? What is P plus actually equal to? What is P plus actually equal to? P plus is known as the number of poles of GSHS in the RHP. P plus we know is number of poles of GSHS in RHP. Yeah, simply GS in RHP because it is unity feedback. Number of poles of GS in RHP. Ab dekho, there are two ways to derive. GS is given to you. Calculate the poles of GS in RHP, but it has a cubic denominator. It has a cubic denominator. That means you can't directly determine the poles. You have to go for RH criteria. You have to go for RH criteria. Okay? You have to go for RH criteria. Okay, so method number 1 to calculate P plus, I think even my board is now tired, it has started hanging. Okay. Method number 1, you can directly obtain it by the RH criteria. You can directly obtain it by the RH criteria. Thank you all of you for your love. Okay. Method number 2, now RH we all know there is nothing new in RH, na? RH to humne pad liya hai. Let us talk about something new. Method number 2, okay, use n is equal to P plus minus Z plus, okay, for 0, 0 encirclement. Let us use the concept of 0, 0 encirclement. थोड़ा सा नया concept देखते हैं because RH is anyways known to us. Okay, RH is anyways known to you, so let's learn something new. Okay, now how many encirclements of 0, 0, dear? How many encirclements of 0, 0? 0, 0 is origin, it is here. It is here. So this is one encirclement, clearly anti-clockwise, and there is one more outer encirclement also. That is also anti-clockwise. Boliye. Okay, there are two encirclements of the origin and both are in the anti-clock direction. Both are in the anti-clock direction. Okay. So, with respect to 0, 0 encirclement, n is obtained as 2 anti-clockwise, means it is plus 2. Okay. So, n equal to 2 will be P plus minus Z plus. Achha, what is Z plus? Now, for 0, 0 encirclement, Z plus is known as what? Z plus is known as number of zeros of only GSHS. Number of zeros of only GSHS in RHP, and dear GSHS given hai. Dear GSHS given hai. How many zeros in RHP? Nothing. S minus 2, there is only 1 0 in LHP, there is nothing in the RHP. So that is obtained from the given question only. Okay, so Z plus is 0. So hence P plus is equal to 2. You can obtain from RH also. Okay, अब अगर P plus 2 आ गया है, okay, तो Z plus equal to 2. Okay, P plus obtained as 2, so Z plus will also be 2. Z plus will also be 2. That is the answer. Okay. Now this Z plus is the Z plus, okay, for 0, 0, for minus 1, 0 encirclement. That is the zeros of 1 plus GSHS. That is the roots of characteristic equation. That is the poles of closed loop transfer function. जो बोलना है बोल दीजिए. Answer is C. The correct answer is C. ठीक है. अब थोड़ा सा और smart approach बताता हूँ. I explained you this approach for concept. भाई concept के लिए बहुत अच्छा ये समझना when to use 0, 0 encirclement, when to use minus 1, 0 encirclement. Okay, so the entire previous approach that I told you, okay, it is good for concept. भाई concept के लिए बहुत अच्छा है. अब देखो, what is one smart approach here? You can solve the entire problem, not only P plus. You can solve the entire problem by RH. बाबा अगर थोड़ा सा common sense लगाओ, you are given the GSHS. Okay, usually this is not given, then we should refer to the Nyquist plot, na? Baba, you are given GSHS and they are asking the poles of closed loop transfer function, so you can directly apply RH. No need of even a single step of Nyquist. Bhai, what is the characteristic equation? 1 plus given GSHS. What is the given GSHS? एक बार फिर से देखता हूं, मैं भूल गया. That is 10k s plus 2 upon, okay, 10k s plus 2 upon s cube plus of 3s square plus 10. ये आ गया s cube 3s square. Okay, 10k s पूरा rearrange करके final लिख रहा हूं, and then this will be 10 plus 20k. 10 plus 20k equal to 0. Okay, ये लीजिए entire RH on the entire problem. Okay, so 1 and 10k. This is known as 3 and 10 plus 20k. So s power 1 cross multiply 30 minus 10 minus 20k, so that is going to be 30 minus 20, 10k, minus 10 by 3, last element 0, s की power 0, x into k by x, तो 10 plus 20k and 0. आपको बोला है k less than 1, आपको बोला है k less than 1, so this will be negative. Why this is negative? Because k is less than 1. So if k less than 1, 10 को common ले लीजिए, तो k minus 1 negative आएगा ना. Okay, k minus 1 negative आएगा. So you are given k less than 1. So this is going to be negative. So you have a sign change, you have a sign change. This is plus, this is plus, this is minus, this is again plus. 10 plus 20k, k is positive, but less than 1. So there are two sign changes. बताइए, two sign changes. So answer is 2. Only this much approach. For this, we don't need anything of Nyquist plot. Neither 0, 0 encirclement, neither minus 1, 0 encirclement. I explained you the previous approach. I wanted you to fit the concept within the mind. But actually, it's a simple, smart approach. Common sense apply karo. Whenever GS given and they are talking about stability. Remember always, whenever GSH is given and they are talking about stability, go for RH. Simple. Very simple, because that is a straightforward procedure. You can go for RH. That is a very simple and straightforward procedure. उसमें कुछ आपको टेंशन लेने का ही नहीं है ना. उसमें आपको टेंशन लेने का ही नहीं है. Do you not take any tension there. You're not supposed to take any tension there. Okay, guys. Okay, so it's more than 7 hours and I need to stop. I have another engagements also. I know we haven't completed, but like digital, I told you, whatever best and important we can do in 7 hours, it's actually more than 7 hours I'll be doing. I don't want to rush up through the things. The another way is in 7 hours I can complete. Even in 6 hours I can complete just formula. But that will not be that effective. वो उतना effective नहीं होगा. Okay, so we are not going with that formula, but we are understanding the things also. Okay, so we have covered time response analysis, steady state error, Routh-Hurwitz, root locus, Nyquist. I think good. Okay, good. Okay, I have some other engagements. I cannot at any cost move forward. Let's see, if you want, we can plan up later on. Kabhi discrete session le lenge state space ka ya mode ka. Okay. So tomorrow, guys, now you will have network theory by Ishan sir, same time 10 a.m. Come and revise the complete network theory. Okay, at 10 a.m. Come and revise the network theory tomorrow at 10 a.m. And then next day communication power system, etc. Okay, now please tell me, how many of you are actually attending this quiz? If you are not attending the quiz, we can stop it also. With respect to the marathons, we are also giving you the quizzes. Okay. We are also giving you the quizzes, daily quizzes. Okay, what about the daily quiz of today? You can join using the link. I will share you the link once again. Okay, or you can scan the QR code. But let me see how many of you join the quiz. Let me see how many of you actually join the quiz, guys. This is the link for the quiz. You can directly click and join. Okay. Because we will see, I'll just look into the data after 1 or 2 days. If you are actually attempting the quizzes, then it makes a worth. Okay, then it makes a worth. Okay, so I have to ask the content team to make a quiz, upload on the app. These are additional quizzes rather than the test series you have, and these are free quizzes. So the link is given to you. Click it up right now. Okay, so that I can analyze how many of you are actually willing to go to the quiz. Okay. ठीक है. So let us see. This is the link of the quiz. Everybody please open so that you can save the link at least. Because if most of the people don't go, then there is no point. I have to separately ask the team to make quizzes, upload on the app, and then we are sharing the link like this. Then we can only have class. So link is given to you. Please do open it. Please do open it. Everybody right now. Humble request. Please do open it right now. Or you can scan this code as well. And guys, this is what it is. Okay, Saturday, Sunday. Now I see you on Saturday. Okay, 13th and as well as Sunday, 14th January. Okay, timing, we'll keep the fix. We'll start again at 10 a.m. dear. Let's start at 10 a.m. Okay, exclusively on the BYJU'S exam prep app. Okay, the revision of general aptitude, the revision marathon of general aptitude. And if you want the complete strategy of general aptitude, Okay, how to score 15 out of 15. So tomorrow, Thursday, I will be having. Tomorrow night in the YouTube, I will be having that session. That is YouTube. But the complete revision class of aptitude will be on the app. Now, how to join this app? You come to the general session tomorrow. Tomorrow, first, we are discussing aptitude. What to do in the last month, what not to do. How to manage aptitude. Okay, how to manage aptitude. Tomorrow, I think 8:30 or 9 p.m. we will have the class tomorrow. That will be on YT only. Okay, there I will tell you what is the aptitude link, how to join and etc. And so that you can directly come up there. ठीक है? Okay जी. Chalo guys, so see you tomorrow 9 p.m. Tomorrow 9 p.m. कल का link if you want, I'll share you the link for tomorrow's aptitude session. Dear, this is the link for aptitude strategy session that I am having tomorrow. I think the time is right now showing 8 p.m. but 8 p.m. nahi hoga, dear. It will be 8:30 or 9. I will update you. Just click to the link. You will get the notification. We'll have it 9 p.m. only because 8 p.m. I'm already busy with some another class. There is some confusion. Okay, so that is the link of the aptitude class. Okay, that is the link of the aptitude class. You can click. Tomorrow, let us discuss the strategy for 15 out of 15 and then how to join the session. I will tell you there only. I'll tell you there what is the link for the session. But the session tomorrow will be 9 p.m. 8 p.m. I'll be busy in some another class. Okay. So you will get the today's PDF, guys. I'll try to share you by night. Today's PDF, password protected password. Already told, not repeating now. Password was already told. So see you now tomorrow with the aptitude strategy session and then Saturday, Sunday, aptitude marathons. Okay, then next week I will be taking EMT and signals also. Abhi weekend pe aptitude hai. Next week my targets will be EMT and signals. By the time tomorrow network theory is there. Okay, so chalo guys, bye bye. Thank you. Stay safe. A very good evening everyone. Have a cup of tea, coffee, whatever. Refresh up yourself and attempt the quiz. Bye bye. Thank you. Stay safe and take care of yourself.